big shout out to House of ZK for hosting this event and for doing all the different types of podcast and information things. That's really helpful.
Really excited by what House of ZK is putting together. I think ZK is going to eat the world.
Warm thank you to the House of ZK. I feel like there's a lot of synergy in the missions of the two projects.
One thing I wanted to plug real quick is the House of ZK eProof Summit event, which is happening in Berlin very soon, June 10th. I think it's going to be a fantastic event.
Yeah, thank you.
We've seen a lot on Twitter of House of ZK over the last several months, and we're very excited to finally be on.
Yeah, absolutely. And thank you so much, Shorty, for joining us on our House of ZK podcast. Yeah.
I mean, I was excited for another dedicated ZK podcast is awesome. We need more of this stuff. So guys, awesome job. Thank you for doing this.
So very excited to be here. ZK is one of the topics that actually got me into Ethereum, and it's something that's very close to my heart.
Thank you, Ming, for having me here. Thanks to all the audience, and really great to be here.
And also I want to mention a big thank you to Ben from House of ZK and ZKM for organizing this entire conference. We wouldn't have this without him, so really appreciate his work in here.
If you guys have the magazine that was printed by House of ZK, there's actually a very nice image on the Bob side that actually explains how BitVM works.
This is just a great fun series where we are going to explain ZK in an as intuitive manner as possible.
That wraps up our coverage at NorCon. We're in such a great time to be able to see this transition from theory and research to building real applications.
The next chapter of AI should be defined not by how large model is, but how human aligned it is.
Black box in control of just the hands of a few. With AI makes it an intelligent asset, owned by all of us, learning from all of us, governed on-chain, transparent, monetizable, and accountable to human according to human values.
Then the data being trained, a small model by the community is the way to go. So this is, I see the Web3 and AI convergence from all massive point of view.
Breaking news tonight from Pandaro, where GPT rate limits have been mandated. This is a developing story.
Concerned about fake identities, fraud, or privacy leaks in Web3? Discover Ontology, Web3's trust layer. Trust starts with decentralized identity. OntID uses zero-knowledge proofs to verify credentials without compromising privacy. Power your Web3 journey with Onta Wallet, securely manage assets and identity. With Orange Protocol, leverage zk-TLS tech to build Web3 reputation. Join Ontology's Web3 revolution.
terms of sort of ZK endgame, in my opinion, most execution is going to move to ZK for all sort of distributed systems or blockchains.
I think directionally, I think you're right, Alice, that snarks are going to eat the world. And right now, the blockchain industry is willing to invest, the hundreds of millions of dollars to make this a reality. But ultimately, many other industries are going to reap the fruit.
The end game is probably like, imagine a CPU device. You have 1% of the CPU chip area that is doing the typical CPU workload we're doing now, while you have 99% of the CPU area doing ZK compute. In that way, every instruction computed on that CPU device is ZK verified automatically.
What ZK can do to this industry is it can make it extremely efficient and extremely time efficient, cost efficient, and not prone to errors. ZK will become more widely accepted than blockchain.
Everyone, like everything is ZK. ZK is the end game.
I do think that we're going to see a lot of infra converge to provable VMs, also known as ZK VMs. Depending on the use cases, they might be adapted, but overall, I think we're going to see a shift from low-level circuits to ZK VMs.
So there's so many things you can squeeze out of ZK, and it just gets better when you combine these other tools.
We can use our knowledge in ZK to build these applications on Bitcoin, which may help Bitcoin make Bitcoin maybe 100% use the only blockchain again in the world, because Bitcoin is the best monetary asset that we have. Bitcoin blockchain is the most secure blockchain that we have.
I will say that the boldest prediction though is, and it's not me making this up, a friend of mine, Vinishri Rao, she's I think a famous cryptographer. You guys probably know her. She's launching a Fermat network, and she's been out there publicly saying that her prediction is that ZK is going to replace blockchain.
You have the code, you have the input, which is all the transactions, and you put that in. You create statements and you generate proofs. There is no component whatsoever of blockchain, but ZK is a component, and this is an example to explain also my thesis that I think ZK will become bigger than blockchain.
Support us. We have Visionaries, Ontology, Zero G Labs, Laz AI, Gonka AI, and AltLayer with us. So today's program, just to give some context, runs across three very interconnected verticals. So we have AI, ZK, and also ZK and AI, featuring a full day's programs worth of keynotes, technical talks, and panels, and also interviews with all of the leading founders, and researchers and builders who are in the space. So together, we will map out the state of ZK and AI and also explore their convergence, their intersection in what we call verifiable AI. So our motivation for this event is simple, but also urgent. Our AI systems need verifiability. AI is advancing very rapidly, especially within the past few years, but without any guarantees on model behavior, data provenance, even on the inference level, trust becomes very fragile. So that's where ZK proofs come into the picture, which offers tools for verifiable compute and also accountable pipelines. So this program builds on the momentum of House of ZK and Lagrange's ZK and AI Summit in Dubai back in April. So that event drew thousands of attendees, hundreds of thousands of virtual viewers as well. But 4 months later, here in Singapore, for this Token 2049, our goal is to really assess what's shaped since then and align on our priorities for our near-term deployment. So thank you all for joining us as we explore the frontier of where ZK meets AI. And let's begin with our opening keynote by Shubho, who is head of Web3 and AI customer engineering at Google Cloud, on the state of ZK, present and future with AI.
New technologies here, right from Web3, AI, ZK, and so on. Thanks for braving the traffic. Monday morning, let's get started. Next one. I got a very interesting question as I was coming in. So what is Google doing at Web3 and AI? I thought let's upfront share with you what we are doing in this exciting space. So 3 things here. We are developing great Web3 products, and I'll talk a few things as we go along today. We are also providing the 3 key elements of efficiency, reliability, trust, and security. So those are what makes the underlying ecosystem of the blockchain infrastructure work. And what we are doing is not just developing a great bunch of products on a secure infrastructure, but we are also helping build the ecosystem of developers to make it easy for people to use. Next one. So here are the 3 core tenets of our strategy. The first one is where we are looking at the foundational infrastructure. When we look at enterprise-grade planet scale infrastructure, so that as you are doing your ZK rollups, we want it to be efficient, we want it to be fast, we want it to be the next level. That's what we are doing. The next, what we are doing is putting in confidential compute. So in the runtime, we are trying to secure it to make sure that you're not getting compromised. And specifically on this, we have developed a great Web3 portal. I would encourage you to go and see it. It has a lot of on-chain intelligence where we have an open dataset program. So all your chain transactions, whatever is publicly available, is very easy to explore there. We are also developing market-leading faucet integrations with 25 different chains. And we also have a great RPC product services, which helps you leverage your chain. On the second note, we are driving a lot of innovation in Web3 through AI. And there are a couple of examples here. One is our foundational models, which is Gemini, which is our first-party model, as well as we have created a model garden where you can also use some of the very commonly used open source models like Llama, DeepSeek, and so on. So it gives you developers a choice. How do you want to bring AI back into the Web3 ecosystem? And then as we roll forward, there's been a lot of excitement around what agents can do or what AI agents will be able to do. So there are ADK, which is the development kit, which makes it super easy for developers to start using it, as well as deploy it on an agent engine, which is a managed service, so that you don't have to manage all this infrastructure. And we are also doing a lot of exploratory research on bringing in the payments on the A2K platform, where we are able to integrate it with different kinds of stablecoins. So it makes it super easy for developers to go ahead and use it. The third tenet is a very important tenet for us, which is the whole area around security. So it's not just your on-chain security, but your off-chain transactions. That is where most of the vulnerabilities start. So what we do is help you with a whole array of technologies that help you secure this infrastructure. Specifically for Mandiant, which is one of our retainer services, we have helped different organizations manage attacks to the extent of $3 billion US. And then we have packaged all these understanding that we have. By the way, we have a specifically designed task force only to secure Web3 assets. And these are some of the tenets of the task force. So these three are the pillars that we help you, whether chains, DeFi's, protocols, what are you, to help you run and then distribute it to your developer ecosystem. Next slide. Next. Now let's deep dive a bit more into what we are doing in the ZK space. The first one is our foundational research. So Collabs, we have been investing into ZK research for more than 2 years now. We are defining unique different systems. There's a lot of research that goes under it. And many of this research, we are also writing papers so that you as developers have better access and reach. The second core one is our applied use cases. So what we are doing is using some of these ZK concepts to help identify new use cases, examples of that being identity systems. This next level is where we are working and optimizing our infrastructure to work along with the accelerators. Examples like the GPUs and the TPUs, which are typically used in the AI world, how can we use that high performance infrastructure for ZK rollups, for example. The next one is scale. So what we are doing is scaling up this infrastructure. So as ZK rollups happen, we want to seamlessly scale it up to literally thousands and thousands of nodes in a rapid space. That's what we are doing using our scale. On the security side, along with our Mandiant suite of solutions and products, we are able to secure this as we roll up. And then finally, optimize performance. So where we are right shaping your VMs, where it's not like ticket sizes of 4, 8, 16, 32, what have you, but exactly giving you the VMs that you require for doing your rollups. Your third one is where we build the ecosystem. So we conduct the largest ZK summit. It happens typically once a year. We bring together researchers, enthusiasts, developers, protocols, all under one roof to look at what's the state of ZK and where's the future going to head. We also do a lot of thought leadership by co-scribing different white papers, articles with some of the thought leaders in this domain. So these are the three tenets of what we work in. Next slide. Let's dig a bit deeper. So these are some of the protocols that we work with, like Polyhedra, Immutable, Polygon. In fact, with Polygon, we co-developed and help them develop the ZK VMs. And I'll talk a bit more about what ZK VM is and share the stats with you. Next one. Next. Now, our goal with Polygon was to take ZK to the next billion users. And here are a few very, very exciting stats that we ran and benchmarked with. Next one. So before I get into the actual benchmark, I'll break it down into 3 layers. So these 3 layers are the layers of where cost performance is actually driven. The first layer is a layer of orchestration, where we are basically breaking down the tasks, helping them massively parallelize, roll up, secure them, and then also make sure that we can do exception handling at each of these tasks. So the first layer is a layer of orchestration. The second layer is where actually the proving systems like the ZK EVMs and other things come into play. And the third layer is the high performance infrastructure, whether it's VMs, CPUs, GPUs, TPUs, what have you, depending on that task, we have the appropriate underlying infrastructure to make it happen. With this background, let's move to the next one. Next slide. These are boiling down to those 3 facets. The first facet of ZK VM, which is from Polygon, first was the custom VM. So instead of like having a massively oversized or undersized VM, we were able to right size it with the absolute number of cores and the memory that's required, which was suited for that specific task. So it's a custom one. It's not like a t-shirt size, it's custom made for that rollup. The second one is scale. So as we do the rollup, we are able to scale 3 times higher than everything else that was available with them for that time. And third was using a high performance database, Alloy, which is compatible with Postgre, so that we have 2x the performance compared to our next available competitor. So it has massive throughput, massive node pools, making sure that we give you that planet scale infrastructure that you require. So these were the 3 facets that we benchmarked on. Next one. The second layer was the layer of security hardening. The security hardening, the first step was scan before you ship. So obviously, we are trying to make the vulnerability protection right at the source. Second, what we are doing is, as changes can happen, we are just wanting to make sure that you have the right digital signature so that you're always using the right VM. And the third one was giving a comprehensive dashboard, one single view, where you can manage this whole ecosystem through the click of a button. Next one. With our partners, we developed this tooling with BCW here, where you see some of the test results, like what's the gas fees, what's the average number of transactions, how many nodes, how many explorations, and so on. So we are happy to work with you if you are interested in developing this performance dashboard so that you can actually measure the performance of your underlying ZK system. I'll take a pause here. This was where ZK was, past and present. Now let's fast forward to the future. Next one. This is where a very interesting cross-section of where AI meets Web3 or where Web3 meets AI, depending on where we look at it, goes. Next one. If you can keep building on this. Keep building on this. Yeah. So there are two different aspects here. One is AI for Web3, which is making use of AI technologies so that it's super easy for Web3 protocols, Web3 developers, Web3 ecosystems to start using it. The other interesting cross-section is where Web3 comes into AI, where it is building trust, transparency, security, and so on. And these interesting confluence comes together and creates this agentic future for us. To build an agent, you have to make sure that it's intelligent enough, it's smart enough, developers can use it, there are interesting use cases there, and at the same time, it builds the trust and transparency with the people who want to use it, or verifiability as we call it. So this is where the confluence of this creates the agentic future. Next slide. Let me give you an example here. Think of it like a crypto agent. There can be two kinds of crypto agent. One is very task specific. So if I give you a specific task, like buy this NFT, and it will go ahead and buy this NFT, which is called what I call a standalone AI agent. Things get more interesting where I don't give you a task, but I give you a goal. For example, was the best yield for 10 ETH. Now, if I were to break it down, I have to break it down into a research task, which is where the planner agent comes into play. The second is an agent that will go down and then investigate at different places. And the third one is an execution task where you can go ahead and then execute. This confluence of three of these different agents working together with a decision making is what the next generation of crypto agents are going to come with. And this is a classic example of where a Web3 and AI come together to solve complex tasks. With this brings me to the end of today. But before my last slide, for fun, next one. While I was developing over the weekend, I was trying out new things. So if you have not tried this out, what you can do is go to AI Studio. That's where you get access to Gemini. Just put this prompt in, upload your picture, and this is what has gone viral on the internet. This is where it just took my picture, a headshot. It created that into a desktop, and then also created something like a Lego box packaging on my screen. And this is the exact prompt that I used. If you want to have some fun, you can always use that. Thank you, and have a wonderful week ahead.
Thank you.
Thank you.
Thank you. All right, thank you so much, Shubo, for the opening keynote. Super exciting to see all of Google's Google Cloud's developments in both the ZK and Web3 and AI spaces. So lots of intersections between all those domains. So next up, we will have our first panel for today called From Models to Agents, the Next Stage of AI Autonomy. So we have Evan, who is CEO of Billions, who will be moderating this panel. And we'll have 4 speakers who will be here. Tom from Metis, Brian from Lagrange, George from Zero G Labs, and June from Gaib. So thank you so much for all of our panelists and for Evan for moderating.
Thank you so much. Hello, beautiful people. Let's see, do I have the rest of my panelists around here somewhere? GM, everyone. My name is Evan McMullen, representing Billions Network. We are the first universal human and AI network built with mobile-first verification, so you can prove who you are. Tom, this is you. You can prove who you are from the comfort of your own device. Let's see if you guys can try to get into the general order of, whatever, it'll work. I think, let's see, are we going to have more than one microphone today, or should we just share this one? Okay, we'll share this one. All right, I think we are now ready to rock. Good morning, gentlemen. How are we feeling?
Great.
Excellent. So to get us kicked off today on our panel, From Models to Agents, the next stage of AI autonomy, I'm going to first invite our panelists to share their names, their roles, and what they are cooking right now. Tom, let's get started with you.
Hi, everyone. My name is Tom.
Trust, safety, and security across AI.
Hello, everybody. My name is George. I lead the strategic partnerships at Zero Gravity. At Zero G, we're building the world's largest AI L1 chain, pioneered through our modular decentralized AI operating system with decentralized storage, decentralized compute, decentralized proving of inferences, and the fastest data availability solution in the entire space. Here and to discuss all the amazing innovations that are occurring within the Zero G ecosystem.
Hello, everyone. This is Jun. So Coney has on my flight issue, so I replace him. I'm the co-founder of Gaib. So what we do is we tokenize AI as a new type of asset class. So we turn the revenue in the AI broad industry, like cloud company, data centers, and robotics company into a yield-bearing asset that people can just hold it and use it in DeFi as a DeFi primitive.
Awesome. Thank you guys so much, and appreciate your constant flexibility and iteration to make sure we have plenty of voices contributing to this discussion today. So to get us started, let's reflect on the evolution of AI in the past few years. It's been about a decade since the chatbot wave popped off, and in more recent times, we've seen static, sort of more fixed models iterate into more autonomous workflows, even multi-agent workflows. So I'm curious how our panelists today see the shift from these more static models to autonomous agents reshaping the experience of decentralized applications in crypto. More specifically, what role does the blockchain, or in the case of Lagrange ZK co-processing, play in enabling that more active, more true agentic behavior? What does on-chain mean for more automated workflows?
I think there has been a quick shift in how AI and actually blockchain interact. From a traditional AI perspective, the market is extremely advanced. You see that with Tesla and their autonomous robots and such, and self-driving. But for blockchain, it's still fairly new. But AI has been around for so long, way before AI was kind of like coined and really a strong narrative now. I think it evolved for the blockchain side from simple chatbots and quickly went away because the I would say entry to barrier is really low. And we're seeing some DeFi trading as well. I think that eventually will also go away. There's no way AI can out-trade, maybe outperform a high-frequency trading firm or quant firm. I think that's a little niche, but maybe from wallet interaction to some DeFi management is the key thing. But there's still a layer of trust and I would say a standard how AI can interact with other blockchains. So that's kind of the key thing. But I think what we're going to see in the next few years is just more advanced trading, more advanced maybe wallet management, very simple things, maybe purchasing some maybe commercial things on purchasing airline tickets with your DeFi or your crypto assets, since crypto is kind of a big thing where we can use it and spend it. And that's still a challenge for our market today, making crypto or crypto assets usable. So I think from our perspective, that's where it's at. But from the Laz AI perspective, I think the data is the key foundation that we really need to focus on. Garbage in, garbage out. I still have challenges with some of the response from AI as well, hallucinating. So imagine people are really utilizing AI for their work. And we recently saw a SEC charge against lawyers for civil lawsuits on how they were using AI. So in terms of what we're seeing with AI and how blockchain interact, I think the data and the foundation side is extremely important.
Yeah, I think when
AI really first started developing, we saw it essentially being a series of inputs and outputs, and then it was up to the humans to take those outputs and take the next subsequent steps. What we're really starting to see now is AI in terms of agents be the autonomous actors to take those steps, still working for us on behalf of humans, consumers, companies, institutions, but there is a degree of control that now is placed with these autonomous agents. And on the Web3 side of things, Web3 is grounded in cryptography. And in terms of where that's applied from the Web3 space into the more traditional world, we've seen a lot of innovations, we've seen a lot of spillover, but when it comes to ZK technology has been used extensively in things like scaling block space, but now we're looking for additional use cases and where we can apply that provability. And really then the merger and the synergy of AI and crypto, especially ZK technology, is where we see a tremendous amount of opportunity and growth. And like any new technology, when it comes out, it's exciting, it's powerful, it's new, but then things happen, negative things happen. And that's when we need to rein it in and make sure that it's mitigated, under control, and has guardrails. So it's really that fusion of this exciting AI technology, which is really still in its nascent state, combined with the provability and power of cryptography and specifically ZK technology that we see as having a very bright synergistic future.
Yeah, so in order for AI to be fully on chain, we at Zero-G had to reconstruct the entire infrastructure. So we started last year with decentralized storage, and we created the fastest cold storage network in the entire space. We get 2 gigabytes per second in throughput. Second, we needed to have fully on-chain AI verified. And to do that, we needed the fastest data availability solution. And our speeds are 5,000 times faster than the current DA solutions. The third component, which is probably the most challenging, is a decentralized compute network. Our compute network works with our service marketplace for a decentralized and fully verifiable inferencing and fine-tuning and data verification. All 3 of those components, we bundled it in an operating system, similar to a Mac OS or Windows OS. You just download it, and you can use any or all of those components. And then we unleashed it to the world, and we have over 400 projects utilizing that operating system to do amazing things. I'll give you some examples. We have DeFi autonomous agents that are actually moving liquidity from pool to pool to maximize yield. In addition, it's part of our decentralized exchange called Zia, and what they're able to do is reduce slippage to 0 and create vaults with maximum APY. That's one. We also have dormant AI working on health data. They're able to aggregate all your wearable data from your Whoop, your Apple Watch, all those things, and they're able to give you actionable insights. We have so many different AI agents, including on the storage side, the security side, more DeFi primitives that are being created by Zero-G because we started from ground zero, where we re-architected the entire storage, DA, and the compute layer. And so now when you see AI agents within the Zero-G L1, you're going to see AI agents that can do things that they could not do on any other chain. And so we just launched mainnet last week. A lot of the applications are going to be coming out soon. So stay tuned. There's going to be a lot of great ways for the community to start participating in these applications early. But the AI agents on chain, there's no better home than Zero-G.
Yeah, so I'm not sure if you still remember like 10 years ago when chatbot first came out. Back then it was just predefined static model, but back then I was doing research on autonomous model already. But it was like, back then the hardware was bad and it was very hard to train a better model. So it's really happy to see we actually passed the singularity point and see more autonomous model right now. And how the blockchain can actually push this further is that's also why we do, and also I do, Skype, because as other shares, other panel shares, like we already have like different types of angles to tap into agents, on-chain verification to actually make the AI model better. And as they were just doing their DeFi on top of the agents application and also other applications, but we are actually lacking of something, still something. It's from the infrastructure part. that's cloud company. Because right now we are lacking of compute, right? We're lacking for data centers to actually provide more compute for people to come up with new idea to have more autonomous model agents. So, but we are not tapping into the compute business directly, as many others are already doing it. So we tap into from the different angle of finance. So it's very similar to like gold mining in San Francisco. Like selling lemonade is also a good business because actually it attracts more people, like solve the real issue of all of the gold miners. So what we're doing is like we provide the capital for this AI cloud company to expand their business so that they could provide more compute for the inventors, for the developers, for other projects to create more DeFi AI models or even DeFi projects. So we tokenize it to solve the issue core in Web3, which is the sustainable yield. There's no yield on chain. There's only like on-chain TPOs right now. So we actually bring the very lucrative revenue stream from the AI cloud company on chain for people to actually own the revenue stream, but at the same time they could expand their data centers like faster. So we actually makes the whole AI industry and the financial industry more efficient. So I think that's how I see the correct marriage between Web3 and AI.
Okay, so we've talked a lot about the promise of these technologies, about the immediate opportunities that are now available because of all of your team's incredible work. Now let's talk about the hard stuff, right? We live in a society, there are rules, and we are starting to bump up against those. For example, in the United States, 7 AI companies are now under fire from the FTC because they failed to implement age-based access control, letting children access all sorts of content from autonomous or AI, enabled experiences. We also are starting to see impersonation agents that are pretending to be someone else, which of course is a challenge if we are allowing them to access funds. So tell us, what is one of the more challenging roadblocks that you guys think about with your teams, whether that's regulatory or functional, and how are you tackling that together?
I think what we're seeing in the industry, how AI is also following the traditional blockchain evolution as well, from cross-border kind of regulation to personal identification, KYC, KYB. We can't escape that. But if an agent can fully interact cross borders on your behalf on doing transaction, how do you regulate this? So I think this is a big tackle. We're still kind of finding the way with blockchain itself and how we really interact and the regulatory kind of stance. Even for our foundation, where we have assets listed on different exchange, each exchange has different kind of regulatory rules. I think agent is actually, it's still very early, and all this is actually going to evolve, and it will definitely shift the way we as organization and builders direct our product or how we build our product. Who becomes responsible? The agent that launches or the company that create the platform where the agent launched? So I think there's still a lot of risks, but we have to really clarify what the rules are. Once we know the rules, then we can navigate the space a bit. But the only challenging thing is each country has their own view. Like you say, privacy, right? Like in terms of the age side and the parental control, I think that's very, very interesting. And that didn't really cross my mind because we're thinking about the financial side where you have different licenses. And if you're interacting and you're in charge of your agent, do you become responsible for its behavior as well? So those are the key things that I do see as a challenge for industry as developers and builders that we have to really keep an eye on and not get too lost because you don't know if they'll backdate it and make us responsible or who's responsible. So that's the key thing.
When it comes to regulation, trust is a key pillar and a key component of it. And in order for any regulatory body or government or institution to incorporate or endorse AI, like any technology, needs to be trusted. And when we look at the stakeholders involved, we look at, for example, we as a team met with in the United States, the SEC Crypto Task Force just a few weeks ago. And in speaking with them, one of the things that we thought about were the different levels and layers of trust that are needed for adoption of this technology. So as a hypothetical example, let's say that the SEC were to want to implement AI into some of its workflows. For example, maintaining a tracking of transactions and looking for nefarious behavior among securities actors. First layer of trust is that for the SEC or again any regulatory body to adopt that, they need to be have the utmost confidence in the trustworthiness of it to work properly. But then there's that additional layer of trust that in this case, the entire US scope of citizens and companies within their scope of purview would also need to trust that the SEC were actually using it in correct and valid ways. So that takes time, especially with institutions and bodies that are traditionally late adopters of technology such as this. So like any wave of technology adoption, you're going to have your first movers, your middle, and then your late, but it's all based on trust. And that is really, in many cases, what certain AI activities and ways it's being used now don't have enough of. And I think that's really where we as Web3 comes in to solve those problems.
Yeah, so safe AI is a very difficult challenge that a lot of people are facing right now. Zero G actually pioneered several other infrastructure build-outs that actually tackle this issue head on. The first thing that we built was what we call AI alignment nodes. Alignment nodes basically help to detect malicious data injection that models or AI agents are tapping into. It flags it and says, hey, this data is not congruent with the rest of the data sets. Can you come and take a look at this? And in order to actually have this system widespread and active, we had to decentralize these AI alignment nodes through a node sale, which was very successful. Last year, we raised around $35 million in that alignment nodes sale, and community was owning this. The second component that we built out is actually a new ERC standard. It's called ERC 7857. It's what we call an intelligent NFT. So what happens when you create an AI agent is that there is no contract address, right? When you create a meme coin, a token, there's a contract address, you know who the creator is. But when you create an agent, especially on chain, it's very hard to tell who the owner is. So Zero G created the ERC 7857 INFT and was able to bundle and prove ownership of these AI agents through this NFT. In addition to that, we can fractionalize the NFT so that users and owners of these agents can actually participate in revenue share. For example, they can also trade these NFTs. We can have agents trade other agent ownership by buying and selling of these NFTs. Those are two components that we released over the past 6 months that solve some of this whole trusting AI agents aspect that a lot of people are facing. The third thing that we came up with is the decentralized compute network with the service marketplace. In this one, you're able to see exactly what model weights and biases were used in the training process. With OpenAI, ChatGPT, when you put a prompt in, you get a result, but you don't know what weights and biases went in to give you that result. With Zero G, because we have this decentralized marketplace to host these models, you can actually see, hey, what data went into this result? What model version am I using? What were the weights? What were the biases in place? This is the first of its kind. No one else is really being able to build this. And even if they were to build this, it would take years and years and a lot of resources. And so we're excited to bring that to market. In addition to that, we're allowing community to participate in the training of these models. So that way, there is no central entity that controls the weights and biases. The community controls the weights and biases in a decentralized way. And again, this is the first of its kind, and we're really excited to launch that in the coming weeks.
Yeah, as a security researcher at Cornell University, specialized cryptography and security, I would like to share how we do it in academia. So, so we focus more on like security side, and it's being a long existing problem since like 7 years ago. Like how to actually secure the AI model, how to make it more trustful. So we actually train a different, using federal learning to train an adversarial model that would be simpler, like a simpler structure that can easily be formally verified. And we will use that model to test a bigger and complex model. And then right now, I think since I'm not really into the federal running field, but from my security perspective, it's actually improve the efficiency of the model training, accuracy, and trust. Because we come up with like objective function of trust that was drafted in another paper, and it could be used to test the general trust of a model. And yeah, and then I probably need to read the latest papers, but it actually actually improves of the model right now. And as a financial service provider, when we talk to data centers, they also have the internal research team that actually push it this way. So we will like to support them and actually see how we can actually make the agents and all of the verification and trust better. And as also like very happy to see the recent research on in 0G.
Thank you.
At risk of sounding like a broken record, something that I repeat a lot is that accountability requires identity. And so I absolutely love some of the suggestions that you guys have on ways that we can more easily determine who who an agent is accountable to, and what the sort of chain of command and control looks like, especially when we talk about multi-agent workflows and more complex types of executions. So, we've talked a lot about infra. We've talked a lot about like cool deep tech stuff. Let's talk about use cases. I've seen some Labubu's out there in the AI universe. I've seen some cool op-eds about ZK for national defense, but talk to me, guys. How is this technology, from your team's perspective, making its way into the real world? And are there any specific use cases you've seen, whether your team builds or others build with your tech, that you're especially excited about?
I think one thing we're really doing with data is also digitizing and monetizing data. I like how from the 0G side is really assetizing the data, putting in a marketplace. Even from Laz AI, I think the team is also I know the team is also really approaching. So it's great to see alignment, how we digitize the data, how we monetize, because data is value. You see that with Google, you see that with Facebook, but it's the underlying data that has not been monetized by the public or community. It's basically almost value that the community and the industry hasn't really appreciated, but these big companies are already, I would say, extracting value from us. So a way to really take that back and almost like taking control of your assets, your keys, your asset. It's the same thing with data as well. I think data is a valuable asset that many companies are paying for, but yet we're not monetizing it. But with blockchain, we can decentralize it. We can see who is the owner. We can tag it. We can see the evolution of the data. Then we can put it in the marketplace. It's like seeing the evolution of data or fine wine. You see the evolution of the wine and the story behind it. I think the data is also the way we will assetize it, and it will be valuable. And the story it tells. That's why Laz AI really launched a gamification where people can interact with data, but with a front end where people can kind of see a character, its evolution, like almost like a Tamagotchi in a way. So from our perspective, it's how do we make it playable? How do we interact? And how do we make it tradable? It's kind of our direction from the Laz AI side.
So when it comes to use cases, this technology can be employed in every situation and scenario where AI is used. And AI is and will continue to become so pervasive that it's going to be used for everything. So I like to think a bit with the end in mind. Years from now, I believe that the concept of unverified AI will not exist, or it will be so frowned upon that the opposite will be the default standard. The question becomes, if we can verify that it was done correctly and that things work correctly, why wouldn't we? The only thing really preventing us from doing that now are things like cost, efficiency, and other variables like that. But as we know, again, with any new technology, those come down over time. And they will get to the point where the ability for those to be used is so pervasive that that will become the default standard. And then from there, we're left with the spectrum of use cases that AI is employed in, ranging from the mundane tasks like figuring out what AI can be used for to take 8 ingredients in your kitchen and make dinner that night, all the way to military defense situations of coordinating drone strikes and where missiles go. And everything in between on that risk spectrum where AI is used can and really ought to be verified. Now, we're very likely going to start on that very serious end of the spectrum, and for good reason. But over the course of time, when it comes to all these various use cases, I like to think that it'll become as simple and pervasive as seatbelts. If we can have seatbelts in cars, we should have seatbelts. And I think an even better analogy here on the very severe end of the spectrum is driving a motorcycle without a helmet on versus being able to then drive in a tank with that certainty of safety that comes along with it.
Yeah, I love that analogy on the seatbelt. So as AI becomes more autonomous, there needs to be safeguards in place. And I already talked about all the different things that Zero-G is doing in that regard. With regards to use cases that we're most excited about, I would say it affects every single industry. We're seeing AI agents being deployed in literally every single industry, and they're using Zero-G tech. In the decentralized science space, I already mentioned, people are using AI agents to aggregate a wide, diverse set of structured and unstructured data with regards to their health data. And they're able to take it and put it into a model, train it, and then actually able to give actionable intel and insights with that data. This is something that the blockchain actually helps, because let's say it's a very successful model and pharmaceutical companies or healthcare companies, health insurance companies would want to pay for that data. They can pay for it, and because it's on the chain, you can actually enforce the royalties through the chain down the value tree. And that's something the blockchain actually solves uniquely. We have in the DeFi space, decentralized finance, we have AI agents, as I mentioned, generating yield, reducing slippage, using natural language models to help make trades for you so that you can not have to worry about limit this, stop list, TP, all that stuff. You just type in like natural language and it'll do it for you. It can also auto rebalance Uniswap v3 pools for you. So if you were to do that by yourself, it's a very difficult thing to do. AI agents can work 24/7 and do automatic pool rebalancing for you. We have stuff in even the decentralized compute side where they're actually asking the community, hey, submit photos, submit pictures, submit data, submit PDFs, whatever you can, because the enterprises are looking for large data sets. And if you can submit this, we will generate the models and we will generate the revenue and give you back the revenue share. So this is something that we're pioneering. It's coming out very soon. It's called the Initial Training Offering. You may have heard of ICOs, IDOs, IEOs, all that. We are calling it the ITO Launchpad. And what that's going to allow is community to participate in the training offering by contributing data or by contributing capital. And then enterprises will pay for those models, and then they can get an ROI on that investment. So that's coming out soon in a few weeks. It is the first ITO Launchpad platform. We think it's the natural evolution from initial coin offerings and things like that. And we're super excited to pioneer that.
Yeah, there are so many use cases already, and I think the biggest difference is a biggest difference from autonomous model and static model is they can learn by themselves. So from our clients, their use cases are basically improving their daily works. For example, from the technical team, they can actually onboard some agents and train their autonomous model to maintain most of the backend, front end, and DevOps. And for the human beings, they can focus more on the creativity part. They can come up with some new experimental projects. They can come up with some new ideas or new side projects on top of their main products. Actually save a lot of time and effort. And autonomous model and the AI agents is more like careful and diligence on finding the issues different from people. They can just work 24 hours. And so it's very cool, and it's more efficient. And so for our perspective, from our perspective, I think like every field having AI agents, it's a big shift of all of the industry, like healthcare, MarTech, or FinTech. So what we're trying to do is to use the blockchain part, which is the core part is the ownership, right? Ownership of data, ownership of the money flow, ownership of the yield. So how we can take the ownership of these efficiency of a new paradigm shift back as you own the yield and the proceeds of the whole industry by all industry, including all of different yields, different fields, and you take it back, you have it on chain. So in the future, it will probably like everyone will have a UBI since you just provide your data outside, and you still own the ownership, right? And then the AI agents will basically just purchase your data in different fields like MarTech, right? Give you more like certain like ads for you to and the products for purchase. And for the healthcare company and healthcare fields, they will give you like better vitamins for you or specific supplements that you need, right? And you just sit there, you use the perceive that they provide, and then go purchase and have your better life. So I'm really looking forward to the next 10 years in this field.
All right, you heard it here first. Gaib tokens are going to pay your rent, everybody. I would love to continue this conversation all day, but we are being informed that we have a run out of time. So gentlemen, thank you so much for your insights. This is a great discussion. Guys, if you are interested in learning more about their projects, our panelists are very approachable. Please come chat with them. Thank you guys so much for your attention today and have a wonderful week at Token 2049. I'm Evan McMullen and I will see you all on chain.
Yeah, thank you so much, Evan, and for all of our panelists for the last panel. Right now, we have Daniel, who is creator of Gonka AI, and we'll be talking all about what Gonka enables and also your journey for getting into here. So I actually wanted to first start off about your entrepreneurial journey. I know you had quite a lot of diverse different experiences, starting from humanism and product science, and then also from Frank Money, and then you also did some work in AR, and then also did some product things with Snap as well. So curious to hear if you can tell us a bit more about your entrepreneurial journey, and then what led you to really focus on the decentralized AI space with Gonka.
Cool. I cannot hear myself, so I hope you can hear me. All right. So the entrepreneurial path of me and my brother David, usually this year is unusual for us because for the 40 years of our life, we mostly always together, the two of us on the stage or anywhere, doing business together since school, high school. And it all started with us actually building a decentralized network for compute somewhere back in 2002, 2003. Back in Russia. We were born in Russia. And then it was too early, honestly, for the cloud compute in that sense, especially because we were trying to build a network of user machines, like a type of a SATI project. And we managed to gather at the time 300,000 machines for doing some of the mathematical compute. Mainly, we were developing algorithms and which previously considered to be not parallelizable, and we were able to mathematically parallelize them. This was like sort of the thing which we saw the future, but then it didn't work as a business. Therefore, we needed to start thinking about something more practical, and we moved to games, online games. Still networks, still a lot of compute, but like understandable market in which you can actually make money. From games, we naturally moved to animation, because for games we build a understanding of how to produce 3D graphics and animation really fast. And we used a lot of early machine learning, like computer vision, to actually produce the animation faster. Eventually, back in 2009, We've built the animation studio, which soon produce one of the top 5 most rated shows on entire Russian TV, a political satire of like weekly produced animated episodes using a lot of machine learning to increase the speed of production of animation, of high quality of animation. And it wasn't just like AI generated at a time the way we see it today, but it was sort of early steps to like early, like before the actual understanding of what AI would be in the future. Then from that, there was this company which we sold to Snapchat, and we built the AR, surfacial AR tag for Snap, an avatar system for Snapchat. If you've seen Bitmoji, 3D Bitmoji avatars, that's us, we build them. And then when we left, we switched our gears towards efficiency of software code. And we started developing AI for software efficiency. And that was a moment when LLMs truly express themselves. And we realized that this technology actually will change everything in our life, like completely upside down world from what we knew before. And therefore from the very first business which we're building with decentralized networks, with decentralized compute, our idea was that decentralization is a guarantee for freedom. In not only in the sense of what happened with blockchains in the later on, like in 2008-9, but in general, the internet and the availability of information, the centralized nature of what we see with app stores or with mobile operating systems in general, or social networks in this sense, and manipulation in these informational layers, clearly not leading us in a great direction for as a humanity. Therefore, a couple of years ago, we sit down and we decided that we will use all of our knowledge of AI and decentralized distributed networks to build a protocol for creating decentralized AI. I think that it was the moment when we realized that Bitcoin can be perceived as not only as a product of itself, as a digital gold, like a digital scarcity product, but also as a framework which allowed a peer-to-peer group of people, a decentralized group of people, invest hundreds of billions of dollars into building compute infrastructure, which today suppress something like 26 gigawatts of electrical power for only Bitcoin itself. And if we'll think about this through this prism, this is a financial framework for financing infrastructure. And as soon as we came to this conclusion, we decided that we need to build a network which utilizes this framework in order to build the network of compute which can compete with centralized players today.
Yeah, absolutely. And with these decentralized systems comes new opportunities as well, like with censorship resistance, like with more people being able to participate. So really love the vision there. And also really cool to hear that you and your brother experimented with decentralized networks from early on. And then it was exploring different markets, like with gaming, with animation, and then even looked into AR-related work. So very cool to see the progression from there. I'm also curious to hear more about the current status quo with our decentralized systems. Are there any types of inefficiencies or limitations or even just general challenges that our current decentralized systems face that Gonka is trying to address, like say with incentive misalignment or any other types of inefficiencies that are present within our current decentralized systems?
I'd say that currently we don't experience their inefficiency in what we see in the existing centralized players like OpenAI or XAI, Anthropic. Like we can see that the people there are really brilliant and they are creating brilliant technologies. The danger is more in a centralization of AI, and we can see this even right now that they sort of paralyze, like taking the side in political decisions, like in political thinking as well. Like OpenAI would be more left, XAI will be more right, like creating biases towards beliefs, and it should not be the case for the technology, which will completely change the life of all people in the world, not only in the United States. Therefore, I would say that the technologies which they develop in terms of AI models and AI applications is great. We just need to shift a little bit towards like the compute should not be. Think about this through this prism. Right now, NVIDIA sells 50% of all the newly produced GPUs to 2 companies in the United States. And then another 50% is mainly divided among another 3 companies in the United States. So like this is a significant centralization of the compute power. And because they are actually efficient, it might seem as if this is the only way. But what Bitcoin showed is that as soon as the framework is in place, and for this framework, it provides financial incentive for the players who provide higher efficiency in compute to get more money in this market, we see insane innovation. Throughout last 15 years, the efficiency of compute of the Bitcoin hash increased 300,000 times. From it used to be something like 15 million joules per 1 terahash to what is today 15 joules per terahash. So like 300,000 times more efficient compute than it used to be 15 years ago. Should we see a similar progression of innovation in AI within the next 5 to 10 years? What we experience right now in terms of efficiency of AI will be childish. Like everything which we have going to be like 10,000 times more efficient, faster. Each of us will have the super intelligence available for ourselves for like $1 a month, $5 a month, not like thousands of dollars a month, which like if some of you guys here are engineers, you know, like that for the cursor you need to spend like $1,000 a month if you actually use it efficiently. And the future might be completely different if the different competitive mechanism will be the force behind the market. And I'm not I can see how the existing companies will still be on the market, but the decentralized nature of the compute can and we all should fight for this to be decentralized. Can be decentralized, like the nature of the future compute can be decentralized, and we all should do everything possible for it to be decentralized. And all the players are going to be just using the same compute inside of the network for their models.
Yeah, absolutely. And it's really great that you mentioned these current challenges now, because in the next few years, when we're getting more and more integrated with AI into our everyday lives, if we have continued situations like what you mentioned with NVIDIA only outsourcing their compute to 2 major companies, then it's really not allocated in that instance. And we're going to have a lot of kind of issues over there as well. And I really like how you mentioned that you see decentralized as a path towards achieving freedom, and how Bitcoin is one instance of using that tool as a completely new framework that we can model off of. So really like those points that you mentioned. I was also very curious to hear about the way that Gonka treats incentive alignment. So I know that Gonka has this very unique mechanism, the transformer-based proof of work using Sprint. So to my understanding, Sprint uses both a hybrid of proof of stake and proof of work, as well as giving the ability to allocate voting rights, voting weights as well. So was curious to hear more about the motivation for creating your own consensus mechanism and how that will really help enable for these decentralized systems.
Cool, yes. So I would flip it a little bit, saying it's not proof of stake and proof of work, but proof of work and proof of stake. Like making the proof of work the central part of what we believe might become the framework for building the infrastructure. As I mentioned, inside of Bitcoin, whoever was producing, let's say, 10 times more efficient compute, 50 times more, 15%, 50%, or 50 times more efficient compute would get a similar increase in the financial incentive they get from the Bitcoin, from the coins issued every day. So we decided that we need to apply the similar approach to this. But at the same time, all of this compute should not be wasted, and therefore this compute must be used for a practical jobs, which is majority of this practical jobs for a lot of us is inference of existing models. And then some percent of this should go for training for new models and increasing the capabilities of new models. So the approach which we decided to apply is how can we keep the 99% of the GPU power, of the compute power inside of the network reserved for actual jobs requested by the developers through the API, and yet be sure that no one can cheat. No one can actually pretend that if they actually have the compute capacity and they actually can produce the jobs. And we have both of this inside of the protocol. First, the sprint, by its nature, it's similar. It's almost like a 5-minute sprint to prove that you actually have the GPU or the compute power. For that, we developed a special algorithm, which is sort of like a Bitcoin hash, but a transformer-based one. And then after this 5 minutes, the weights of who actually have more compute is saved on chain and used as a voting power and the reward power for the future reward at the end of the day. And then during the day, the developers or like the randomly created load to the network, providing this load, providing the tasks, the actual real tasks for inference of specific open source, open weighted models, and then other participants inside of the network validate and verify the results. But we only validate and verify 1%, like every 100th of the tasks. And because this is like API requests for LLM models, during the day there are tens of thousands, if not millions, like in the future millions and probably even billions of the requests going through the network. Therefore, even when it's only one out of 100 tasks are checked, your particular node and your particular GPU is solving tens of thousands of them every day. And therefore you are checked hundreds of times randomly, and you don't know who will check you and when will check you. And all those results are then in an interesting approach stored and verified on chain as well. We save several stages of several vectors of the process of inference on chain to be able to prove that the result was real and true, so verified.
Got it. So there's some randomly selected tasks. You mentioned around 1% of them are actually verified on-chain, and that way you can save a lot of these on-chain verification costs that can incur. Yep. Got it. And most of the compute power, you mentioned around 90% goes towards the actual task compute itself. Got it. Goes toward the actual compute.
Yeah. So it is constructed currently, and it can be changed by the voting of the miners in the future. Mm-hmm. Because as you mentioned, the miners then get the votes based on the weight of their compute, and through the internal dashboard, they can then vote for changes in the code and accept any update of the network as well. But then the way it's structured right now is that up to 60% of the network capacity, compute capacity, can be used by the developers completely for free. So every request through the API to the network will be solved for no payment. But then as soon as it reaches 60%, a mechanism similar to what Ethereum doing for the gas turns on, and the higher the compute above the 60% of the capacity, the higher the price of million AI tokens resolved by the model.
Got it.
But every developer can set the cap of like how much they are willing to pay. In this sense, it's sort of like an auction system. Whoever is ready to pay more at a specific level of the overload of the network is actually getting their tasks solved earlier than others.
I see.
And in this sense, we expect that the network will never achieve, like probably in some peaks, network will actually reach 100% of the load. But what we expect is that at least 20% of the network is going to be free most of the time. And this 20% can be used for training of open source models in order to make the network itself a place where newly offered to the miners community models will be accepted, and then training new models in a decentralized way. And over the past 2 years, it started to be clear that the new models can actually be trained in a decentralized way. First, it was DeepMind's Google's article on DeLoco, and then several more upgrades proved that it is completely possible. We ourselves in a testnet trained, I think, up to 7 billion parameter model, and it's just like a matter of like how many GPUs we have had in a testnet. Right now, we have only 400 GPUs, but we started with 80 GPUs. Okay. So like in a month, the amount of GPUs grew 4 times. And if we are right with this, with the thesis of using the framework of Bitcoin to attract more compute, we expect that in a year, this network might grow to up to 100,000 GPUs first, and then probably even to 1 million GPUs like a few years after that. And what we also expect is that in a couple of years from now, we will see, not even a couple, like in a year from now, we will see the emergence of the ASICs for the transformers. They already exist. There are already dozens of companies producing them. It just, they need a protocol and a framework for them to be able to start making money as soon as the chip exists. And we hope that we actually build the open source protocol which will enable such market for the producers of the chips.
Yeah, got it. It's really great to hear kind of the hardware side that you guys are addressing as well. And then, yeah, also very curious to hear in terms of, say, those entities, any kinds of new people who are entering into the network and want to provide compute, want to take on some new tasks. Do they still have the chance to take on these new tasks if there are, say, existing players already in the network who may have more resources to delegate to? I'm just curious to hear about, just for new entries of people who have some compute and want to take on some tasks, how easy it is for them to participate.
So basically, this is a permissionless network, similar to Bitcoin. You just need to install the node on your servers. And it's a little bit more complicated than Bitcoin just because it involves actual AI inference, and it involves actually having the system with installed drivers, with like properly installed networks set up. So it's like a little bit more complicated, but we're making it easier and easier, more and more automated with like several updates already. But in like the vision is that it's going to be as easy as running a Bitcoin mining node in this sense. Okay, we'll use one mic. It's either off or battery. So okay, off. So what the answer to this is like The network is permissionless. Anyone can participate in the network. Currently, because there is not a lot of GPUs. Okay, 400 is already probably like, I mean, it's still not a lot, but we see that a lot of our participants currently don't even own their GPUs, but they rent them from the existing GPU providers, and they basically like rent them for like half a year to a year in the future, and mine the coins, basically providing the GPU power to the network. So in this sense, anyone with like a $50 or $100 a day, because this is the cost of the actual professional like H100 GPU per day if you rent it, can participate in mining.
Yeah, it's really great how you guys made it permissionless in a way where any kinds of new entrants can come and participate and delegate their compute. And the network is not really dominated by, say, just a few players who have a lot of resources or a lot of compute to delegate, but it's actually built in a way where anyone who wants to participate can. So yeah, I really like that design consideration you mentioned, and also about all of the tricks that you do for increasing the efficiency as well. Even for, say, you mentioned like maybe 20% of the compute is not being used, but that can be used towards training those models. So it's really great to see that all of the compute here is leveraged in a very efficient way. And just as a last question before we end today's interview, I'm wondering if you can speak about what's coming next for Gonka, and then also what still needs to be done to enable for more efficient decentralized AI systems. And if anyone in the audience is interested in getting more involved and learning more about Gonka, what should next steps be for them?
Yeah, so there are a couple more things which are still in the development, like end-to-end encryption. So we hope that in a few months from now, like maybe 3 to 4 months, we'll finish the part of the protocol which will enable end-to-end encrypted requests like end-to-end encrypted inference, enabling like the level of privacy which must be presented for the AI. Because if we will think about this, right now when we use OpenAI or XAI or any other company in the United States, by law, those companies are required to store all of our data unencrypted, available to be provided to the court or law enforcement. So should like anything of this will be like any of our conversation with AI might become public. And I'll give you an example. Like, you remember how several years ago Elon Musk said something about like taking his company private from public, taking Tesla, and then he was sued by the SEC. And during this process, all of his text messages and emails was published because of how the legal system in the United States works. So in the same sense, every single conversation you had with AI, with OpenAI, today already is stored, will not be and cannot be deleted by you, and accessible for the for public eyes. In a sense, someone is suing you. Like in a case, someone is suing you. So like to avoid this, decentralization is a requirement, and end-to-end encryption is a requirement, and that's like how we see some part of the future for decentralized AI networks. Another important part, which already there, like we couldn't launch before we actually achieved this, is because the results of the inference are, at least statistically, but with a increasingly, like insanely high chance of probability, verified. In this sense, we may say that the result of this inference is immutable, similar to Ethereum smart contracts immutability. And if we want to have the agents in the future, which we can trust with our money, bank account, like wallet, key, our kids' education, all possible variations of the private individual information, sharing this with our agents, we need to understand in whose interest those agents are actually acting. And in this sense, like if we don't have the immutability of the results of the inference, we cannot trust to some level of extent whose decision is actually executing the model behind our request. And then how to participate. Mine, like go and like you can go to gonka.ai, find all the documentation. I know it's like very unfriendly at this stage because it's like engineers project, but sooner or later we will make it easier for literally everyone to be able to participate in mining because it's a permissionless network.
Absolutely, and thank you so much, Daniel, for being here and for speaking with us today with all these insights. And yeah, I really appreciate all of the strides that Gonka is working to making using decentralized as a tool to further strengthen AI and using the decentralized component as a verifiable mechanism as well. So thank you so much, Daniel, for all the insights.
If you have any questions, I'll be standing there with a stand you can ask.
Yes, Gonka has their own booth right over there. So feel free to talk to Daniel and other members of the team as well. But thank you so much, Daniel. Thank you. All right, thank you so much, Daniel. Next up, we have a keynote by Tom from Metis.
I guess we'll go ahead and kick this off. Thanks, everyone. My name is Tom Ngo, CEO at Metis, and also advisor for Laz AI. I think our industry is really moving towards a huge focus on AI, and that's something that we cannot deny even from Metis. So we're working closely in incubating Laz AI and really want to highlight some of the unique features of what we're building with the team, supporting the team, and what the projects bring to the industry. So one of the key things today, and it's been quite touched on quite a lot, is trust. What is trust in this space? What is trust in AI? I think the key thing is, how much do we trust it? Maybe hand raised if you fully trust AI and your ChatGPT. I think there's almost no hands here. He's laughing. For me, I don't really trust AI fully, right? I think one of the key things that people don't know, and for me, just being in industry and also working with teams, is ChatGPT records everything. You log in with your email, you trust it with your work, you trust it with maybe, if you're a lawyer, to help proofread things. You trust it to maybe do some math and algorithm. I did a math equation and it was totally wrong. They integrated and put some unique numbers that wasn't part of the formula, and it kind of really messed a few things up. But that's the key thing with AI. How much do you really trust it? And as our industry moved towards of like being, I would say, lazy and want AI to do everything, I think trust is an impactful thing that we have to really focus on. So just touching on trust and centralization, I think with trust is, how do we verify our agent is doing the right thing? I came up with some ideas like, how do I really throw the system off, right? I can tell an autonomous agent, hey, just find some wallets of users, and then how do you create some malicious activities? And this could happen. And it is happening, right? We say the good things in AI, but we don't see the dark side in AI just yet. But it's already happening. I think being in the blockchain and the crypto industry, risk and trust is a very, very important thing. And even for blockchain itself, we're still in an industry where there's high risk. Recently, some of these big hacks, even from Bybit, right? I hate to mention it, but $1.5 billion in asset was really extracted from the company. So in terms of trust, I think trust is a very big thing. Even with AI, there's AI which is really centralized, and there's no clarity on how these algorithms are working. We don't know who's inputting this data. I know companies and projects, they're inputting data so they have higher rank, so they can be the source of truth. But I'm not sure if they are the source of truth. They are the experts in these sectors. But these systems are being manipulated. It's based on how much data is being inputted, how many times they're being pulled on the web, and then the AI agents are pulling this as verified truth. But it's not quite verified. Who is verifying it? The scary thing is, 90% of our data is pretty much owned by 6 of the largest tech companies in the world. That's huge. Where this tech company is based is also important because these tech companies may be influenced by their government. So that's the key thing. Even with Gartner research, they said 84% of companies don't trust AI. I don't think a single person in the audience raised their hand saying we trust their agent or AI just yet. But we do trust it to give us health responses, maybe recommendation, even some ideas of how we should curate different things, projects, marketing plan. We're already using it, but yet we say we don't trust it just yet. So I think where this industry really aligns and what blockchain brings to AI is transparency, immutability, accountability. I think this is extremely important. With blockchain, what we're doing with traditional finance, and now the industry is really respecting it, I think this is what we will do here for data as well. Laz AI is tackling the foundation of what we see with the blockchain, how it can support the AI data sector. I think data, the foundational of every agent, every machine learning models, is extremely important. Common saying is garbage in, garbage out. I see it quite a bit. Even these agents are hallucinating. They'll create unfactual information in terms of, even though data is available on chain. So what's our solution? What's the solution that's being implemented from Laz AI? Is a tech stack that really provides the foundational pieces and the full tech stack to really tackle this. From compute to execution layer, verifiable data infrastructure. And this is where the blockchain really comes into play. Autonomous agent and creating assetization. How do you really value these agents? I was speaking earlier on the panel, and one of the key things is data is value. Data is value that's being extracted by big companies right now, but not the consumer level, not the small business side, because we can't really monetize it. What Laz AI is bringing a full tech stack where you can monetize from day one, where things can be really, you can track who's contributing to the data. So for Laz AI, we are re-architecting how this is done. From the protocol layer, we have Laz AI. It's built on the Metis SDK. It's open source, so anybody can utilize it and really utilize it for their project. And we would like people to contribute. We built the foundation. Now we need the builders to really extract it and maximize it. It's like, what can you do with a pencil? You put it in the right hands and you can create magic, amazing things. So that's what we're doing here. From the AI agent framework, Aleph. Aleph is a way for projects, for researchers to really interact with Laz AI. This is how you interact with the chain, verify everything on chain, store your data, track it. And LazPod. LazPod is a way for we to really reach out to the consumer level. How do people really interact? How do people get engaged? I think this is a first step for people to really test the water of how data can be monetized and be interacted with. So with Laz AI native AI protocol layer, we have DAT. It's a new standard, and it was, I think Zero G also kind of touched on this, but they have a different approach. What we see is DAT is a standard where it's almost like it's not an NFT, but a dynamic NFT. You can see the full cycle of where this data came from, who contributed to it, almost like a serial identification for all the contributor. But it allows users and creators to really monetize and actually extract value. You know where it's coming from, almost like an IP for data. And it's really open to anybody can further contribute to the model or the data itself. We also have IDAO. I think one thing that we notice is like we can't fully trust AI agent fully. And we do need some human governance, human guidance. I think that's one of the key things. Imagine if an agent was fully developing your tech stack, but it has malicious data. I think we have to have some intervention. This is where IDAO really comes into play to really support, almost safeguard for the industry. We're not talking about it now, but even in news, right? We see fake news all the time. How do you verify that? And how do you correct that? This is kind of where IDAO can really make an impact and how the structure is really meant to be built for. in terms of verified computing, I think cryptography is really the key thing. ZK proof, verifying the data. This will help really streamline the data, on-chain inference, and really putting trust into AI data itself with blockchain. So I touched a bit about data anchoring token. Data anchoring token is not a static data. It's almost like the evolution of a story behind the data. And we're really created some example, and I'll share here later in this slide, of how data can be tracked. Why do we need to track the evolution of data? We want to know where it came from. It's almost like fine ingredients, right? Coffee. You want to know its source, how it was managed. Does it have fertilizer? Toxic things. We want to the same with data as well. We want to know who contributed. It's a verified contributors as well, but you can track this with that. That allows us to see the full story, where this data came from, how it evolved, and how it could be used. Yaro? I briefly spoke about individual-centric DAO as well. This is a model for us to really govern its agents and its data. It's a way where we could put safeguard into this data. Maybe eventually iDAO will be fully autonomous, but at this stage in time, we do see agents and also data. It needs safety guardrails, and this is where iDAO really comes into play. So how do people interact? How do people really utilize this technology? We built some tool sets where developers can easily access, right? We don't want everybody to really fully build out the framework. We did all the hard work. So all the developers and projects can definitely use what we built. And this is what we need. We want to invite developers to really utilize the LazAI tech stack, and it's omni-chain. It could be working with any chain itself. Use our resource, use our tech stack. We are here to really push and really help innovate the industry. We're here to tackle a problem. And we see where blockchain really solved this problem and strong use case for the AI side. Us as a blockchain project and industry, I don't think we can take over AI itself, but we can provide a solution in parallel to bring something that really is meaningful and impactful. So from a user perspective, there's a way to really interact, even to launch agents as well, from pre-assetization to more mature product itself. We have LazPod. LazPod is it's a playground for, I say, community side, but also projects to launch their AI agents itself. And the DAT marketplace is interesting. It's where the marketplace can really put a price on these data and how it's really traded, how it's really bought. So the market really determine how these data are valued. I think that's one key thing. And another project also showed that, like, how do we monetize data? And this is the first initial step. So with all this, sharing and also this information, LazPod launched LazBubu. It's a community way for people to start understanding how value can be accrued. These little pets, you can see its evolution, its interaction, and what's it's eating. It's almost Tamagotchi on chain, but now you have a live interactive interface that puts life to data itself. This is just the beginning, right? I think it's just extremely simple, but how projects utilize this, how gaming project utilize this would be very interesting in the next, months and years. So with LazAI, we drive to innovate the entire AI ecosystem, a life cycle that fulfills the early stage of data, how you monetize it, how you track it, how you verify it. I think this could be really integrated into some of the government system as well. Like we talked about the LazPad side, we talked about the LazBubu, but I think from a government perspective, I think tracing the data and where it came from, and even what region, there's sanction on regions of where maybe capital finance is originated. Data might face the same challenge too. So for LazAI and the token standard, this brings a solution where a government body can also actually use. So in terms of what we're doing today, I think for Metis, we see the technologies beyond blockchain. It's basically how blockchain can really support the industry, all industry, not just AI, but even the financial sector, which is already, I would say, more mature than the AI sector now. We invite you to join us, contribute to us, and also let us support you in your journey in this space. Thank you so much for your time. My name is Tom Ngo. Thank you very much.
Concerned about fake identities, fraud, or privacy leaks in Web3? Discover Ontology, Web3's trust layer. Trust starts with decentralized identity. OntID uses zero-knowledge proofs to verify credentials without compromising privacy. Power your Web3 journey with Onta Wallet, securely manage assets and identity. With Orange Protocol, leverage zk-TLS tech to build Web3 reputation. Join Ontology's Web3 revolution.
Breaking news tonight from Pandaro, where GPT rate limits have been mandated. This is a developing story.
The next chapter of AI should be defined not by how large model is, but how human aligned it is.
Black box, in control of just the hands of a few. With AI makes it an intelligent asset, owned by all of us, learning from all of us, governed on-chain, transparent, monetizable, and accountable to human according to human values.
Then the data being trained and small model by the community is the way to go. So this is, I see the Web3 and AI convergence from all Laza point of view.
The keynote, very exciting to see what types of work Metis and Laz AI are doing in the decentralized AI space. Right now, we have our second panel for today. The second panel's topic is AI and security, building trustworthy digital systems. So for our panelists, we have Dr. Yaoqi Jia, who is founder of AltLayer. We have John Stevens from Veradice. We have Rob from Horizon and ZK Verify. And that's all, and Leo from SciSic as well. So please welcome all of our panelists for this panel.
Thank you.
Thank you so much, all of you, for joining us today for this second panel. The main motivation for this panel is, well, AI is described often as this double-edged sword, especially for security. It can both identify threats faster, but it can also be utilized as attack vectors as well. So the main motivation for this panel discussion is to discuss about those trade-offs and how we can use AI to better enable security. So I think for our first topic for today, let's just give a quick round of introductions from all of our panelists so we can start off.
Yeah, good to see everyone. YQ here, founder of AllLayer. So at AllLayer, we're providing a bunch of these infrastructure services. For example, rollup as service, EVS as service. And yeah, since around the Q4 last year, we also provide this decentralized AI hosting platform for different agents.
Hello, hi, my name is Neil Fan. I'm a co-founder of SciSix. So SciSix starts by doing some hardware acceleration for ZKP, and then I guess starting several months ago, we are providing computing power for almost like every Web3 project, including ZK AI and crypto mining.
Hi, I'm John. I'm the CEO of Veradice. We perform security services across ZK and the Web3 space. And we also build automated tools in order to identify bugs and vulnerabilities in ZK circuits and smart contracts.
Hey everyone, I'm Rob Viglione. I'm not up there, so you won't see my picture. I'm a last minute add-on, so I'm happy to be here. I am the CEO of Horizon Labs and the founder of ZK Verify. So we have the coolest stickers in back over there. I mean, great stickers for everyone, but come get some stickers.
Thank you so much. We have a very diverse number of panelists here, so both working on the protocol side, on the auditing side, and on the hardware side as well. So very excited for this panel discussion today. I'm wondering if we can first start off with just a general overview of where AI is most effective in detecting fraud or any kind of malicious activity. But at the same time, what new attack vectors can merge when adversaries themselves, say you use AI for things like phishing or for using deepfakes as well. Are there any examples where, say, our over-reliance on AI right now or potentially even in the future, where security has created these vulnerabilities as opposed to closing them?
You have to be okay, I guess the consensus is maybe I should start here. So it was a long question, but basically when it comes to AI and security, there's a couple of ways that we've seen AI used in the past. And so AI is a good way of kind of raising a red flag very quickly. And so the nice thing about AI is, like you said, it is automated. It can be used in order to kind of infer information about something that it doesn't necessarily know yet, which is something that can be very powerful, especially for things like phishing and stuff like that. AI, however, is also something that you have to be cautious about because, at least from the security side of things, which is where Veradice comes from a lot, it doesn't provide any sort of security guarantees. So that means that AI can both miss things, but it can also flag things that it shouldn't. And so that means that there are scenarios that you really shouldn't be using AI. And so I know that's maybe not a popular opinion in the days of AI, but really with security, you have to be very careful about how you're using it, especially with the impact that it can have if it doesn't flag something that it really should, especially when there are other alternatives out there. And so, yeah, maybe I'll just leave it there. Does anyone want to add anything? Why not? Yeah.
All right, guys. So clearly, AI automates the threat landscape, which sucks for all of us, right? But when we try to automate the defense landscape as well, it's really important that, like, I guess one aspect where we can come in on the protocol side is to verify that the AI tool that you're using is in fact the right AI tool that you think you're using, including are all the parameters the right parameters that were used to train that model, or were they changed in some way? If you're running an AI model in a secure enclave, as an example, for some privacy reasons, maybe you're working with data that's healthcare data or some proprietary data, and you can't run that in a public environment, are you actually getting the outcome or the output that you think you are? Were you actually running it on the right data, with the right model, with the right parameters, and so forth? And that's why, so my company, I guess I didn't do a very good job introducing myself. I was obsessing over the stickers, which you guys should still go get some stickers. But the way we come in is just we deal in cryptography is the bottom line. So my company, we are specialists in zero knowledge cryptography in particular, but also operating in different cryptographic environments and different types of hardware, secure enclaves, and so forth. So where we're trying to tackle this problem is on that one specific niche of, are you actually running the right model? Was it trained on the right parameters, using the right data, and so forth? I do think this is something probably no one thinks about and is actually very important.
Yeah, I mean, making sure that you're running the right AI model is extremely important. You mentioned us seeing new attacks that are making use out of AI. So in the recent past, we've seen malware that's using AI in order to, kind of modify itself and perform actions that are not clearly defined within the malware itself. We're also seeing people attacking AI models themselves, where they might do something like replace the AI model that you're using. And I'm pretty sure that there was an attack that did that recently as well. And so verifying that you know the AI model that's running is very important. And also, just making sure that, you're interacting with a trusted entity is always an important thing and is important with AI going forward.
You would just say ZK verifying your model is very important?
I'm not here to advocate for anyone. I'm just saying it's important.
ZK is certainly one mechanism to do the verifiability. So appreciate how all of us have different perspectives in that area as well. And really great point that you mentioned, John, about some of the limitations with using AI for detection, especially if you are misdetecting or flagging some wrong instances. It could be a little dangerous. And Rob, your points you brought up of verifying that the model was done and also used correctly is also very imperative as well. But just as a follow-up question that I think, John, you posed about how in some contexts AI shouldn't be used, and in some contexts, security-related contexts, AI should be used. Curious to hear from you as well as all the other panelists, in what context should AI be used and in what context should it not be used, especially relating to high security related scenarios?
Yeah, so my background is in software security. And so when it comes to software security, you have to be very careful with AI because there are a lot of alternatives to perform like vulnerability and detection and stuff like that. And so while you should always use every security tool available to you, AI does not provide the security guarantees that other tools that are available can. And so while AI can be used to quickly scan your software, there have been, a lot of studies that you can find published online, which shows that AI is not necessarily good at finding bugs below like surface level bugs, like common vulnerabilities and stuff like that, where it can do some deep reasoning, but still AI is being trained and it's being trained on a corpus of like common vulnerabilities and stuff like that. And anything that deviates too far away from it, AI struggles a lot more with. And these are things that you can use other tools in order to, provide you with actual security guarantees. On the other hand, a good time to decide to use AI is when there is no other alternative in order to perform a particular action. So in formal methods tools like the ones that we commonly use, AI is very frequently used to search large spaces and stuff like that. And so for these particular problems where it's unclear what other alternatives there are, AI is always a good thing to use because in some cases it can do very well.
I sort of can give more this kind of real world like use cases and examples, because since last year we've been working with a bunch of partners and projects. They're running all different agents, and we feel that like basically after all this conversation with them, because like last year Cloud Code and OpenAI doesn't have very powerful code X, right? But for the past few months, there's a lot of sort of code generated by Cloud Code and also Code X. And when we talk to these agent sort of partners, they told us like in the early days, they want to have these kind of super powerful agents. So any user can just input what kind of strategy they want. Like for example, I want to buy some tokens. I want to have the highest APY across different chains, right? And like the AI, I mean, behind the scenes, the cloud or OpenAI to really like sort of generate instructions and execute these actions. But gradually they figure out the biggest hurdle right now is not about the model. It's really like how you really scope sort of the questions you ask the AI. For example, if the user just input whatever I just mentioned, right? The problem is like the model will just generate some instructions following the guide, but beyond that, they also overthink a lot and take some extra action. So that part is sometimes very dangerous. So for example, it will do multiple looping for some DeFi pools, and it definitely creates a better API, but at the same time, it can also expose you to more leverage and also security issues. And beyond that, granular, they figure out, okay, the best scenario would be like, we like the AI to generate probably some strategy, but at the same time, if for all the interactions with on-chain protocol, it should be deterministic. For example, these agent partners, they will just predefine a lot of interfaces and make sure like even the strategy generated by AI, it won't really do a lot of these overthinking actions. It can be really properly scoped by the interfaces they provide. That's something at least I learned from these the partners. They already provide these strategies for a lot of users. And beyond that, I believe like if we have a lot of developers, right? Another thing I feel like right now, the most important thing is like, because we do web coding, and for most of the time, this cloud code, they will just scan all the files in the repo. In that case, like for a lot of developers, they may also share their private key directly to the cloud. So that's one thing I feel like is super important. For Web 2, probably, right, there's some password for database, but for us, most of the time it's private key. It's more important and crucial. That's something I feel like we should really avoid, or at least instruct the AI don't really touch these private files.
Since like Sethik is not doing anything like related to audit, so I just talk about some my personal experience. So previously, I wrote some papers on using like formal methods to say like to show like some skins or the security proof for some cryptographic skins. They are secure. Means like the scientists or the researchers, when they are writing the proof, they are actually like doing it in some way. So in that part, since like the search space is quite small, probably like we can just write a bunch of rules and we can just apply some like brute force search, like to say like which rule we should apply to carry out the security proof. So that part, I don't think like AI is a huge help, since the space is very small. You just do some brute force search and you are done with that. Like some of my previous papers say like if you want to carry out a proof for say like 10 to 20 page long proof, like you just need about 2 to 3 seconds to finish the proof on this like, automatic systems. But then the next goal is to show like the security code you write, they are like a functional equivalent to the spec. Since like we are doing a lot of like optimization to make sure like the last optimized version is like very cost effective, and it of course will deviate from the gold standards, the naive basic implementation. So that I think like we can use some like AI tools about that. But since like I'm not in that field anymore, so I'm not sure if any tool has been carried out to verify, to security proof that like the optimization you apply for your original code, they are like found in these transitions.
So there has been some work in integrating AI into interactive theorem provers in order to do search, because yes, in some cases the search space is very small and people can probably do it effectively, but especially for these like mathlib and stuff like that in Lean, they found cases where the search space was very large because you have to figure out like how you can prove individual lemmas, and they have built in like tactics that use AI to help accelerate that. I think still people writing proofs in Lean tend to solve more problems eventually, but it's a very good way of speeding things up and performing that search process, because writing code in some cases is a search for the right solution. And so
I haven't tried it before, that I'm still in the cock or combo.
I think there's actually a cock tactic as well.
Very interesting to hear just from your side, Leo, and then also John, your side, about experimenting with those, with the assistance of AI, especially in this proof generation context as well. So very interesting to see where these AI tools can be applied to. And then also on your side as well, you presented some use cases relating to alt layer, and you mentioned how giving users the flexibility of providing their own inputs could have its own caveats as well, especially if the model tends to overthink afterwards. So appreciate all of the kind of insights that you guys gave here. And then I was also curious to also hear about, as we're incorporating more AI into, say, these high security or high security stake systems, how is regulation going to follow along with this? Are there any types of hurdles that we have to go through, or just any kinds of insights that you have like regarding that?
I think at least based on the conversations and policy discussion from the U.S. or different countries, I believe the first or the biggest topic for all the regulators who want to talk about AI is about data. So basically, we all know, right? Singapore, we have PDPA. Like in Europe, we have this GDPR. And US also definitely, they don't want the data to be transferred to the other countries or out of the US. But we all know, like, if we use, for example, Cloud, OpenAI, ChatGPT, right? Most of our data by default will just transfer to their servers. And then, like, so there are two things. One, like, they claim that they don't use our data for future training, but it's basically trust me, bro model. We don't really know. We probably need ZK to really make sure, like, okay, the data literally not used for training. But it's probably very difficult. But beyond that, it's also like, apart from training, right? We just reuse the data for something else. For example, for the recommendation, like, for example, when we use Google, right? Google always use our search history for better recommendation. But the thing is really about data, especially right now, we web coding a lot of this private information inside the company. Somehow, when we use AI, right, for coding, roughly we share most of the company's information with the cloud or OpenAI. I believe this kind of this data protection and also this copyright, right? Either belonging to the company or belonging to this cloud or OpenAI, if they write the code for us, right? So there's a lot of, the boundary is super blurred right now. And the copyright data, who is the real owner, how they really pay for it, or like, can we really sue them if they misuse our data? These are all the things super sort of blurred at this moment. Yeah.
You want to add on to that?
Yeah, that's a great point that you mentioned, especially the blurred lines between data, between copyright, even like who owns what. Those are all kind of all instances that we need to further define, especially as we're incorporating AI to these more high security stake systems. But yeah, just off of that, I know there's some talks of just some people mentioning there should be some sort of like proof of security, for example, like baseline requirements, some kind of attestation that, say, this AI model can be effectively deployed in this, especially in like very high security domains, like say with defense, for example. Just curious to hear about all the panelists here, what your thoughts are on about this. Any sort of baseline requirements that need to be completed before we can start using AI, especially in more like sensitive domains, like say in healthcare or in defense, for example.
Yeah, why not? So guys, beyond getting some stickers at the ZK Verify booth, I will say again, like I'm not the security guy on the panel, and I'm definitely not a regulatory guy. I'm not a lawyer. But I do think that we do know some things. So we know AI is here; it's not going away. We do know that a lot more is being audited or being automated, and we even have team members that are vibe coding. So beyond that, we know that we are absolutely going to have very strong security requirements around AI. So not to constantly tell everyone to ZK verify your AI models, but I do think the reality is, depending what industry you're in, You're going to have to protect data. We know that. So that's kind of exists today. We are going to have to, as we use AI models, depending on what you're doing, maybe you need to run it in a secure enclave or some piece of partition software, especially in the national security space. In these types of environments, you're probably going to want to have some sort of assurance that what's happening in the black box is actually what you think is happening in the black box. So from my perspective, as we come back to this question, it's really, how are you verifying that what's happening in that black box is really what you think it is? There's multiple ways to do it. Obviously, we think cryptography is a key component of making sure that that happens.
So when it comes to securing an AI model, there's been some research on that over the past couple of years, but I'm not like an AI security person, so I'm not familiar if there is some work about securing LLMs. As far as I'm aware, there's no work on, making sure LLMs have some sort of guarantee about, like, when someone asks me a question, I'm actually going to do something related to that question. And so the way that I've seen people usually end up providing some guardrails on not necessarily LLMs, but AI in general, is to essentially put what is called a shield in front of the LLM. And so that shield is just a program that has formal guarantees to say, like, I am not allowed to do X, Y, or Z, so that you can say, yes, the AI is going to do certain things. It's got like a specific thing that it wants to do. And so this primarily, the shield thing that I'm talking about was primarily seen in like automated cars, where based off of sensor data, you want to say something like, given this sensor data, this program is going to make sure that the car is turning in safe thresholds and stuff like that. But when it comes to LLMs, things get a lot more difficult because they are so general. And so as far as I'm aware, there's not really a whole lot that you can, or that people are currently doing in order to make sure that an LLM that you're using is actually secure. But when it comes to like, I don't know, military purposes and something like that, they might be able to do something similar.
Yeah, so like as I think, we are also doing something like related to AI security or LLM security, is to say like the first is like we use ZK to verify the inference result of some like AI models, which means like if you are asking like your AI model to use say GPT-5 to do the inference, then they are supposed to do that. They are not supposed to use like GPT-3 to do the inference. Since like from a human perspective, we cannot tell the difference. But we use ZK to verify, to make sure that they are actually using the model you ask to do the inference. So that's like one thing. The second is like about the AI training part. So like if we also have some like in-house research which we recently like published on ePrint, to say like we want to use like ZK to verify the model training purpose, the model training process. They are also legit, which means like you are using the correct way, you are using the correct data set to train the model. So, but it all takes so much long to generate a ZK proof for say like for GPT-5, it's usually like in several minutes to generate a proof. But for this like ZK proof for training is like, I guess like more than 1 hour to generate a proof. Yeah.
And yeah, thank you so much for all those insights there. Rob, you mentioned about perhaps running these within secure enclaves. And then you mentioned, John, about having that potential shield as well. And then Leo, you addressed kind of two main aspects that we need to think about for these models, which is relating to the training and inference stages and being able to prove the validity of those two. And even Rob, your point that you mentioned about we need to really see that what's happening inside the black box is actually what's happening, which is very difficult because like for us, we only see the inputs and the outputs. We don't really see what happens in between, but hopefully ZK or some other verifiable mechanisms can be used to help assist with that process. So thank you so much for all of our panelists for all the insights. Yeah, I really appreciate it for you all for being here.
Thank you.
Thanks.
Thank you, guys. There we go.
No, shove it in my face. Yeah, exactly. I wanted to make sure people knew that there were stickers over there and that.
Concerned about fake identities, fraud, or privacy leaks in Web3? Discover Ontology.
Thank you so much for our panel in the last panel. Next up, we have David, who is a co-creator of Gonka and who will be giving a keynote.
Hey everyone. Artificial intelligence represents humanity's greatest opportunity for general abundance. Unlike oil, copper, or wheat, it doesn't have boundaries of scarcity. AI is pure information. It can be copied billions of times with almost zero marginal cost. The biggest foundational models today can fit just a tiny flashcard. When they built, when they trained, they can serve every human on Earth. This is a fundamental promise. Coopia, from Latin, abundance. Yet today, we stand on a crossroad, sliding in artificial scarcity. Big tech companies found the choke point. Computational hardware and energy. Yes, AI can duplicate infinitely, but GPUs who runs it cannot. This physical bottleneck has been frontier of control. NVIDIA market dominance, as well as hundreds of billions, literally hundreds of billions of dollars invested today in GPU infrastructure by major corporations, it is calculated bet. If you control the means of compute, then you can extract the rent from humans' need for AI services. It is not an innovation, it's capture. Bitcoin, though, showed us an alternative path. When true market forces unleash, innovation follows. Started with CPUs, then GPUs, and then ASICs, specialized hardware chips. We all seen dramatic improvements in both efficiency of compute and energy consumption. Just 15 years ago, 1 terahash required 5 million joules. Today, it is 300,000 times less. Just 15 joules. Personally, I already today as an engineer spent couple $1,000 a month on AI services. Divided by 300,000, and it's just zero. Too small to even measure. Also, Bitcoin showed the scale. Data centers around the world in Bitcoin network today represent 26 gigawatts. It's a really important number. It is more than Google, Amazon, Microsoft with all their data centers combined. Even if you account for labs like OpenAI and XAI with their ambitious projects, you likely see in all these major titles about hundreds of billions of dollars committed to build a new data center. Each of these labs this year plan to add 1 gigawatt of data centers capacity. At the same time, with no announcements, no PR, Bitcoin added 5 gigawatts just last year. Imagine to apply these principles for artificial intelligence. If decentralized protocol, proof of work protocol, would govern AI inference and training, this type of innovation, this type of alignment of incentives, because protocol drives incentives, incentives drives hardware innovations. We can make compute so cheap, it is impossible to monopolize. Where the network will not only be a tiny share of the AI market because of the importance of immutability of calculation or because of the privacy and security, but just because it would produce thousands of times more compute. So I'm David Lieberman, creator of Gonka. Don't be distracted by few AI project networks out there which based on proof of stake. Proof of stake means incentives aligned with capital. Capital doesn't care about efficiency. The biggest AI network, decentralized network today, already generate $1 billion worth of rewards every year. But most of this goes to stakers. Only a fraction of this goes to real hardware providers, hardware innovators. It gives us only 5, 6, maybe 8,000 of high-end GPUs on this network. It's definitely not enough to compete with major laboratories. But if we would use proof of work, if we will use the path which was shown by Bitcoin, we can do much more. When Gonka protocol was designed, it uses this idea as core principles. Protocol is transformer-based proof of work, so that incentives aligned with those potential hardware innovators who will bring new type of hardware to compute AI. The network already launched is the mainnet. And already today, every coin generated goes to miners, hardware providers. It also, we needed to innovate further. It wasn't enough. That's why we introduced sprint proof of work, which only require fraction of computational power for security and verification. The rest is available for real, meaningful AI tasks of developers through decentralized API, as well as end consumers of those developers. I invite you all to join this revolution. Is still possible. Build protocols, innovate, mine, develop apps, and we will all see this different future while it's still not too late that big corporations will steal this future from us. We are on this stand. Come and talk with us. It's a pleasure to talk with you all. Thank you.
Thank you very much. Yeah, thank you, David, for the keynote and for introducing Gonka, and also the transformer-based proof of work mechanism that Gonka uses, and how the system is designed in a way where most of the compute efforts go towards AI-driven tasks. So very appreciate the keynote from David. Next up, we have our third panel for the day. So this panel's topic is Scaling with ZK, Proof Systems for Global Infrastructure. We have Evan coming back again to moderate, and we also have panelist guests, Stefan from ZKM, Anurag from Avail, Michael from Brevis, and Shiv from Boundless. So please welcome all of our panelists.
All right, GM, everyone. Thank you guys so much for taking time out of your busy schedules this week to join us. My name is Evan McMullen from Billions Network. We are the first universal human and AI network built with mobile-first verification. Come on up. So today I am delighted to be joined by some incredible panelists. To get things kicked off first, I'm going to invite everyone to share who you are, what you are working on, and give us a little bit of context for the hat you wear when you come to the House of ZK today.
Okay. Thanks. Yeah, I'm Stefan from the ZKM. I'm the CTO of the ZKM, and ZKM is a MIPS-based ZK virtual machine that's targeting building the general purpose verifiable computation infrastructure. And currently, our use case includes the Bitcoin layer 2, like the Gold network, and some other even include some AI-related projects like the Laz AI. Yeah.
Hi, Anurag, co-founder of Avail. Been in the space for about 8 years now. Previously also built Polygon. Avail builds infra in the spaces of scalability and interoperability. So we just come out with this upgrade called Nexus, which we are focusing on now.
Hi, this is Michael from Brevis. At Brevis, what we're building is what we call the infinite computing layer for Web3. It enables your applications on blockchain to tap into an infinite amount of computation powers. So, there are two main products we built. The first is called Pico ZK VM. It is general purpose ZK VM that is extremely performant and developer friendly. So another feature it has is like extremely modular. So you can actually plug in something called a ZK coprocessor for many commonly used application scenarios. They work with many of the biggest names in the DeFi space, such as Linea, PancakeSwap, Uniswap, QuickSwap, and many others to build the application feature that is in production right now. With like hundreds and thousands of users hundreds of thousands of users are actually using them on a daily basis.
Hi, I'm Shiv. I'm the CEO of Boundless. Boundless is a universal protocol that brings ZK to every chain, every app, every builder, and every context. We were born from RISC-0, which invented the ZK VM and really sort of restarted the conversation around ZK and its applications. So yeah, super stoked to be on this panel. I'm also a graduate of NUS, so this is a homecoming from me. Lived here for like a decade, so yeah.
Excellent. So I'm particularly excited to be here with you guys today because you have a little bit of a different perspective, let's say, than the one that I build on. So with Billions Network, we're really focused on client-side proving, libraries like CirCom, SnarkJS, RapidSnark, but we are now entering into a new era of proving with more of a commodity model and decentralization. So can you help us think about the journey? What has been instrumental in evolving from, call it 5 years ago, when if we wanted to generate a zero knowledge proof, we were sitting at our desktop computer, crossing our fingers for 30 minutes and hoping something would happen, to the marketplace-based ecosystem that we have today?
Maybe I'll start. So I think Boundless is completely born out of these sort of market trends in a lot of ways. So key thing to remember is until like maybe like 5-6 years ago, or actually to be honest, 4 years ago, most of ZK was implemented using circuits, which required PhDs, in-depth understanding of what you were doing. If you wanted to like actually do something in production, was just run something in your laptop. There's maybe like 200 people who could do this properly, another 200 people who could audit this for you. So a very happy 400 people family, like farming, like a very small industry. ZK VMs actually flipped that narrative completely by allowing access to anybody who could write a high-level language to enter the domain of writing ZK programs. So accessibility. The next thing is like improvement in proof systems themselves. Polygon famously, like, spent like quite a lot of money acquiring the best ZK researchers, putting them together to like improve the state of the art, especially with the Web3 context. And then there was other people as well, Eli, of course, and like lots of other teams, RISC-0, putting forward newer proof systems that advance the guard, which makes performance something that is now in the domain of like totally acceptable to getting even faster, and cost as well. The last thing is cost, right? So the most important thing that businesses pivot on is OpEx, cost. When you're actually doing something for real, like somebody has to foot the bill. It's all great for CTOs to hang around saying this is all cool and shiz, but there's a CFO standing at the back going, I can't really pay for this, which is why we're entering the market era. Markets, and firstly, crypto and markets work extremely well together. The power of the token actually like reduces costs. And that is really going to be the entry point where we are going to welcome more and more users come in. So this is why we're all here, to build like markets for ZK and so on.
Yeah, I agree with a lot of what Shiva mentioned. So I just want to mention one thing, that we started in the ZK space from building circuits, which is basically writing mathematical equations, but then evolved into building general purpose ZK VM, where developers themselves don't need to understand anything about the underlying mathematics. And then, you can just write any kind of general purpose, program on top of that ZK VM and get that proven. But, we also need to know that from a engineering and technology perspective, there's always this trade-off space in any kind of engineering solution, right? So like, if we look at the entire ZK VM space, now we're operating the trade-off space between performance and programmability. So, with ZK VM, general purpose ZK VM, we have the maximal programmability, but at the same time, undeniably, we're also sacrificing some performance. How do we fix that? Well, we now is actually coming back to the more specialized kind of a circuit architecture, where as long as you have a modular enough ZK VM, you can plug in, as if you're plugging some special hardware in your computer, you can plug in some special coprocessor in your ZK VM to deal with commonly used application scenarios and use cases, such as access to on-chain historical data and compute on top of that directly in your ZK VM. So this is like what Pickle and Brevis does here, is to have this kind of a modular architecture, but at the same time allow application developer to access the performance of specialized circuits for commonly used application scenarios. This is why we can actually, have all these different kind of application use cases that is mass adoption ready, that were not available anywhere else.
Yeah, like to be honest, I think I mean I come from the customer side. Like I've been like all using Res Zero. We've been using Brevis. We've been using Succinct, for example. We've been writing custom circuits as well, right? Like so we've used like the breadth, all the possible solutions. In general, like in concrete numbers, when we have like this bridge that is ZK based between Ethereum and Avail, that we first wrote in, like we had to write in, like we wrote the circuits. It took us 9 months, lots of audits, everything to kind of get there. Then once, like the ZK VMs became ready, we rewrote it in. Actually, we've rewritten it in, Res Zero's thing. We've written Brevis, for example. We've written in Succinct also, for example. And all of them took a few weeks, to kind of get ready. So to be very honest here, like it's been like a very great performance thing for us. The thing that took us 9 months now takes us, like a few weeks. It's very easy to understand for our developers. We get more developers who can develop. Like I can just get people who write in Rust to write these programs. And so, but we still use, like custom circuits when possible. Like the base layer of Avail still uses custom circuits because that's where we need very light logic and very high performance. And so we use which is appropriate in that sense.
Yeah, I agree with most of the views that performance maybe is the biggest challenge for most of the ZK VMs right now. And but from my understanding that, I wouldn't say the end game. I would say the non-term goal of the ZK VM would like they build something like the verifiable cloud. So consider the last decades, how the traditional cloud grew up. So I think one of the most important is the developer experience. So how to make sure that ZK VM comes out because of its own now the developers should use high-level language like C++, Go now, or C#, maybe to write the sockets to build the applications. But right now, I think most of the ZK VMs are just focused on like the Rust because it's bringing you as a very short instruction sequence. But for the other languages like the Go now or some like the C++, I think that's one we are focused on to make sure the developers can use that. Okay, so this is the first point. We need to improve the developer experience. I think we support multiple language is very important. And the second one is, it's about the performance, I think. When everybody focuses on the RISC-V, maybe somebody may think RISC-V is the most suitable instruction set. But from our understanding, that's maybe not. We are focused on the MIPS, and we can take a look at the easy proof that the Xano is the ZKM's instruction set. That's the stackers of each block from Xano. It is about 10 to 30% less than the RISC-V based ZK virtual machine. So basically it can help us reduce the proving cost. For somehow. So that's the second one. We still think the performance may be one of the biggest problem right now. And that's what we think about.
So obviously, improvements in performance, cost, and efficiency are vital to this abstract idea of scaling. To make it a little bit more tangible, we had a spicy prediction from one of our brilliant colleagues in the Lagrange team earlier today that in only a few years, all compute will be verifiable as a basic expectation, and if it's unverified, it will be tantamount to non-existent. Do you agree that all compute should be verified, especially in the DeFi space? And if so, how on earth are we going to afford that?
Yeah, definitely. this makes me this reminded me about the containerization several years ago, maybe 10 years ago. Should everything be in a Docker or in a Kubernetes? I think the answer would be no, right? So for the ZK VM, I think that's would be a similar answer. Not every software should be proved or verified by ZK VM. But for the AI, I think especially for the agent, I think it's when the people some speakers are talking about they use the agent to do some like the prediction markets for the transactions. It will be very important to verify the execution trace or the actions or the plans of those agents. So I think for the AI, it's very important actually, but performance is still a big problem right now.
Yeah, I mean, it's of course be very bullish if everything was to be verified. But to be very fair, I think most computation doesn't need to be verified. Like, I mean, like there is a market for computation that is important, and there is a market for computation that is not important. So blockchains are basically compute that needs to be verified, right? Like, I mean, you want your money flow to be verified. Do you want like like I don't know, like sending your stickers emojis to 10 people be verified? I don't know. I mean, whether that should be verified, right? Like, so and of course everything is a cost, right? Like, I mean, I don't think there is a world where running one cycle of computation natively and versus verifying that requires of course multiple cycles, right? Like, so I mean, again, it comes down to a lot of things. Of course, anyone can make these predictions like everything is going to be verifiable, but I don't really think so.
Wait, Anurag, I have a follow-up there. So you've noted that on the one hand, of course, financial transactions warrant verifiability. That seems like something we can all agree with. We want to ensure that our money is only engaged in verified transactions. Then on the other hand, we've got sending stickers around. Those seem like two agreeable poles. How do you draw the line?
Cost, I would say, I mean, that's a very easy way, right? Like, I mean, essentially, I mean, even right now, right? Like, we have to look at cost very succinctly, right? Like, for example, if we are using a ZK prover from RIS0 or from Brevis, or do we have to run our own? Do T's kind of suffice for this use case, for example? Because there's always a dollar cost attached to everything. So I think cost is a very easy way to kind of filter. I mean, just compute the number of the dollar revenue that these guys will make if I had to verify liking or sending emoji stickers or liking a social media post, for example. These would be the most valuable companies in the world.
Yeah, I think for that prediction, I want to refine that prediction a little bit. And I think that will make it valid. That is like, I think in 5 to 10 years, 99% of blockchain applications, this computation is actually going to run in an off-chain, verifiable, ZK-powered way. Now, the reason for that is the amount of computation that is actually accessible on-chain today is actually very, very, little. So like, let me give you guys a very, very concrete example. So if you have used any kind of a centralized exchange today, you probably all seen this feature that is like VIP trader reward program. If you trade it a lot in this month, then in the next month you get a trading fee discount, right? So every centralized exchange has this feature. Now, think about it. Think of all the decentralized exchanges that you have ever used. Have you had any kind of exchange that offered this feature until very recently? Until we work with PancakeSwap, for example, right? None of them offer this feature, not because they don't want to, but because just to compute individual users' trading volume historically on chain is going to bankrupt you in gas fee. So this is how little computation power you actually have on chain. And this is why we need to change it with verifiable computing that can allow you to offload this kind of a complex computation away from your smart contract to an on-chain environment, then bring it back to the blockchain so smart contract can verify that easily and cheaply. So this is why we're powering like a lot of intelligent DeFi features such as PancakeSwap and Linea and Euler and Euromoney, helping them to launch new programs to customize user experiences for their user, to distribute the reward based on very complex user behavior on chain in entirely trustworthy way. This is what we're doing with Brevis now. So for now, we're kind of having application that is half on chain and half off chain. Most of the, half of the business logic still runs on chain. But I think in just a few years, we're gonna see applications have most of their computation logic that happens actually entirely off chain, such as like, we're working with like major perp DEX recently to launch this kind of a ZK perpetual swap, where you can have centralized exchange user experience, but at the same time with privacy protection for your order and positions. So you can have like dark pool orders, you can have like hidden positions. So there's not going to be any kind of a liquidity assassination that you guys seeing on the kind of a James Wayne case, right? So this is where we see the industry going, and this is where we are pushing forward to.
Yeah, I actually agree with Anurag to like a really large extent. Whilst I would love to be the most valuable company on the planet, I think that's maybe like taking it way too far. Because ultimately people are driven by cost. If you have like a cheaper option that is acceptable for your requirements, then that's where you should go as a responsible builder, because it is passed through cost to your customer. And generally how markets function is, if I blatantly make my app more expensive, somebody will find a way to build a cheaper app and like kick me out of the market. So I think there's always going to be that trade-off. I have a different perspective on this, which is, so I'm both a CS grad, but I'm also an economist by training. What will actually happen is the size of the pie itself will increase. I used to work at AWS and Azure when like the whole war cry was all computing will move to the cloud. It didn't. A lot of it did. A lot of the new computing moved to the cloud. It created more opportunities for people to build highly scalable business models, new kinds of applications. Netflix runs completely on AWS. Most people don't realize this. But data centers, if you know how much power you need, if you know how much compute you need, data centers are the way to go. You're always going to find it cheaper. It's easier to be compliant, all the more interesting things as well. But similarly here, what's going to happen is as verifiable compute becomes cheaper and cheaper, as ASICs become a reality, as client-side proving becomes a reality, more use cases will show up. We will eat a dominant share of these use cases that have been built around this capability. Because when you think about it, it didn't exist because verifiable computation wasn't cheap enough. Verifiable computation becomes cheap. These use cases come in. Obviously, it means that they need verifiable compute. So you will see the market cap of like verifiable compute increase, and that's great news for us. The world that I want to live in is where like all of these options are available to me as a builder, and it is native in my DevX experience as well. When I'm writing my application, if I can switch between verifiable and not verifiable in like some kind of metadata in my code itself, and I'm like, oh, this is a very critical piece, I want to run this in verifiable infrastructure versus this, and like I just start splitting it out. That's what you're going to see. And I'm really hopeful for that future as well, because it does build more engaging user experience. You want to build really quick user experiences for everybody that are slick and easy to use, but also provide the security that you need. Not necessarily just blockchain, but like off-chain as well. Like, yeah.
So Shiv, you said something a little spicy there, that trust assumptions will adjust to the requirement of the use case. Let's talk a little bit more about that. So, I think a number of these forthcoming and even present use cases, especially those in DeFi, imply that there exists more than one chain, right? We live in a post-Bitcoin world, and so interoperability is the elephant in the room when we talk about these trust assumptions. How are you guys thinking about that interplay between the interop requirements of scaling, concepts like unified liquidity, and how we moderate the trust assumptions of building in between these different ecosystems?
Yeah, I think interop for a while had died down in its conversation because people have just accepted that this is what oracles are, this is what bridges are, just deal with it. But the advent of ZK, or like rather its presence in the conversation, and the price point at which proofs like On Boundless, for example, during our mainnet beta, the median price of proofs was $0. So people were willing to speculate on the token so much that they discounted the cost of the proofs to $0. P90, 90th percentile was also $0. P95 was also $0. I don't expect that on mainnet, but what we are seeing is 90% discount. So the cost like do go down, and which means like people are willing to do these gigantic proofs of state of Ethereum, for example. We built a full consensus client for Ethereum, not a light client, but a full consensus client, previously thought to be not useful because the proving of that would be so expensive. We've been able to do that, which means you can carry Ethereum proof to any other chain. Let's say we do that with Solana. Now you can carry that. So if we are able to actually do that for most of the major chains, we encourage people to launch app-specific chains, because maybe it can be argued, but I don't know how you'd win the argument that like having a custom chain for your use case is not better than having a general purpose chain. Like I think just intuitively makes sense to me that having your own custom block space is important. And if you can make interop extremely cheap and easy to do for you to plug in your own custom block space, all assets will become multi-chain, in my opinion. Not that they need to. I also think it's kind of silly that like if every asset is multi-chain for no rhyme or reason, you just, it's a hat on a hat, as the stand-up comedian would say. It's not necessary, but the capability will exist. And I think as an end user, I am not super concerned about where my asset lives and what I have to do. Right now, I have to do my own bridging and do all these interesting things to use something on Solana because my asset is on some other chain, and do all these like hilarious things that actually adds a lot of onboarding headache. I'd much rather be able to open an app where I'm just like, I have these assets, I want to use this app, I want to do this thing, I want to get this yield, just do it. Don't bother me with all the other execution details. Funnily enough, that's how Web 2 operates, isn't it? When you connect your bank app to Wealthfront or use a robo-advisor or all these things, you don't really worry about like, oh, how are they moving the data around? Like, am I supposed to do more things? You just authorize, and you just like things just move around. So that's really the world I want to live in, and I do believe ZK unlocks this because costs have gone down enough, and you can do this at scale with decentralized proving networks like Boundless.
Would you guys agree that interop is I'm just asking our other panelists if they agree that interop is useful based on the pull, based on the demand for that interop?
I think interoperability is kind of a secondary demand. Interoperability's demand stems from the need to have scalability, really, right? So like, because we cannot scale layer 1 blockchain fast enough, this is like why we actually kind of now break, many kind of break into these many sort of isolated islands of layer 2s and separate blockchains. And, I think my take on this is like, if we want to fix interoperability, we need to actually come back to the layer 1 blockchain. And if we can scale the Ethereum layer 1 blockchain by another 100 times, even like 1,000,000 times, then we basically have the interoperability solved. Like we can actually enshrine all the validating clients for the layer 2 into the layer 1 itself, so everyone can have like synchronized communication between all these different shards, different kind of islands in the Ethereum or any kind of a blockchain world. Now, there's a reason we couldn't do it today, because the Ethereum, again, layer 1 doesn't have enough computing power to do that. Well, what's the fundamental reason for that? Well, the fundamental reason that we don't have this capability is because today's blockchain consensus runs on something called a simple computing. That is like you have a verification of the computing by only doing recomputation. So like you have 1,000,000 nodes in the network, right? So you want to have this 1,000,000 node reach the same conclusion for some kind of a computation. What we're doing now in every blockchain is to have every node in the system does the computation again and again and again and again. The same kind of a computation get repeated 1,000,000 times. Is like the time is like the cost of that is basically 1,000,000 times more than the single unit of computation, right? So how ZK can solve this is by allowing you to just pick one node out of that 1,000,000, generate a ZK proof of the computation, spend maybe like 100 nodes worth of computation power on that. However, you save the cost for millions of replication of the computation, because everyone else can just verify the proof of the computation with extremely low cost. A very, very important benefit of ZK is that no matter how complex the original computation is, the cost of verification stays constant. So this is how you can actually build a Ethereum future, for example, that matches the capacity and speed of Solana while still maintaining maximal decentralization. Once you have that, you can essentially have all your layer 2s share the use kind of a shared sequencer with the entire Ethereum blockchain to become essentially based or native rollup, right? So that will give you a level of interoperability that is just simply not possible to do today. So we actually think that this is something that Pico has been working on. To achieve that, you basically need the first step to do that is you need to prove Ethereum blocks in real time. And we're gonna launch something very exciting very soon on that front for Pico as well.
Yeah, I mean, one of the main reasons why we began Avail in the first place is, Ethereum blockchain like Ethereum doesn't really have native interoperability, and for some of the reasons which Michael already kind of pointed out, it's very hard to kind of bolt in something like native interoperability. And so it's very hard. Like if you see, there are like probably 200, 300 layer 2 chains on Ethereum today, but all of these look like separate islands. Like each of them have their own liquidity, own assets, and then everyone has to go back to the mothership Ethereum to kind of bridge funds, for example, and so on, which was actually okay a couple 1 or 2 years ago, but there's now a lot of competition, from let's say things like Solana, Hyperliquid, for example. So now there are these new islands forming, and so it's not really necessary that Ethereum and its own L2 ecosystem is going to kind of latch on to the legacy adoption they had. So interop is a very serious problem in general, right? Like because funds are moving from one ecosystem. I mean, if you see the Plasma launch, right? Like recently. It's a new L1, but insane amounts of money capital moved from the existing ecosystems to the new ecosystems, even though it has nothing to do with Ethereum, for example, right? Like so, and with the advent of TradFi, there's only going to be more chains. Like each TradFi ecosystem company is looking to do a stable coin. Each TradFi company is looking to do an L1 chain or an L2 chain. I mean, whether it is ZK, optimistic, doesn't matter. But there's a chain coming, there's a stable coin coming. By end of next year, I would say there will be probably 500 different stable coins on the market, like USD, A, B, C, D, E, Z, whatever, right? Like so, and I mean, I'm not joking. It is right, like. And how do you interoperate between these new chains? How do you interoperate between stable coins, right? Like, how is a USDC or A going to be compatible with USDCZ, for example, right? Like, are you going to have to trade on a curve with like multiple of these pairs, for example? So there's a lot of questions around it. Coming back to the ZK question, when we started Avail Nexus, which is our interop upgrade, we actually meant it to be ZK native on day one. But the reality is that we don't have the kind of ZK rollup or ZK chain verification proofs on all chains, right? Like there are hundreds of chains which are either optimistic or pessimistic or L1, which we then now to go and find what consensus do they use. We need to create proofs for each of them. So it's a very messy task. So that's why, us and even other teams do now this combination of ZK, but we also use T's, for example. We also use, like things like validator level consensus, for example. So at the moment, I would say ZK is not there yet, not from a tech perspective alone, but also from a business perspective alone. Like Base is not ZK enabled today, for example. Like something like Plasma or Hyperliquid is not ZK native ready today. So then we have to resort to other methods. But I'm saying interop is essentially, like a foregone thing. It has to be solved. Today, it will be done with a mishmash of technologies. But, of course, on, in a few years, we want it to be completely ZK because that's very easy to manage as well.
Okay, it's still about the interoperability, right? Okay. Yeah, so basically at the beginning of the ZKM, we were trying to build the ZK verifier for the Metis layer 2, because Metis layer 2 originally is a optimistic rollup, so the finality time would be like 7 days. So we want to build some hybrid rollup that uses the ZK proof to reduce that finality time. That means when some people want to withdraw their asset from layer 2 to layer 1, we can generate a proof and to convince that the on-chain fraud-proof VM that those transaction has been included and be verified. Okay, so after that, we begin to consider the interoperability with different blockchain like the Bitcoin. Yeah, that's why we also spend a lot of effort on building the BitVM and BitVM2. BitVM actually is you can consider it as a smart contract of the Bitcoin. Yeah, it's more powerful than the script. Okay, so we also have we also apply this design implementation on the GOAT network. GOAT network is a Bitcoin layer 2. Okay, so actually we have a vision that we want to build something named entangled wrap. That means if in the long-term run, I think every blockchain with roll up maybe becomes a based roll up. That means use the layer 1 to sequencing ordering the transaction of the layer 2 and then verify the proof of those transaction, layer 2 transaction executions. Okay, so at that moment, that means every blockchain can produce a proof as the evidence that the source or the destination blockchain that this transaction have been included and verified. So you can trust me. You can unlock the assets or lock some assets on the other end. Okay. So basically, the integral app aims to build such a protocol to make sure different blockchain can use proof as the evidence for the other blockchain to move or add the liquidity, something like that. Yeah. Okay. So basically, you also need something like the CCIP to format the message. Okay. So yeah, basically that's the interoperability about multi-chain ecosystem supports. And another thing I just have in my mind is the interoperability with the real world applications. I think this because it's very useful for the real W assets application. Because it's also an answer to your previous question, should we prove every software? So one thing is that we have something right now we cannot prove, right? For take the operating system, for example, we can prove the thread, multiple thread by library operating system, but we cannot prove the interaction between the operating system and the hardware, right? Because we cannot prove the data from the network or from the other hardware that is correct or is follow up some rules. So that means for the ZK VM right now, we still need some abstraction between the unproved word and the proved word. Yeah. So that's another thing I have in my mind about the interoperability right now. Yeah.
Awesome. Well, thank you guys all so much for your time and attention today. Thank you to our wonderful panelists. It seems like we are in great hands when it comes to scaling and moderating our trust assumptions across chains. My name is Evan McMullen, and I will see you all on chain.
A variety of different audits, from smart contracts to ZK related to dApps as well. And recently, Veradice also announced its launch of Audit Hub as well, which enables developers to be able to catch different bugs during their development process. And would love to speak to you more about that as well, John. So thank you so much, John, for being here.
Yeah, no problem. Thanks for having me.
Yes, thank you. So I'm wondering if we could first start off with just some general context about Veradice as an auditing company. I'm very curious to hear about what was the main motivation for founding Veradice, and for you guys using your own in-house tools, and then finally for launching Audit Hub as well.
So part of the reason why we founded Veradice is because we noticed that there were a lot of cases where, auditing was really big and people were performing security services, but really they were doing so in a way that was fairly inefficient, that didn't really scale with, basically the growth of the blockchain ecosystem, which is, by performing manual audits. And so the background that me and my co-founder came from is formal methods, where we created tools in order to automatically identify vulnerabilities in various types of software. And so it started out where, we worked on a formal verifier for smart contracts. And so from there, we decided that it made sense to create a security company that, yes, would operate similar to these other people in the space that would perform manual audits, but also would try to provide stronger guarantees by also using tools during the auditing process in order to provide higher quality audits. And then as those tools became more and more proficient at finding bugs, we decided that it was time to kind of take that those tools that we had developed and wrap them up into a platform that anyone could use in order to identify bugs as they're developing, rather than waiting for the very end of development to say, okay, now what bugs are there in my system?
Yeah, and really love that direction that Veradice is going through, because I feel like for a lot of auditing firms, and the way that these projects are currently developing, they have their development life cycle, and then they'll say release a product version, but then have that be audited all the way in the end, as you mentioned, waiting until the end for the project to be audited. And at that point, maybe there's quite a lot of bugs or different areas that they need to address before they fully launch. So in this way, with Audit Hub, developers can catch those bugs alongside while they're developing, and instead of waiting for it in the end. Got it.
Right. So the way the current auditing process works, where all of the software development is done ahead of time, can lead to issues, because once a bug is introduced and you continue to build on it, then you're kind of compounding the impact of the bug and making it more complicated to fix. And so by considering or integrating security into your development process, you can, one, make sure that your software is more resilient than it would be if you waited until the very end. And you can also make sure that you're shipping at a pace that makes sense and with the features that you want, because we see that in cases where people find out about significant bugs at the end, either they have to delay their launch and get re-audits or something like that, or they end up just taking out entire features that they were planning to launch with.
Got it. And are there any examples so far, or maybe ones that you hope to see in the future, where Audit Hub was able to catch something that a conventional auditing process may not have caught during the process? Any kinds of particular examples?
Yeah, so we've been using Audit Hub internally during our auditing process in order to, identify bugs while we're auditing. And so there are several cases where our tools have identified a variety of bugs in smart contracts and ZK circuits that, might have not have been caught by our auditors, or were caught before our auditors found them, let's say. And so, for example, recently there was an inflation bug that was caught by our fuzzer Orca. And then also another thing that we've been doing a lot of is integrating our ZK formal verifier Picus into the development workflow of ZK VMs like RISC-0. So RISC-0 has been kind enough to act as our guinea pig while we have been releasing this. And so Audit Hub was very useful for us when we were auditing RISC-0, because we were able to use Picus, which is the formal verifier, in order to verify that their circuits are deterministic, which is the most significant source of bugs in ZK circuits. But also it found quite a few, or found several non-deterministic circuits inside of their ZK VM. And reasoning about the constraints of a ZK circuit can be difficult, and having a formal verifier that's there to say that there is a bug and this is exactly what it is, or there are no bugs, was very powerful.
Yeah, absolutely. It's great to see where tools like Picus can really help with that formal verification process. And just as a kind of just giving some generalized context for the audience as well, wanted to hear from you the need for ZK systems, like, for example, all of the ZK VMs that currently exist in the market to be formally verified.
Yeah. So the reason why you really need a ZK VM to be formally verified is because with a ZK VM, you're basically providing the infrastructure that people are going to prove stuff on later on. And so if there's a bug inside of your ZK VM, then anyone who's building on top of that ZK VM, who has a product that is supposed to prove various information, that proof could then be manipulated by manipulating the underlying ZK VM. So rather than going through and figuring out how to attack every single project that's building on top of the ZK VM, you can actually attack all of them by just attacking the ZK VM itself. And so that's why it's critical that ZK VMs in particular are, have the highest degree of security.
Yeah, absolutely. And especially since a lot of ZK VM systems are becoming production ready, and even targeting some use cases, like, for example, in the previous panel, there was some talk about ETH proofs with real-time proving of Ethereum mainnet blocks. And now that ZK VMs are becoming more mature, a lot of ZK applications are looking to be built on top of these ZK VMs. So it's especially critical that these underlying infrastructure systems be audited and make sure that they're ready for production.
Yeah, for sure.
Mm-hmm. Absolutely. And I also wanted to ask you about some of the newest research that's coming up with Veradice as well. I know that the team presented a couple of papers at the CAV conference, so one with ZQL and one with multimod. So curious to hear more about what this new research entails, and then also how you see formal verification and these cryptography-related committees kind of converging together.
Yeah, so basically these were papers that we published at Computer-Aided Verification, which is a conference that's all about using software in order to help you verify other software. And so the two papers that we published were multimod, which basically improves the ability of this thing called an SMT solver, which reasons very specifically about, like formulas that you provide it, to reason about ZK systems by allowing it to do reasoning about different primes. So when you're creating a ZK system, all of your operations are being performed with respect to a large prime. But typically when you're building like a ZK VM or something like that, all of your operations are being performed like modulo 2 to the 260 or 2 to the 32 or to the 64 or something like that. And so what multimod allowed us to do is to improve our ability to verify ZK circuits by taking advantage of the knowledge that you do have these multiple, kind of primes or modulos that you're solving against. Then what ZQL did is ZQL kind of took advantage of the observation that when you have a ZK circuit, you've got constraints and the witness generator. And when you perform formal verification, you always need to verify a particular piece of software against something. And so with ZK circuits, the constraints are really the thing that you want to have security guarantees about. But people are much worse at writing constraints than the witness generator. And so what ZQL does is it essentially verifies that your constraints are performing the exact same computation as your witness generator, so you don't have to write a specification, and therefore provides you strong guarantees about the behavior of your ZK circuit, but also has some nice effects like by proving consistency, which is what we called it, you can also prove that your circuit is deterministic.
Got it. And also in terms of other recent developments as well, in terms of Veritice's in-house tooling, I'm aware that Veritice also released LLZK. So wanted to hear more about the motivation for creating this modular IR framework, especially since a lot of the tooling, especially when it comes to ZK and being able to write these circuits, a lot of it is very fragmented and a bit, all over the place for the developer experience. So wanted to hear some more about what LLZK can provide.
Yeah. So LLZK is basically compiler infrastructure, which is not something that's very, fun to talk about for a lot of people. But at Veritice, we like compilers. And so basically the problem that we had at Veritice and what other companies have is the ZK space is very fragmented. And so you can build something that works for SIRCOM, but then people have moved to Halo 2. Then you build something that works for Halo 2, and then people have moved to Plonky 2, and then Plonky 3, and then possibly Noir. And so that makes it very hard to create infrastructure that works for ZK because you're always just re-implementing things. And so in order to deal with this, we created a compiler infrastructure, essentially, which lets people compile down from the ZK arithmetization that they're working with to this common intermediate representation so that we can, perform, formal reasoning about that intermediate representation, but also other people can build on top of it to do something similar. So you don't have to start rewriting your ZK infrastructure over and over again. And we can start sharing some common parts of ZK infrastructure that's kind of missing, like optimizations and stuff like that is often missing in a lot of ZK languages because people are frequently just moving to the next one. And so any languages that do have the ability to optimize constraints are not used as frequently, and that just means that people then have to hand optimize. And we found that these hand optimizations are more likely to lead to errors inside of the underlying constraints.
Got it. Yeah, and it's really useful, especially as you mentioned, there are so many different proving system backends. And when projects have to migrate, like say if they want to migrate from using the Halo 2 system to some ZKVM based system or some other kind of circuit level writing method, they have to fully migrate and oftentimes rewrite a lot of the constraints involved. So yeah, very great to hear that now there are more ways in which we can provide a more modular and a more flexible developer experience for these teams, as opposed to so many different fragmented proving systems as well. I know that for a lot of ZKVMs, even they have to migrate from Plonky 2 to Plonky 3, and that takes quite a lot of development time for them as well. So really good to hear about kind of how streamlined this new modular IR can enable this process to be.
Yeah. And I mean, that's the goal, is like as new developments come out, people can start, rather than creating entirely new languages to take advantage of that proving system, hopefully instead they can, add a backend to LZK. They can add passes in order to go from some common IR to something more specific. And so that way we can reuse parts of the infrastructure or reuse things that were written before rather than always inventing something new.
Got it. And also wanted to hear just from your side, based on all of the audits that you've completed and all the research that you've done, are there any types of common bugs or vulnerabilities that developers should be aware of, especially for those developers who are building their own ZKVMs or their own ZKDSLs? Are there any sort of things that they should keep in mind of?
Yeah, when it comes to really anything ZK, the most common bug that we find are non-deterministic circuits. And so you need to spend a lot of time making sure your circuits are deterministic. And that's why we created a formal verifier in order to automatically verify determinism. Once you have tackled determinism, though, there are other things that you need to worry about. And so with ZKVMs, the nice thing is they're normally built off of, or they're referencing some well-defined infrastructure or well-defined ISA or something like that. And so like they're targeting RISC-V, they're targeting MIPS and other things like that, which have instruction set architectures which are very clearly defined. The semantics are known. And so at that point, the most common thing that you would see would be some of the semantics implemented inside of the ZKVM not quite matching the intended semantics of the infrastructure that they're trying to implement. And so in that cases, you could have deviations in the behavior of the application that you wouldn't expect.
Got it. And so there's some deviation. You mentioned deviations with what's being developed versus the behavior that one can expect, especially with these ZKVM systems.
Yes.
Got it. And curious to hear also, just a follow-up on that, are there any specific bugs that are unique to ZKVMs that you see commonly happen as opposed to, say, SIRCOM or some kind of ZKDSL, or just like vice versa as well? Any types of common bugs or other areas you found in those ZKDSLs or for languages like SIRCOM that maybe aren't present with ZKVMs?
Yeah, so in the ZKVM circuit itself, not really, because once you get down to it, the ZKVM is just another ZK circuit. And so similar to other ZK infrastructure, you're seeing things like non-deterministic circuits. You can see things like field overflows, or in some cases, you also have over-constrained circuits where there are some valid programs which wouldn't be interpreted. And so that can cause issues, but it's also things that we see in ZK. And so really, when it comes to something specific to the ZKVM, we're talking about logical vulnerabilities, which can happen in any particular application because it's specific to the application that you're implementing. And so in that case, like an example would be, not strict adherence to the underlying instruction set architecture. If you're talking about like people who are instead of building a ZK circuit, are building a ZKVM though, then, or building on top of a ZKVM, so they have like a guest program that's running in a ZKVM, then we see different common vulnerabilities. And yes, you do have things which are common, which differ from ZK. And in many cases, that's things like people who, and this is kind of similar to ZK, but people who are not actually proving what they think they are. And so in some cases, with a ZKVM application, you have an untrusted host and a trusted guest. And the trusted guest is going through the proving process. And so one of the common vulnerabilities that we see is someone using information which does not eventually flow to the underlying proof to be checked and is assumed to be safe.
Got it. I see. And just as a last question before we end today's interview, for any type of ZK teams in the audience, and we have quite a lot there, do you have any kinds of advice or any points of guidance that you'd like to share with them in terms of as the ZK systems that they're building are becoming more mature and becoming ready for production grade applications? Any types of advice that you'd like to give for those teams?
Yeah, I mean, I think most of them know this anyway, but security is critical. This is because oftentimes what we see is people, kind of offloading into ZK circuits some critical part of their infrastructure. And so for that reason, you really need to make sure that the infrastructure that you have running off-chain is free of bugs. Otherwise, it's very difficult to determine what actually was intended to happen on-chain, and sometimes it's difficult to detect on-chain. And so for that reason, especially when you're dealing with things like privacy, it is critical that you make sure your circuits are acting as they are intended. And so for that reason, at Veradice, we performed a study in order to see how frequently ZK circuits have significant bugs, and we found that they were about twice as likely as DeFi projects to have bugs. And so that just shows how frequently this common or this critical infrastructure has things that are going wrong with it. And so using more security techniques that provide you with security guarantees is critical for ZK.
Got it. So the more security guarantees with the techniques, the better it is.
Yes.
Got it. And thank you so much, John, for all the insights, especially with this topic of our conference today with verifying intelligence. A large part of it is also for the auditing part, how important it is to be able to audit our systems, whether it be ZK systems or even AI-based systems, and make sure that they're ready for applications to be used by everyone. So thank you so much, John.
Thank you.
Yeah, thank you, John. All right, thank you, John, again. And next up, we have a keynote who will be presented by Shiv, CEO of Boundless.
Hey folks, thank you so much, my man on the computer helping me with the slides. Hopefully everyone can hear me. Yeah, so that's me. My name is Shiv. I'm the CEO of Boundless. Next slide. This is my third token 2049. This is me 18, 19 years ago in Singapore studying here. It was the wild mustache phase, and that was a little robot I had built as my first ever project at NUS. I'm an NUS graduate, proud to be an alumnus. I lived here for a decade. I was an early engineering manager at Grab, which is of course an application that everyone in this room is using. Back then it used to be called MyTaxi, but followed it through its evolution. I've also worked at Amazon, Microsoft, Coinbase, Lyft, a bunch of other places. My background as an engineer is in database systems. And as an executive is in designing marketplaces for digital services, for real world services, and so on. My wife is also from Singapore, so in a lot of ways I am Singapore native. Next slide. Today's agenda, I'm just going to do a quick recap of our journey to mainnet, what it took for us to get there, the challenges that we faced, why mainnet looks the way it does, and of course also focusing on, or rather giving you a teaser of what happens post mainnet and what we are looking forward to. Yep. Cool. So a lot of you might know or may not know this, that the Boundless team was, of course, incubated inside the RISC-0 team. And RISC-0, of course, was the inventor of the ZK VM. In a lot of ways, putting together the best ZK tech and also figuring out how exactly ZK should be delivered to every customer, to every application, to every dApp, and so on. So much so that I think that we've created like the standard. 20 months ago, there was just one ZK VM, which was us. 19 months ago, it was 2. Yesterday, we counted, it was 38. No one knows how many more they're going to be. Now, the real question is now, is that what product market fit looks like? The answer is a bit nuanced. It's always been the plan for RISC-0 to build the standard. We always knew that like if you built an open source ZK VM and gave it away to everybody, you can't actually build a moat around it. But what we can do is inspire standards, because what you should be doing is building add-on services on a standard that everyone approves and adopts. The metaphor that I use with venture capitalists, some of my venture VCs are actually here, is don't sell engines, sell cars. That's what customers are actually in the market for. They don't really want to buy ZK. They want to buy something that enables their application. They want to buy add-ons that make their apps better to use, safer to use, and so on and so forth. So whilst we invented a whole category of ZK, we're in the business of packaging it and selling it, which is Boundless, which is the finished product, a completely decentralized, permissionless protocol that delivers ZK to every chain. We are chain agnostic. We're not just one camp or the other, to every app and dApp and every builder. It's very important to note that you need all 3 of these facets if you want to build a successful ZK protocol. And of course, like the way we wanted to test it out in production was with mainnet beta. We personally feel that testnets have gone through like multiple phases, where now it's basically about engagement farming. People just kind of like fool around with games. What we wanted to show was what it actually looks like when you actually put funds to the test and run it with real funds. And we went live. And that's when we really got to showcase the strength of our network. We had over 2,000 provers. We were doing 80 teracycles per day. Now, here's the interesting thing. Because of the power of token and how crypto actually operates, the median price of all proofs was $0. Here's another fact. P90 was $0. P95 was $0. I don't expect that to happen in mainnet, but it really started showing the power of decentralized and permissionless markets. Some of you might have done Econs 101. You might remember that in perfect markets, the price of a commodity actually goes down to its cost price when there's full competition. That's what we started seeing. That gave us more and more confidence as we moved towards mainnet. And that's what we did. Boundless went live on September 15th. ZK Coin is our ticker, and it is a proud moment for the entire team. However, this is what the team looked like on September 16th. But in a lot of ways, like whilst we were extremely tired, we were also enthused to put the final piece of the puzzle together, which is proof of verifiable work on mainnet. Proof of verifiable work is our novel primitive that actually allows us to reward prover activity on our network in a very fair and programmatic fashion. Every epoch, essentially, we are able to calculate how many compute cycles everyone provides and fairly reward them for the cycles that they contribute to the network. This is differentiated from a lot of other networks where they have competition. So everybody is trying to prove the same thing, and whoever gets there first gets a reward. Or proof of work, which is Bitcoin's elegant solution without ZK, where you only have one winner per epoch. That really sets us apart and is the foundation on which Boundless is built. It also heralds the arrival of ZK mining and of abundance. ZK mining has become its own, they would say, meme or its own vibe. I guess is what the younger people say. The essential thing being that like a lot of people who have spare GPUs in China or like different parts of the world see this as a great opportunity to join a permissionless network and operate their machines and offer useful work for tokens and pay. Looking beyond, this is my final slide. We launched mainnet. We launched mainnet beta. It's been like, you know, I would love to take a vacation. Some of my marketing folks here are like hinting at vacation. It's not happening. Where we're headed right now is to improve our stability. We're already at 3 nines. 3 nines is pretty much gold standard for most SaaS services. 4 nines is AWS territory or Google Cloud territory. Got to fix that real quick. And that's something. No. My friend, let's go back. Yeah, thank you. Wrong signal. And then really move towards VM diversity. One of the key reasons why Boundless and Risk0 were separated as 2 entities is this actually allows us to be non-aligned with like one VM technology. We're a little bit humble in that, like, whilst we created a whole new ZK category, we also know that we can't outcompete 1,000 teams. What we wanted to build is a vessel where these teams can come and bring their technology. So we want to be multi-ZK VM. VM diversity is extremely important to us. DevX, this is probably the most underrated aspect of ZK. We've already taken it 1,000x from going from circuits to Rust, but there's a whole new paradigm left for us to explore. We're really chasing the Ruby on Rails moment for ZK programming. And then, of course, cost. Cost keeps going down for us. I actually put down 5x here, but you give, because all of us are friends and that half of the room is really not listening. I'm really chasing 50x with the arrival of ASICs and so on. So that's really the focus for the next 9 to 12 months and where we are headed.
All right, thank you so much, Shiv, for the keynote. Next up, we will have our third panel for today. And we have Kashfi, also from Boundless, who will be moderating. And our panelists are John from Paradise, Randy from Ontology, Steve from Aztec, and Remy from Inco. So please welcome all of our panelists.
Steve, he's on his way.
Hi.
Sorry, everybody. You're fine. Hello and welcome everyone. Welcome to House of ZK X Boundless, Verifying Intelligence, or as I like to call it, Verifying Intelligence. Today we have a stacked panel with some of the most well-known voices in ZK, and we're going to talk about confidentiality and compliance and how you can essentially balance both. Let's go from right to left with quick intros. Who are you, what do you do, and why ZK?
I don't know if we'll be verifying each of the panelists' intelligence today, but we'll see. You know, proof size too big to do that. Anyway, so I lead media Aztec. I've been banging my head against the compliance on blockchain wall for quite a while now. I was working at Avi 4 years ago on this problem. So trying to get DeFi, or trying to get institutions into DeFi back then, to varying degrees of success, I would say. I would say probably, so Avi Arc was a permission chain, and I'm probably taking up too much time already. I'll get to the point. That was set back by FTX, the whole kind of institutional compliance space, which made me look at the problem again. And a lot of the feedback we were getting was in relation to privacy. And therefore, I went down the ZK rabbit hole and came out on the Aztec side. So I've been leading Aztec BD for the last couple of years.
That's awesome.
I am LARPing as Remy. I'm here representing him. But yeah, my name is Kate. I am head of community at Inco. Inco is the confidentiality layer for Web3. And yeah, I mean, institutional compliance, balancing that with privacy is kind of our raison d'etre. So yeah.
This is Randy from Ontology. So I think Ontology is one of the OGs in the space because our project starts in 2018. So it's been over 7 years. We focus a lot on decentralized identity from day one. We have a public blockchain. We have an Onto wallet, which is an identity wallet and also a multi-chain wallet. We also have an Orange protocol, a replication layer built by the same team. So we are trying every effort to provide a suite of the products to facilitate the ZKs and identity.
Hi, I'm John. I'm the CEO of Veradice, and so we are a security company that has worked a lot on securing ZK circuits. And so basically, I'm here to talk about when ZK and privacy goes wrong, because that can happen.
John, let's start with you. My first question is about, can blockchains and privacy truly coexist? And if yes, how? I know that this is a basic question for many of us, but let's break it down because I think that's what where the main case for ZK, use case for ZK is created. So can privacy and blockchains coexist?
Right. Privacy and blockchains can coexist, and we've seen a lot of people who are, bringing privacy to blockchains. I mean, I think that if I said it can't exist, then, the rest of the panelists are probably going to get pretty angry at me. The thing that I'll say, though, is that privacy in blockchain is a very hard problem, because not only do you have to worry about explicit privacy leaks, but you also have to start worrying about implicit privacy leaks, where depending on the application that you're building, you have to start worrying about some things like constant time computation and stuff like that in order to ensure that you aren't leaking any privacy by just how you're performing the computation itself. And so you can definitely have both, and you can have it with ZK and in some other ways, but it's definitely something that is hard and requires, a lot of smart people to look at and make sure you're doing it properly.
Rainey, anything to add there?
Yeah, sure. Absolutely, they should coexist, right? I think privacy is not about hiding everything. It's about provide necessary information that is really required. So I think that privacy and blockchain can actually complement each other and drive the adoption of Web3 in some ways. And people are coming for blockchain mainly because they can protect their privacy with the most advantaged technologies.
Yeah, I mean, I think obviously we talk about mass adoption, and I think we're kind of at this, turning point in the industry where if we actually do want mass adoption, it's going to be enterprise, it's going to be institutions, and there's really no way that banks and large conglomerates are going to, do any sort of meaningful on-chain activity when all their positions are public. It's not going to work. So I think, it is possible, right? Privacy and compliance can exist. I think there's two, in my opinion, there's two main components. One is on-chain prevention, right? So stopping bad actors, and this can happen at the blockchain level. This can be programmed, at the blockchain level, the asset level, the application level. It can happen at the withdrawal phase, the deposit phase. There's a bunch of ways to do this, and then the other side is auditability, right? Who has access to the data? How is it handled? Who has the decryption keys? And, I think we're still in the process of getting that right? We're still, this is all very new. But I think, if we do want any sort of meaningful institutional, larger scale adoption, we really have to stop thinking of these two things as being diametrically opposed and start moving forward, designing systems with compliance baked in, and not kind of retroactively trying to affix, compliance to applications that we built, but building them out with compliance, in mind.
Thank you, Katie. Steve?
Yes. So I think privacy and blockchains can coexist. I'm not sure that privacy and EVM can coexist. Which is maybe a spicy take. Basically, metadata leakage isn't conducive to privacy. Like any metadata leaking is akin to surveillance. And so that's why we built our own VM. And going back to the original question, can they exist? Yes. Will they exist soon? Yes.
Aztec fair market launch coming up next month. Heard it here, ladies and gentlemen.
What are the types of user data that need to be protected with ZK and privacy? Yeah.
Yeah,
And
so
then we
there's
can
three
go to
different
Steve.
levels really. So you've got the like the transaction data, so information about the asset, so like size of transaction, type of asset being transferred, and then there's the transactional identity-based data, so who the receivers are and senders are, and all of that stuff can be achieved in an EVM compatible way at the minute, and you're starting to see that. But the really, really tough piece is the transaction logic data. And so that relates to call stack privacy and the contracts that users are interacting with. And like in our view, you need a comprehensive, holistic approach to all three of those pieces to achieve like full on-chain privacy, just because there's so many monitoring tools these days. And so if you leak any metadata there, it's very, very easy to track that information back to who the original user is.
Thank you. Katie?
Yeah, I mean, I completely agree. I think, privacy is a sliding scale, right? Like pseudonymity is kind of the default. But, you can do everything from hiding the amount of money that's sent to hiding the sending, that's kind of the first layer. And then full privacy, right, is hiding the amount of money that's being sent, the sender and the receiver. And, this can be done using ZK, TEs, FHE. But yeah, I mean, nobody wants their entire financial history, completely visible. This can also, it can affect your safety, right? We've seen like the CEO of Ledger being kidnapped. If you're buying something here in Singapore, that could signal, well, I'm not home, right? So there's no one, watching my house. And so, yeah, I mean, hiding people's, you should be able to opt into privacy when, and it be compliant. You as a user shouldn't have to worry about that, But yeah.
For me, I would say identity information and of course financial records. So there's some scenarios that people must finish the KYC to some reasons. When they enter into the centralized exchanges, when they got to create a crypto card. These are very essential to be fully compliant with the AML restrictions. But are they necessarily to like upload their passports to the platforms? They know everything. They know your name, your date of birth, that what's your nationality. These are not necessary for me. And it makes sense for people to generate like a ZK-approved verifiable credentials. Show that to the platforms that I'm legally fine. I'm a legal resident for a certain nation name, and then they should be good to go. And while for the DeFi world, that I think like your transaction records, your wallet balance, there should be some ways to protect that as well, because nobody's want to showing to everyone that I have $10 million to the public. But when they need to access to certain like DeFi protocols, which they can earn better yield, or they can access to some VIP services, they still need to prove that. So for me, these are the two important information criteria.
John, what do you think?
I mean, for me, it's not really up to saying what should be private. It's up to me in order to make sure that what people think is private is actually private. And essentially, the thing to remember here is that, privacy is very easy to lose. And what I mean by that is once you have so much information out there, that information can kind of easily be correlated in order to uniquely identify you. We see this happening in a number of spaces. So for example, in browsers and stuff like that, people can look at, patterns in different websites that you're visiting in order to more or less uniquely identify you. You can imagine similar things happening in the blockchain space where if, there's some people who are associated with a well-known address and that address is public, you can start, correlating location information and use that to de-anonymize people. And so really, like I said, that's more what I'm here for, is saying blockchain is, or because of the amount of visibility that's here, it's very easy to lose privacy, and it's important that you're considering kind of all of the side effects of what you're allowing people to make public.
Since we've established that it's actually very easy to lose privacy despite it being a use case that many of us market, let's talk about how it's regulated and who is doing the regulation. There's obviously on-chain validators that we have, but there's also like governments and stuff that are involved in holding people accountable. So are any of you actively speaking with regulators, and can you give us some insight on what regulators think about ZK?
So nobody's willing to tell something about regulators, right? I think it's interesting is that regulators are curious about ZK proofs, but they are very cautious as well, because they don't want ZK technology to hide anything illegal or do so. Some regulators even think that Tadona Cash is like a giant for them to protect, knowing the truth of where the money goes and how you deal with the money. I think for now, it's very necessary to get some clear standard about the selective disclosure and also verifiable credentials. Just let us know that to what level of the information you can actually trust. And then we would know that how the technology could meet that requirement and actually making it more efficient for the regulators in some ways. So we still need to do a lot of stuff. And the second, I think that it's very necessary for all of us to build some experimental, maybe in sandbox, to show them that we can solve it and you can trust it. That's very vital as well. And the third thing is that we probably need audit in some ways, because they can using a third professional party to let them know that all these actions can be audited and you can trust it.
Yes, so I mean, we've done a little bit of work trying to educate regulators on that. We collaborated with A16Z to jointly submit a response to the Bank of England's inquiry into the digital pound. And whereas I'd be skeptical, obviously, any of this stuff is going to be implemented very quickly at government level, like they are definitely starting to take an interest. I think maybe stepping back a little bit more, where ZK is super useful is connecting Web 2 identity with Web 3, right? Like if you take Web 2 identity, like any credential, or you can create a proof of any credential, right? Anything that you sign with a public key, anything online, you can create a proof of that and bring it into Web 3 world. And I think that's where it's going to be especially interesting. It's like linking your Web 2 identity to Web 3. And of course, we're trying to do that in a privacy preserving way. And these are the types of things, these are the type of things that are going to get regulators comfortable. Like if we can verify to them that a user has been through a certain check, is the owner of a certain attestation, and do that in a privacy preserving way, I think that's a nice middle ground.
Anything to add, Katie, John, or do you feel like we have it covered?
I mean, I don't really have to deal with regulators, which is great. So.
You are the regulator in some ways, one type of it at least, with the audits and everything.
Yeah, I guess, but I don't have to deal with governments or worrying about convincing people of technology. So I'm happy.
What are some of the most viable real-world use cases of ZK that you're seeing are being put into application without blocking compliance? Do you want to go, Katie?
Yeah, I mean, decentralized ID, I think that's a huge use case. It's a way to, verify who you are without having to leak all your, I just flew in from India and I landed at the airport and I got a SIM card. And to get the SIM card, they had to take a picture of my passport, take a picture, of me with a black, behind a blank wall. They needed my father's information. And this is just like some, airport attendant with their phone, So, I think we have, this insane technology and there's opportunity to, use it for good. this can, once you verify yourself, you can do things like on-chain voting, right? You can kind of whitelist yourself to access private payments and stuff like that. So, yeah, I would say decentralized ID is my answer to that.
Yeah, and a specific example of that is ZK Passport. So ZK Passport utilizes Aztec Stack. It's built in our programming language, Noir. And we're going to be putting it to practice as part of our launch. So you'll get a chance to try it in the wild, hopefully. That's one example. And I wish it is an example that existed when I was back working in the Avi days, because like going back to the DeFi stuff, like when we were trying to onboard institutions then, all of the KYC would happen off chain. And so like that was one of the most that was one of the highest points of friction, let's say. Like it's the whole transferability piece that hopefully is going to make it easier for people. So yeah, that's kind of what I'm excited about.
I agree with the DID, and actually Ontology has made it happen because we do have the DID that minted Ontology EVM. So users basically can use their Onto wallet, the applications, to generate their DID as well as the verifiable credentials. And all the information stays on the client side. So the users can choose what to review. It's not on blockchain, it's not on the internet or any server. And then the Orange protocol provides them a way to use the zk-TLS to verify these VCs. So there's already a lot of ways for people to actually use it. But the next question is more about regulators. That's how they treat them.
Yeah, I mean, I guess for me, the projects that I tend to like the best are the ones who are building infrastructure that make things easier for other people. So writing ZK is very hard, and anyone who's building infrastructure that makes ZK easier to use are the ones that I, tend to pay attention to the most. And so this would be like people writing ZK VMs, people writing ZK DSLs, that sort of thing.
Speaking of which, what are our biggest obstacles right now in terms of helping ZK go mainstream and having worldwide ZK adoption? Is compliance one of them, would you say, or are there other bigger things that we might be overlooking or not talking enough about?
I guess I can go first on this one. I think that there's a lot of things that are kind of standing in the way of adoption of ZK. So first of all, it's hard to write ZK proofs. Like it's hard to write the actual ZK circuit itself. And so there have been attempts to make that easier, and there is a lot of work there, which I think is really exciting. Other things that I think are kind of standing in the way are things like proving times, just because, we can certainly do quite a few things off chain, but, you can't do everything off chain because sometimes proving times are going to become prohibitive. And so continuing advancements in, the underlying ZK cryptography is pretty critical there if you want to move everything on chain or to prove everything. And then, I don't know, it seems to me like regulators are pretty against ZK, so, or privacy, I guess, not necessarily ZK, but yeah.
Compliance always is a big issue, right? But another thing I think in the barrier would be people's mindset, that people would pay attention to their identity, privacy, and data to some degrees. We have the GDPR in Europe, also CPFC in Los Angeles, US. But in the crypto world, I would say that people are more willing to use some protocols that can help them making money to some degrees. While for the ZK and decentralized identity, there's no such like fortune impact for them. So it somehow prevent them to trying it out, even though they are very essential. But on the other side, I would say that with compliance development, more people are paying attention to how to give the right data to the right person and right authority. So there will be more adoptions, I believe.
Yeah, I mean, I think the obvious one is interoperability, the technology itself. But, on the compliance side, like the technology is universal, right? But KYC looks very different in different countries, right? The KYC process, for me in Canada is going to be vastly different than, somebody in, this part of the world, right? And then you start getting into, communities that maybe don't have standard forms of ID, right? If you look at Kenya, with M-Pesa, they've kind of bypassed KYC by actually going physically to the store to top up their accounts. The store owner knows you, and then that's your KYC process there, right? So I think in terms of actually, achieving kind of ZK solutions at scale, like I said, the technology is universal, but, compliance and KYC and regulations vary, very, very, very vastly between countries. So, that's going to be kind of a difficult but necessary piece of the puzzle.
Okay, I have a follow-up question after Steven.
Yeah. Well, I think if you asked me 8 years ago when Aztec was getting started what the hurdles were for ZK adoption, the answer might look very differently. But we've literally invented the maths to enable us to do a lot of this stuff on the client-side proving side of things. Mobile proving is now possible in milliseconds, no less. Is that quick enough? So we've got there on the technical side, but I think if I maybe step back and think about kind of the broader mission, we want to onboard retail and normies to on-chain, right? And so I think a lot of it is still in the education, which is kind of a boring answer, but then also in the the tangibility. It's difficult to make people actually feel something when they're interacting with ZK, right? I think we can have all of the ZK passport stuff, but it's very difficult to give people the sense that none of the information is being collected, that they have privacy when it hasn't existed before. So, I mean, this is a problem more broadly. I think people are kind of willing to give up privacy in everyday life because you don't know what you've lost. But I don't want to get too philosophical, but this is where we get into the fabric of society slipping away slowly. But yeah, I'll leave it there.
You're not wrong, though. That's where Claire comes in and I come in, and we try to build narratives around privacy and ZK and try to get people to care, because education truly is such a crucial pillar of, making people care about ZK in the first place. Compliance comes after adoption to an extent. So it is one of the biggest challenges, I would agree. My question, in a sense, to wrap this up is, how are you guys balancing confidentiality with compliance, which is what we're talking about here? But as Aztec and Inco and Ontology and Verdize, what is your stance on this right now, and how are you essentially balancing things?
Natural instinct. So on the Aztec side, Aztec is aiming to be unopinionated infra. So our approach to compliance is credible neutrality. Aztec's launching fully decentralized next month. If anyone wants to come and run a sequencer, you should do so. And that's the biggest thing for us, the credible neutrality piece. Aztec is just infra. Same way telecommunication networks is just telcos. It's just infra, enabling new technology. And as it relates to compliance, if you're an application developer, if you're a user, if you're a CFI operator, a bridge, all of the tools exist on Aztec to allow you to meet your individual compliance requirements. There's viewing keys, all of this stuff, selective disclosures. You can privately verify someone's been through KYC, but Aztec itself isn't doing any of that. Aztec is unopinionated infra, it's credibly neutral.
Yeah, I mean, I'm with Inco obviously, and we're in the same boat, right? We're infrastructure providers, we're dev tooling. We're not the ones completing KYC checks. We're not issuing tokens. We're not custodying assets. None of that. What we allow for programmable privacy, right? If you want to create a wallet application where just the amount of money is represented as a hash on chain and is hidden, you're able to do that, all the way up to full privacy, which is the sender, the receiver, and the amount of money is hidden on chain. So, the way that we do it is you don't have to learn a new language. You can code in Solidity, and you can make encrypted function calls through our libraries. So before you would call uint or a Boolean function. With Inco, you'd call EUINT or eBool, so encrypted versions of those functions. So, creating programmable privacy that's very developer friendly, and giving, developers flexible access to create whatever, kind of privacy preserving protocol, application, whatever that they want.
So rather than the infrastructure layer, we do have, because we are layer 1, we also have a couple of the developer protocols like Orange. But on the other side, that we are trying to build some POCs or use cases for really end users. So that's the reason that it's pretty easy for everyone to download the wallet. For Onto Wallet, it's pretty similar. Like you use Trust Wallet, OKX Wallet, whatever the wallet is, you can use it to manage your assets. But on top of that, we have an identity mode where users can generate their DIDs, verifiable credentials. And we are working with a third-party KYC providers where users can actually do the KYCs and generate that species. So these efforts are trying to give people a way to actually try out that how ZK can change their life and change their way that's managing their data and privacy. And I think that once there's bigger use cases that we guys work together, that will be a really show off to the audience that you can actually use it and access it.
I mean, similar to the infrastructure providers, I don't have to worry about compliance. The only thing that I will say is, the people who come to us for an audit, might, or in some cases do need to worry about compliance, and we can help make sure that there's not a way around that compliance which can get them in trouble with regulators. But, that's not something that we advise on.
Awesome. Thank you so much, everyone. Does anyone want to share any closing thoughts or any final statements, or do you feel like we have it covered? Katie?
Yeah, I think, like I said, we're at this very interesting turning point in the industry. And I think, being compliant to regulations is the necessary next step to really kind of create these privacy preserving applications and use cases that the industry needs. So yeah, I mean, compliance and privacy, I think, can go hand in hand. And, at Inco, we're working to do that.
Amazing.
Yeah, our CMO is sitting in the front row here, Claire. So be remiss of me not to just shill Aztec's launch one last time next month. What was I going to say? So this will be the first time that you're able to viscerally feel privacy preserving ZK. So I'll leave you with that closing thought.
Thanks, Steve. Randy?
Yeah, I think that there's need to be some joint efforts with everyone in the house today. There need to be more education series, no matter from your Twitter threads, your blogs, your Twitter space probably, and the events like the House of ZK holds. So there should be a way for us to educate more people to taking attention to their data and to ZK TLS. So let me give an invitation here is that Ontology is hosting the privacy talks every Thursday. So if everyone is willing to share your thoughts, let me know. Yeah.
That's a very fascinating CTA. John?
I mean, I guess I'll just reiterate, it's easy to lose privacy. And so if you are developing something that requires privacy, it's important that you assess and make sure that you are actually preserving privacy and you don't have things like implicit information leaks and stuff like that. And so it's important that you get your software evaluated, and I would say also because it is really important that you use tools that can automatically identify privacy leaks.
Awesome. Thank you so much, everyone, for your time. We appreciate it, and this was a very insightful panel.
Give a big shout out to House of ZK for hosting this event and for doing all the different types of podcasts and information things. That's really helpful.
Really excited by what House of ZK is putting together. I think ZK is going to eat the world.
Warm thank you to the House of ZK. I feel like there's a lot of synergy in the missions of the two projects.
One thing I wanted to plug real quick is the House of ZK eProof Summit event, which is happening in Berlin very soon. June 10th. I think it's going to be a fantastic event.
Yeah, thank you. We've seen a lot on Twitter of House of ZK over the last several months, and we're very excited to finally be on.
Yeah, absolutely. And thank you so much, Shorty, for joining us on our House of ZK podcast. Yeah.
I mean, I was excited for another dedicated ZK podcast is awesome. We need more of this stuff. So guys, awesome job. Thank you for doing this.
So very excited to be here. ZK is one of the topics that actually got me into Ethereum, and it's something that's very close to my heart.
Thank you, Ming, for having me here. Thanks to all the audience, and really great to be here.
And also I want to mention a big thank you to Ben from House of ZK and ZKM for organizing this entire conference. We wouldn't have this without him, so really appreciate his work in here.
If you guys have the magazine that was printed by House of ZK, there's actually a very nice image on the Bob side that actually explains how BitVM works.
This is just a great fun series where we are going to explain
Alice from the previous panel and for Kashfi for moderating. Next up, we have a keynote that will be presented by Ishmael from Lagrange. So thank you so much, Ishmael.
Thank you so much. And thank you so much, everyone, for being here. You know, Lagrange was one of the first companies to really begin to commercialize technology at the intersection of AI and zero-knowledge proof. And it warms my heart to see such a large focus of the space on verifiable AI, but intellectually honest verifiable AI. Not verifiable AI designed to launch a token, or verifiable AI that has some consensus of validators that are generating an excuse to launch a token, but intellectually honest verifiable AI secured by cryptography. And I hope nobody here minds me saying that Lagrange is the company that is at the frontier of verifiable AI. From independent benchmarks, DeepProve is 1,000 times faster than our closest competitors. And we've been very fortunate to be able to actually prove frontier models like GPT-2, which we announced previously. And today, we're excited to announce that DeepProve has reached a new milestone and set a new benchmark for verifiable AI. As of today, Lagrange can prove Gemma 3, the frontier model from DeepMind, that is open source at least. And we can prove that in a set of benchmarks that are commercially viable, and we believe open up a new frontier of applications for verifiable AI outside of crypto. For the first time, you can take a popular LLM, one that you might actually use in a Web 2 context, and you can make it private and you can make it verifiable in a way that lets you use it in security critical settings. Now, let's start with a very simple question. Why does proving AI even matter? We have a whole day dedicated to it today, and we have about 4 or 5 companies that are making a stab at trying to do it. It matters because AI is the foundation of intelligence systems in security critical industries, all the way from aerospace defense and kill chain relevant autonomous weapons, all the way to healthcare and diagnostic models. The use, please go back, yeah. The use of AI within security critical settings is only expanding. And the only way to ensure that it operates such that consumer preferences and security principles are protected is through advanced cryptography. Cryptography secures the modern internet, TLS over HTTP. The foundation of everything that we rely on in the modern internet, from e-commerce to online banking, is protected by cryptography. And naturally, the only way to ensure that AI systems at the frontier of machine intelligence have the same properties of security and privacy is through building cryptographic systems to protect them. Next slide, please. Wonderful. So what does ZKML actually solve? Very broadly, there are 4 things. Firstly, accuracy. How do I ensure that the model in question, with respect to a given input, has produced a certain output? How do I ensure it hasn't been tampered with? How do I ensure that it is audible and that there is a chronology of that inference? Number 2 is safety. How do I ensure that if I use this output in some system that has large-scale downstream ramifications, think of autonomous weapons, healthcare, really anything within enterprise finance, how do I ensure that that AI input that is being used to change some property in another system has correctly originated from the right model? Then number 2 is integrity, and number 3 is integrity, number 4 is privacy. Privacy is a big one, right? How do I ensure that sensitive consumer data isn't leaked to large cloud providers or data aggregators? How do I ensure that if a hospital is using an LLM to diagnose a common illness, that there isn't a third party who can take that data and resell it? ZKML is a technology that allows that to be solved in conjunction with things like MPC and FHE. Now, today, as I mentioned at the beginning, we have extended our library DeepProve to be able to support Gemma 3. The first time that any company building ZK machine learning systems can actually prove a frontier LLM model. We can do this through massive improvements to the underlying infrastructure and massive efficiency gains through parallelization and GPU optimization. And we can do this now in settings ranging from healthcare to defense to enterprise AI to crypto. So for those of you who are interested, I recommend you check out our GitHub library where you can take Gemma 3 and run it through the model. So you can take Gemma 3 and run it through our prover and generate proofs of correctness of the output, which allows Lagrange to effectively be a verifiable AI layer for all of crypto and for all of Web 2 applications as well. This is a fundamental breakthrough. We've seen ZKML systems for the last 3 years operate as little more than science projects. They're hackathon curiosities, and they are intellectual experiments created in university labs or early stage companies seeking their first rounds of financing. Lagrange launched a token earlier this year. We are one of the largest ZK companies in the industry, and we are the only company that has commercially been able to advance ZKML to the production level. We've announced fantastic works earlier this year with teams like Intel and NVIDIA, and I recommend everyone here stay tuned for some very large commercial announcements in emergent sectors over the next few months. But the backbone of this is our ability to prove frontier LLMs like Gemma 3. What makes Lagrange different? The last milestone we demonstrated was GPT-2, which is an older model, an older model architecture, but we claimed at the time was a sign of Lagrange's ability to very soon prove the frontier. And today, we show that prediction is accurate. Gemma 3 being Google's frontier open source model, or frontier open source LLM, and today we can prove it. Today you can take a real world application all the way from a chatbot that you use for consumer financial payments in a bank, all the way through to a complex decision model that you fine-tuned within an autonomous drone or autonomous warfighting system. And you can add verifiability and privacy on top of it. Next slide. This required a rather substantial improvement in the core infrastructure. We had to take the deep proof library and effectively double the number of parameters that we can prove. For the current benchmarks that we have released online, Lagrange has been able to prove Gemma 3 and the 270 million parameter version of that. This required us to embrace new levels of parallelism and new levels of GPU architectures, as well as to build a variety of new modules, write circuits for a variety of new modules within our Onyx representation that we use for proving models. This required things like group query attestations, attention layer for global and local orchestration, rotary position encodings, root squared mean norms, and gate linear units. For the sake of brevity, and not to bore everyone here, we won't go into each of these, but I recommend you read our blog, which will be published concurrently with this talk for those of you who are interested in these technical fundamentals. But to summarize, what this means is verifiable AI is here. Not verifiable AI with some scammy token staking, but verifiable AI with cryptographic security. The same type of cryptographic security that protects the web, internet payments, e-commerce, and the foundation of modern blockchains now protects AI. We're going to be announcing soon some very, very large partners across healthcare, enterprise AI, and aerospace and defense who will be embracing cryptographically secured AI at the frontier. And the frontier of industries that are security conscious outside of crypto. So what's next for Deep Proof? Well, we're going to continue to expand the LLMs and model architectures we support, all the way from computer vision and drones to other commercially frontier LLMs, things like Llama, Falcon, Mistral, and more. Expect more announcements surrounding this soon. And for anyone here who is potentially building something that requires cryptographically secured AI at the frontier, feel free to reach out to us. Our team is happy to help, and our team is happy to provide developer grants. Now, what I want to end with today is that the applications of verifiable AI and cryptographically secured AI specifically are not just crypto. There is a tendency to try to build technology for peer problems. When you look around crypto, there's a bunch of persistent problems that our peers are trying to solve. And the majority of companies going after them have yet to look at what the largest market for their technology is. We've spent about $1 billion as an industry building ZK for launching new tokens and making blockchains faster. It is an uninspired and rather small and limited application of what is a fundamentally new paradigm for securing computation. Lagrange believes that that is the old way of thinking. That is the past. We already have dozens of ZK rollups and dozens of ZK rollup teams that have had various levels of commercial success. What the frontier of cryptography is taking what has been financed and developed in crypto and applying that outside of crypto. Bring that to enterprise AI, bring that to healthcare, and bring that to aerospace and defense. Lagrange is the company not just building the future of cryptographically secured AI, but we're the company that is commercializing that within sectors that crypto companies have never entered before. If that excites you, reach out to our team, build with us, connect with us, and learn more about what we're doing. Thank you all for coming here today, and I look forward to seeing what many of you build on top of our technology.
Concerned about fake identities, fraud, or privacy leaks in Web3? Discover Ontology, Web3's trust layer. Trust starts with decentralized identity.
Breaking news tonight from Pandora, where GPT rate limits have been mandated. This is a developing story.
The next chapter of AI should be defined not by how large model is, but how human aligned it is.
Black box, intention.
Thank you.
All right, thank you so much to Ishmael for the last keynote. Very exciting to see all of Deep Proof's improvements within the last few months. So right now we have an interview with Daniel, who is CMO at Laz AI. Thank you so much for being here today, Daniel. Really would be very excited to talk about some of the data misalignment problems that we see so far, how Laz AI is addressing them, and what's new, what's up next for Laz AI as you guys are preparing for the mainnet launch.
Yeah, thanks for having me. And this is actually a really cool event. I love the venue, right? It's not like a little tiny restaurant or a cafe. It's actually really nice. It feels very historical too. So lovely to be here.
Yes, thank you. Thank you so much for being here. And yes, this venue does have some historical roots to it. So that was one of the reasons why we chose it. But I'm wondering if we can first start off with this conversation on just some general context as to the exact challenges that Laz AI is addressing, specifically within data misalignment. So wanted to hear from you, what are the key challenges that exist within our AI systems today, especially when it relates to model collapse, the data misalignment problem, siloed data ecosystems, and how Laz AI is planning to address these different areas?
Right. So the AI and blockchain space is in a bit of a weird phase right now, where they're transitioning from very niche focused solutions to a bit more holistic solutions. So for example, we keep talking about the data problem, and there's been a lot of projects that started out with the data problem, and they only service that one little niche of the whole AI pipeline. Nowadays, we're seeing a bit more that's a bit more holistic in their approach. So whether they're a layer one, or whether they're an infrastructure to pretty much service the whole thing. And that's similar to what we're doing actually, right? So we did start off focusing on the data problem. Data problem is pretty simple. You train AI with data, so the data has to be good data, and it has to be aligned to why you want to create the agent, right? So for example, if it's a healthcare, like a medical provider, a service provider agent, then it should have very good knowledge base of healthcare data to pull on, right? But we keep seeing in AI agents, when you use them, you see things like data hallucinations, you see data biases coming into play. So this misalignment is what we ended up focusing on. It's not that we're just focusing on data, it's that we recognize that there's a misalignment between the intent of the creation of the model and how we want to use the model. So focusing on this allowed us to take a bit of a step back and create a much more holistic approach into how we're servicing the AI space. So that allowed us to basically create a very complete solution that services the whole pipeline. So from data generation, verification, assetization, you can launch models and agents through us. You can use our AI agent framework that we built. We had this whole kind of basically pipeline built out so that we can focus on those small individual things, right? So that we can solve the root causes as well as the results of those root causes.
So right now there's a bit of misalignment between the intent of the model as well as between the intent and then how it's actually executed. And for Laz AI, the main focus is addressing each parts of this pipeline, not just say one area within these models, but every single part of it. Got it.
Yeah. But actually, to get back to your original question, again, it is really about that data to start off with, right? Because you need that data to be aligned with why you want to use it, right? So going back to the medical healthcare example, if you do have a lot of data that doesn't really have, I would say, contextual data, then it's not really meaningful in its own right, right? So you have to contextualize the data, you have to transform it so that you can feed it into the model in a good way. And the model has to understand that context to provide the right care, right? So for example, you can treat, say, hypertension, so high blood pressure, you can treat it as much as you want, but if you don't know that they have high cholesterol, you're not actually solving anything, right? So that kind of, that's simplified, but what we're doing is we're adding things like POV data, which is point of view data. So it's not just saying, yes, we have high cholesterol. Maybe it's also splitting that into different kind of lifestyle patterns as well, right? It's giving that human perspective, and that's why we're calling it point of view. And the data that we're encapsulating contains all of that as well. And to actually make that work seamlessly throughout building and launching an agent, that you have to have a whole system that's built around incorporating all these things, right? Because we can provide as much contextual data as we want, but if the models and the agents aren't built to handle that kind of data, then it's pretty useless, right? That's why we ended up building that kind of whole pipeline model.
Got it. So there's two kind of main aspects here. First is having that appropriate context-based data, and that can hopefully relieve some things like biases or potentially hallucinations as the model is given more context. And the other part of it is building the outside structure for being able to feed this kind of context-related data.
Yeah, absolutely.
Got it. And I know that LazAI is also really focused on the vision of having composed intelligence as well. So I'm wondering if you can speak a bit about what the idea of composable intelligence means, and then also the real need for AI to adopt composability and how the use of DATs is really fitting into this.
Yeah, so composability to us was pretty key from the beginning. So while building the Aleph AI agent framework, we looked at, what can we incorporate it in to make it basically provide the maximum amount of value that you can to agents. And for us, keeping in line with, the ethos of blockchain, which is composability, right? We've been focusing and we're doing quite well at composability for a while now. So if you look at agents, I'd like to give an example of a logistics company, right? Let's say you own a warehouse and you build an agent to manage that warehouse. So then you start monetizing on it by, selling it on the market. I own a trucking company and I do the same to manage my trucks. Well, what a user can then initiate is, we don't have to do it. A user can see that they have a trucking company and a warehousing company that has agents. Well, it can then combine those two together to create a logistics solution rather than just a managing warehouse and managing a trucking company. And doing it that way is quite difficult because now you have to actually look at the composability of these agents rather than how they interact. Because just if you leave it at just interaction, you're looking at it the way that a lot of other projects are doing right now, and that's by sending messages between the agents back and forth. You can do it that way, but the more complex the system gets, the more difficult it is to get proper results out of it. So let's say if I'm building out a product line and I need a logistics solution to handle my products for the next year, then you have, let's say monthly shipments, you have variable timing, you have different insurance plans, you have different, for example, is it freight on board, right? So how are you paying for it? When is it being paid for? When does the ownership transfer? All of these things are very difficult to just do in messages between agents, right? So by focusing on the composability, we can see what would actually make that happen. And you can get the two agents to, for example, share the database. You both look at the underlying data, and then one side proposes a whole plan to the other. And by making the interaction between them actually integrated instead of just sending messages back and forth, you can get that composed solution out of it.
Got it. So more about being able to integrate between these different ecosystems rather than just having agents simply just interact with each other and converse with each other, which has its own kind of caveats and not being able to capture the full picture. Got it.
Yeah.
Got it. And also wanted to hear more about LazAI's offerings, especially for developers. For developers, the developer tooling that LazAI offers. Wanted to hear about any kinds of specific infrastructure challenges that these AI developers face, and what types of tooling that they need that Laz AI can provide.
Right. So in terms of infrastructure, if you're building an agent, then hopefully what you're getting a lot of interaction between you and the user, right? So it's not like, for example, a DeFi company or where you can come in, stake once, and that's it. You can leave it for months, weeks at a time, and you don't have to worry about things like transaction costs. You don't have to worry about how quick the network can handle that transaction. For AI agents, that timing, the performance of the network basically becomes much, much more important. And the more successful you are as an agent, the more infinitely difficult it is to handle that amount of traffic going back and forth, for it to actually have a usable, I would say, user experience. Then you need to have it actually executed on a timely manner, right? So that aspect of it, we're also solving basically by providing a high performance network, both on Laz AI and by being integrated with Metis' Hyperion as well, which is also focusing on high performance and AI, right? So the tooling that attaches to that high performance network also solves the other side of the equation, where it's not just providing a smooth experience for the user and providing a low cost solution for the developer, but also if you also integrate in things like access to databases, oracles, if you have the APIs, if you use our agent framework, you also get the access to things like interoperability. You get different support for different languages, pretty much all the common smart contract languages or coding languages we support. And on top of that, even things like the ability to track dynamic data sets with our new token standard. It's called the DAT, Data Anchoring Token. It allows you to track dynamic data sets. So as a developer now, I can look at encapsulating my data set to be able to evolve. You can have your agents and models also evolve over time rather than taking a snapshot and trying to tokenize that, right? So we're giving a lot of freedom and options, and basically lowering the hurdles for a lot of developers to come in and build what they want.
Yeah, awesome. And it's really great to hear about the dynamic data collection as well, especially now that a lot of the data sets that we train our models on are kind of fixed. And then unless if we have the release of a new model, that's when it has some more data to be trained on. But it's great to hear that developers can now, with any kinds of changes that they want to make for the data set, those can be included when they're building their models. So really great to hear the kind of flexibility that's offered. And also wanted to hear some of the other offerings that Laz AI has and some of the motivations behind the design considerations behind the architecture. So you mentioned the data anchoring token and how it has a marketplace as well. And then there's also the individual centric DAOs, and then the verifiable computing framework as well. So wanted to hear more about how all of these components really work together and what's available for the user if they want to get more involved.
Yeah, for sure. I would say the things that you mentioned are technical innovations that has gone into providing our solution. So if you look at DAT, for example, being able to track dynamic data, it has immense value, and it can be a very different experience to using static data, right? So for example, if I have an agent or a model that should be consistently updating, right, then obviously I should preferably have a consistently updating database. But if it's just static data, then you have to basically pay for it every single time. And then from the pricing standpoint, then as person who's selling the data, then I have to immensely lower the price because now they have to come back every time to buy it. Well, if I set a dynamic data set, then the pricing scheme completely changes. You can have it on a subscription-based model. You can have it buy once and forget about it, but then you can increase the price massively. From a purchaser of that data set, then again, the same thing comes into play, right? Then I can much better control and have an idea of what the pricing is going to be like. Now, from the agent standpoint, you can also look at different ways of actually generating value instead of even just monetizing. So one of the agents that is launched on LazPad already is called the LazBubu. And what it shows is the capability of the DAT. So the agent evolves with every interaction with you over time. And that is what's actually tokenized, right? It's the evolved, it's the changed and end result of the interactions. So what you're doing is you're putting value into actual interaction instead of just what the data set says, right? So instead of just what it is. So at the end of the day, what we're allowing to happen with the DAT is businesses aren't a static thing. So we're allowing the facilitation of evolving and dynamic environments for both the developers and the users. On the IDAO front, I'll try and be quick because I think I've taken a lot of time. But on the IDAO front, we've seen how the DAO models work out, and until now, it hasn't really worked out as well as we thought it would, right? By providing an endless boundary to a DAO, we thought it would allow anybody to get involved, but what it ended up being is it ended up becoming like a board member, right? Board of directors. Because let's say, I hold Ethereum. I don't really care that much about how the tech develops on Ethereum, so I just delegate my votes, right? You can say, well, it's still working in the right way because the people who know and understand are voting on the right thing. But at the end of the day, that still means I'm still far removed from what value that vote has, right? So on Laz AI, we flipped the boundary and we made the DAO centered around an individual. And doing it this way allows us to much tie the user and the actual result of the DAO much closer together. So you get a much better value alignment or objective alignment between the two. So for example, you can focus it around on a DAT. So an agent is controlled by, for example, the people who funded it, who providing the data, who's marketing it, right? And maybe for the users as well. So you can control things like what privacy rights look like. You can look at how royalties work. You can look at how verification works, what kind of point of view data goes into play. So, yeah.
You can really redefine the boundaries to be at the individual level as opposed to, say, like the general company level, and really have it be tailored to that specific individual or user. That sounds great. And also, even when you mention about the data anchoring token and some of the other mechanisms that are involved with tracking the evolution of these agents and really contributing to that idea of the dynamic data sets. I think these are all like very important design considerations that the team has made. And I also wanted to hear about some of the current use cases that Laz AI is targeting right now. So whether that be within DeFi and AI, that intersection, or with DePIN as well. Are there any current use cases that the team is looking at, or any future use cases that you see really has potential with Laz AI?
Well, I really like the logistics solution that I talked about, but that's a way down the line kind of thing. Immediately, at least, the conversations that we have right now are a lot more interesting and kind of things that we can relate to a lot better. So one of them, for example, could be a, what would you call it? Tourism, right? So it would be a tour agent that's able to help you plan your vacation, also book them for you, give you recommendations. But all of that would be based off of the data that's provided by the government in link with their tourist agents, tourist minister, right? I guess. And by having this kind of database also tokenized, but also available for the agent, you're allowing democratization of that data. So for them, it's not just available for just this specific agent. Through the IDAOs, what they can do is control what kind of data is actually made public on the marketplace. So for them, it's very easy to come in and say, okay, this type of data is okay to go out. This type of data is either private data or something that just they should not be sharing. And then it allows businesses and users to come in and get access to the data much easier in a very standardized way versus, okay, if I was a business starting out in this area, how would I try and get that data, right? Another one is, for example, we're talking to a game developer AI company. And what you would be able to hopefully do later on is if you launch a game through their agent, then that could get minted as a DAT on our network, basically through a button click. And then that agent would then be able to, help either manage that game, or you could even just list that game as DAT, and you could manage the things like again, the usage rights, how it's monetized, the fees that would be involved, all of those things through the DAT.
So you can really control the monetization levels, and then also even you mentioned that example of selective disclosure. So being able to decide which areas or which parts of the data is kept public and which are kept private. Okay, yeah, that's great to hear. And just as a last question, for any developers, AI-based developers, for example, in the audience who would like to get more involved with Laz AI, what are some next steps for them?
Next steps is go to our website. That's literally first step one. We also have a thriving Twitter account that we're trying to build out, all towards the mainnet. So the one thing to note about us is that our go-to-market is not just try and hype up a token launch, right? Which happens quite often. It's not to give out a bunch of grants. It's none of that. What it is our go-to-market is based entirely on the traction that we're going to get through the LazPad Launchpad and the AI agent framework, Aleph. So the more users use Aleph and the more agents that are launched on LazPad, that brings on the interest, that brings on the users, and users can already earn and off-ramp that way because it's already launched on Andromeda Network on Metis, right? We're not just a closed system on testnet where it's kind of play money and nobody really cares until, token generation. We're seeing that, doing it that way is not really conducive to a longevity of any ecosystem, and it's not really something that can capture interest long term. But the LazPad gives us a completely different avenue where we can have open launches. We can also have curated launches where it's either agents that we're launching or our partners are launching. And it gives a different level of, I'd say, interaction and what we're calling playability for the users to get involved before mainnet. So check out LazPad, check out our website, and please use Aleph.
Yeah, sounds great. Thank you so much, Daniel, for all the insights. Really great to see how Laz AI is specifically solving the data misalignment problem, and through its different offerings, like with the data anchoring token and with the marketplace as well. So thank you so much for all the insights.
Thank you for having us.
Thank you.
Thank you very much.
Thank you so much. All right, thank you so much, Daniel, for the interview. Next up, we have a keynote that is presented by Geoff, who is head of community at Ontology Network.
We're here to talk about a future where AI, zero knowledge proofs, with me, decentralized identity is that. Sounds pretty abstract, right? What it really means is how do we keep trust, privacy, and ownership in the next phase of the internet? Sorry, 1 second, sir. Okay, just bear with me 1 second. It's my agent, it's my AI agent. It wants me to verify, me for a service. Okay, so normally that would be KYC, you know the drill, passports, selfies, utility group, bills, proof of life, all those things. Actually, instead, it's actually just issued a zero knowledge proof that says this person is verified. So the service trusts me, but they don't know my home address, my bank details, my age, and so on and so on and so on. And my agent has taken care of that quite nicely. Okay, so that relies on them trusting my agent, right? So I refer to this as know my agent. So you know your customer, know your business, and so know my agent is an important part of that because there's a mathematical proof in a zero knowledge way that the statements are true without revealing any underlying data, and it's all anchored to my DID, and it's portable across all the services. And my agent has got an identity to it, so it's verified. So the services looking and speaking to my agent know my agent is who it says it is, just like it would know I am who I know it. I say I am through the know my agent deal. So that really worked quite nicely, not too much of an interruption. And as a point, that's not just for onboarding, it works for compliance too. My agent can prove I'm not on a sanctions list, that the agent isn't on a sanctions list, that I've passed AML checks, and none of this needs to expose all of my history because my agent's been through Know My Agent, and that's all good and brilliant. That was easy, right, no problem. Back to what I'm actually here to talk about. Sorry about that. So, you know, we want to think about zero knowledge proofs, and we want to think about identity, and all of that, of course, is for us here. We talk about the blockchain as well, and the blockchain can be used to verify ownership and income and even reputation, all without full disclosure. You know, one of the problems with blockchain in the past is it's too transparent, and zero knowledge proofs gives us the opportunity to actually prove things without too much disclosure. And so blockchain becomes really important in this privacy and I'm sorry, it's my agent again. Okay, what does it want to do? Okay, I need a loan. We're doing up the house and so on. And so the agent's just proved my income for a loan, and it's done it via ZK proofs instead of bank statements and place slips. This person earns enough to pay the loan, no details, and that's nice. So Orange Protocol is our reputation layer at Ontology, and it's used ZK-TLS to check my account and say, yes, it ticks all the boxes for income and balances and so on for you to give this person a loan. So that's Orange Protocol's gone off chain with ZK-TLS to talk to my bank and figure all that out on my behalf. My agents, again, Know Your Agent has done those things. And okay, so that loan should come through, which means I can get a new kitchen, which is excellent. Everybody likes a new kitchen. ZK-TLS can do all sorts of things for us, right? It can let us prove interactions over an encrypted channel is valid without exposing any content. And I can package up my on-chain activity into a reputation credential, and I can reuse it across different ecosystems, and I can take that reputation with me. So that means that my agent can prove that I'm trustworthy to DeFi or DAOs or even in the job market. Or with this cryptographic assurance, I don't need to do screenshots or PDFs. And that really matters because scams are everywhere. Fake AI agents, fake services. Verifiable reputation allows us to cut through some of that noise. My agent can help me know who I can trust, who it can trust, who we can trust together. And that's really useful. And so the third thing, I'm really sorry. Again, I'll deal with this 1 second. Okay, this is pretty awkward. So my agent is monitoring my talk for me and seeing how it plays out. Actually says it's going really badly. It's a little bit embarrassing, but it's actually applied for a new job on my behalf because of how badly this talk's going. Okay, I don't think that's quite necessary, hopefully, but it has, and that's okay. It's submitted my proof of qualification on-chain, verifiable, to employers, and so they can actually see the proof and they can actually see everything. Again, I've not had to reveal too much about who I am and where I work at the moment, which is obviously a worry when you're applying for other jobs. It just proves that I am qualified to do the job they're advertised for. Thank you, agent, I think. I'm not so sure about the critique of the talk, but okay. So that's a job applied for, apparently. They've submitted my proof of qualification, and this is, it's kind of verifiable credentials 101, right? Instead of trusting documents, you trust the cryptography. The issuer signed it, the ZK proof checks out, it's valid. Much safer than the amount of fake CVs or fake qualifications, fake degrees, fake PhDs, so many things. And that cuts through that, so you know you're employing or you're talking to the people who are qualified in the way they say they're qualified. And you don't have to give everything over at the same time. So that's really nicely done. Thank you, Agent. Agent Bob, I call him. He interrupts too much, but he's quite useful. Okay, so let's move on to the third section here. We've got identity, we've got proof, and of course, as you've seen, we've got AI agents. These agents will act legally and securely on our behalf, negotiating, applying, transacting, doing all the things we need them to do for us. And this is... Sorry, let's see what he wants this time. Agent Bob, yes. What is it now? Okay, so this is Ontello. Ontello is our evolution of OntID, and it's not out yet. It's just on my phone for testing. It's not just a wallet, it's kind of a smart identity system, a smart wallet. Agent marketplace, privacy chats, linked to our IDs, sort of the things to put together the infrastructure for this environment where agents and ZK proofs and identity can work together on there. It's actually looking to see if I want to, somebody actually likes my presentation and wants to talk to me about partnering with OntID. That's brilliant, but anybody who's used Telegram will know that when you get messages from people who suddenly want to partner with you or want to do something with you, you never know if they're real or if they're impersonating somebody, if they're scams and so on, and it's really hard to understand sometimes. And obviously with on-chain reputation, linked to on-chain identity, we can actually send off our agent, say, can you check on this person in a zero knowledge way? We don't want to delve into their lives, their KTLS off-chain, see if there's any proof of humanity, proof of who they say they are. And our agents can negotiate whether we trust them or not, verify credentials, protect against scams, and that's really important. And so I just said, yeah, okay, I'll talk to this person, but make sure they are who they say they are before we enter a private chat. That's really useful. And they can do the same with me. They can use zero knowledge proofs to check, to see who I am without exposing my address or anything else that could be, well, dangerous in reality to expose to people. So good old zero knowledge proofs there, keeping us all safe. And it's really important. You know, agents are going to negotiate contracts. They're going to verify credentials, protect against scams. And these aren't apps owned by corporations. They're extensions of us. And because everything is signed on chain, the outputs of these agents can be verified. They don't have to be black box AI hallucinations with unverifiable claims. We can have the data and all the things necessary on chain that can then be verified, and even in a zero knowledge way if that is sensitive information. So I'm going to turn it off. We've heard enough from AI agent Bob. Let's right. Okay, let's get rid of Bob. Right. Anyway, enough with the interruptions. I've turned the phone off. Let's actually start and do the presentation. I've got some PowerPoint prepared somewhere, and let me just have a look. What are my timings like? And I've pretty much run out of time, which is ironic, really, because that's exactly the point. Our agents will be running in the background, saving us time, protecting our privacy, improving trust. And that's a huge shift in technology. Not just another app, but an entirely new architecture for the internet. And the pieces align and go: identity, blockchain, zero knowledge proofs, AI, and this amazing community that is building all those things together. And together, we can deliver a better, safer, more private future. one where our agents work for us and not against us. And this is a big undertaking. Everything you've just seen is coming. We're not quite there. Together, we can build the pieces, line them up, connect the dots, and deliver a future where we have more time, more safety, more reliability, and more privacy. Thank you for your time. Enjoy the rest of your day. Enjoy the rest of the week in this beautiful city. And hopefully, the next time I'll be there in person. Have a great time. Goodbye.
Concerned about fake identities, fraud, or privacy leaks in Web3? Discover Ontology, Web3's trust layer. Trust starts with decentralized identity. OntID uses zero-knowledge proofs to verify credentials without compromising privacy. Power your Web3 journey with Onta Wallet, securely manage assets and identity. With Orange Protocol, leverage zk-TLS tech to build Web3 reputation. Join Ontology's Web3 revolution.
The next chapter of AI should be defined not by how large model is, but how human aligned.
Black box, in control of just the hands of a few. With AI makes it an intelligent asset, owned by all of us, learning from all of us, governed on-chain, transparent, monetizable, and accountable to human according to human values.
Then the data being trained and small model by the community is the way to go. So this is, I see the Web3 and AI convergence from all Laze point of view.
Breaking news tonight from Pandaro, where GPT rate limits have been mandated. This is a developing story.
My intuition is that we do see snarks kind of eating cryptography in the sense that they become a commoditized building block, just like hash functions are. But I also see them kind of eating the world of computation. So one of my dreams, in some sense, is to have CPUs where there's an onboard prover that generates proofs in real time.
Our vision is that in maybe the next 10 years, most of the computation is actually not going to happen on chain, but it's going to happen in an off-chain environment. And this is the future we're building towards.
My personal thesis on this is that ZK is going to long-term be as significant of a technology as, say, public key encryption, that it's going to be something that
Last keynote. Next up, we have our last panel for today. The topic is verifying intelligence, building AI systems that we can trust. So for our guests, we have David from Gonka, we have Daniel from Laze AI, Ishmael from Lagrange, and Rob from ZK Verify.
I'm going to sit under the picture of me.
Daniel from Laze AI, your panel is up. If you could come to the stage.
We might need a new moderator. Who's the moderator? Are you moderating?
Yes.
Oh, nice.
Yes. Okay, we will wait for Daniel to come up later. He can join after we begin this panel session. All right. So thank you guys so much for coming in to listen. Thank you for our panelists for joining us today. So kind of the context for this conversation is as our AI outputs, guides, decisions made in the industry applications it's applied for, like in finance, like in healthcare, in defense, governance, the question really shifts from what did the model say to can we trust it? What was it supposed to say? Kind of aligning the intent of what the model is supposed to do and its actual behavior. So today's panel will focus around these aspects for how we can go about with verifying our AI-based systems and some potential tools, like for example with ZK, and how it can help with that verification process. So first off, I'd like for all of our panelists to go and briefly introduce themselves, starting with Ishmael.
Yeah, so good afternoon, everyone. My name's Ismail. I'm one of the co-founders of Lagrange Labs. And we're a company that focuses on the intersection of AI and zero-knowledge proofs. We build a library called DeepProve, which is the only production grade and most performant library available for ZK machine learning today. And we have a fantastic research team that tackles problems like verifiable inference, as well as many ancillary ones, things like proofs of non-hallucination, as well as proofs of fairness.
Hey everyone, I'm David Lieberman, creator of Gonka. Gonka is decentralized AI compute network. Every inference on the network provided to developers is immutable, inherently immutable, verifiable, so we can trust actually what model says.
Hi everyone, I'm Daniel Kwok, the CMO at Laz AI. We do basically everything in AI. If you want to launch an agent or monetize your data, we can help you track your dynamic data. We have AI agent framework, and most important, we have a launchpad for you to come launch your token on. So yeah, thank you.
Hi everyone, I'm Rod Viglione, the CEO of Horizon Labs. We're the core builder behind ZK Verify. Like I said on the panel earlier today, we have cool stickers back there. Please come check them out. But yeah, we've been in the business of ZK for a while, the last 8 years, and ZK Verify is hopefully contributing to this particular space at the pure verification layer.
Thank you very much for all of the introductions. Starting off kind of broad and really focused on the main motivation, the main why as to why we're doing this. Wanted to hear from all of you what the real need is to verify our current AI systems, especially, for example, say, proving the inferences from a model or proving that the outputs are as expected, especially when, for example, a lot of the models that we currently see act in this black box environment where we aren't really sure what's going on underneath the hood. We can only see, what goes into the model, the inputs, as well as the corresponding outputs. So wanted to hear from you all what the real need is for verification in our AI systems.
I'll leave it to these guys to kick it off because I think they should all be ZK verified.
Yes, so in general, we already observed two major shifts brought by blockchain. First was introduction of immutable ledgers, when we can trust the transaction would happen. No one can stop it. No one can interfere with it. Governments or richest people in the world, they cannot affect it. Then we saw the same with immutable compute, with introduction of smart contracts in Ethereum. And now it is the third major shift, when we need to build the infrastructure for immutable agents. These type of systems will act on our behalf. We cannot just leave it as it is, run by corporations or influenced by governments. We need to have the way for it to be immutable as well. The same way as we run smart contracts, now we need these agents to act and to do financial transactions or to any type of business transaction for us. Like immutable smart contracts, they allowed legal system to be on chain, but immutable agents will allow us to run bureaucracy as a whole on chain. So we need to have the way to trust it without trusting any particular source.
Yeah, so it's a great question. I think it's important to always ask why on most things in life. But crypto has this problem, very broadly speaking, that most of the technology sector for the last 10 years in America has had. And that is an obsession with building incremental solutions to non-problems. And this is why we have 40 teams building chat apps. This is why we have, hundreds of crypto teams trying to build consumer roll-ups. And really very few people tackling problems that I think are fundamental to modern technology, right? It isn't fun to solve something that's intractable to an industry. It's fun to try to make a small tweak to a successful business and hope you can monetize it by capturing a portion of the existing demand. And so that's why you look at AI today and you say, okay, AI is being used in everything from autonomous weapons to healthcare decisions to enterprise or institutional finance. And yet there is no way to assure that the correct model is being used in the correct contexts. There's no way to guarantee privacy naturally over inference. There's no way to guarantee a model isn't hallucinating. And there's no way to guarantee that the model is fair, right? That we've run the model over a sufficient number of inputs to determine that there's no inherent bias in how the output is constructed. And we're willing to just keep building things that are incremental instead of going after those problems. The core of verifiable AI is building closed form mathematical solutions to those problems, right? It's not slapping a consensus on an LLM and claiming that now you have verifiable AI. It's designing fundamental solutions using mathematics and cryptography to solve issues that are intrinsic to AI. That's what we do at Lagrange. The first thing that we built was verifiable AI for inference. You take a model, you parse that model into an ONNX file with a bunch of modules, and then you can prove the correctness over a quantized version of that model. So you can now use that model in a drone in a security conscious setting, and you have assurance over the correctness of it. Now there's a variety of other works we have coming out that are extending that to support privacy over both closed source models and proprietary data, as well as extending that to being able to formally prove fairness, as well as non-hallucination. And we think that these are the types of things that companies have to tackle for the industry of crypto and cryptography more broadly to actually have, true PMF.
Yeah, great question, and I completely agree with these two. They're brilliant answers. And to build on that, I mean, if you just look at how AI is built, right, then exactly like you said, the kind of how AI is actually coded is it doesn't care about verifiability at all, right? It's just not built into it at all. And that allows basically companies to build a complete black box, because it's not just that they're not accountable, it's that they can't really be accountable, right? Just by how they're run. And if you look at your answer, it's really, if nobody's doing it, right, then you don't really expect it either. So at the end of the day, it's, do users expect it? And does that actually make a marketable difference in basically how well they sell, for example? And by having a system that allows you to actually verify, then you can actually get real value into the actual system if you look at agents that are making actual work outside of just chats, right? So for example, if it's a medical agent, if it's a Deep AI, if it even hooks into TradFi, then all of their decisions or even recommendations would have marketable impact on the actual users, and even have calamitous consequences if it actually goes about it in a really terrible way. So at the end of the day, it's important for us to have these systems that track it, not just so that I can track it, because at the end of the day, how many of us are actually going to go look up the proofs that are going to come out of this? It's, if you do it his way, then by nature, it is verifiable. If you do it some other way, then you are allowing that accountability to happen, which forces the businesses to adhere to whatever ethics that they think is their bottom, right?
Why not? A little louder than I thought. So guys, I think where this is going to play an even bigger role is when we get into more black box type systems. And I'm not talking black box of a model itself, but when models are run on a black box, like a hardware enclave or some sort of like TE environment, especially for use cases like national security, healthcare, areas where you just need privacy to what you're doing, or just pure segmentation of it. then verifying that in some way is going to be even more important. And clearly, you're not going to look up the proof yourself, but you'll have some software that just references it, from somewhere else. I think that's how we look at it, and that's where we hope to play a role.
Thank you all for your insights. First, David, on categorizing those different shifts and now how we're emerging into this immutable agents focus right now. And then even for Ishmael, the current work that Lagrange is doing with DeepProof and your guys' approach for finding that PMF. And then Daniel and Rob, your insights as well. So thank you for that. And I now want to ask about some of the specific parts of the pipeline that you all believe should be prioritized in terms of verification. So should it be on the inference level? I know, Ishmael, you mentioned that for Lagrange, one of the first use cases was being able to prove these inferences. So would it be based on the inferences, the model architecture itself, inputs and outputs? What parts of this pipeline should we really be prioritizing for verification? And like, for example, say with a higher stakes related industry, like even with defense or healthcare, for example, should we also be prioritizing the verification of the inputs and outputs in addition to the inferences as well? So which parts of the pipeline do you guys really believe we should be prioritizing on?
We at Gonka, we decided to prioritize adoption. So today, the major shift happens more people in the world use AI. Really, billions of people use AI. And if we are not there right now in their major use cases, we will lose it towards these black boxes. And that's why, even though I personally truly believe that training, for example, is really important to make verifiable as well, but we need to solve inference as soon as possible. Because we need to educate people that they can have this kind of privacy, they can have this kind of trust. And then the rest will be able to build on top of that. So from this perspective, by having the ChatGPT type of experiences or Cursor type of experiences run in decentralized networks, I think it's crucial right now because it will educate all these users that they can have this type of trust in the systems, and then we can offer it for national defense and the rest of the world.
Yeah, so I think, once again, adoption is very important for any technology. The problem is the architecture that you use to get to that adoption, right? Do we think that Raytheon is going to grab a Tendermint blockchain with some TEs and use that to secure, the next campaign? No, I mean, it's just, you're not going to be able to actually reach adoption of cryptographically secured AI if you don't build cryptographic systems that can easily be integrated into existing architectures. If you're using a blockchain to secure AI, the application of that is substantially limited. Now, this is back to your question of what you should actually be verifying with cryptography. And yes, inference, I think, is the North Star first step, right? If you can't prove inference, you're not going to be able to prove fairness or training. These are all problems that predicate on actually the code of being able to prove inference. And then beyond just proving the correctness of an output, there's several other things you want to prove about inference. I mentioned non-hallucination previously, which is very much an open problem. Another of these is fairness. How do I ensure the model doesn't have an inherent bias at the point of training? How do I have a formal property that inference, in fact, abides by some, human recognizable concept of being fair to the input set? And then from there, you get to things like fine tuning, which are computationally less complex than things like training. And then you finally get to training, which is an incredibly computationally intensive task and probably will not happen for the next 30 years in a verifiable way, given that training, Grok 4 costs hundreds of millions of dollars, if not low billions of dollars. And the idea that you're going to have a 2x overhead on that to run the whole thing through a prover is a little far off. But the immediate problems are inference, and then there's things that are ancillary to inference that will soon be tackled as well.
Yeah. Again, I mean, you said two brilliant people to my left, so I can only follow up. But to have a slightly different take on it, right? While I do completely agree with all they said, you'll also kind of have to look at who is this for, right? It goes actually exactly to what you were saying. But if you look at who it's for, then let's be honest, I'm probably, again, not going to look up the proofs of whatever the inference was, right? At least not that much. Right now, if you look at ChatGPT, probably one of the biggest uses I think I saw was that they use it as kind of a more enhanced Google search, right? For me to look up what kind of food dinner I can make with the ingredients in my fridge, I don't really need a verification, right? I don't need it to be proofed. But if it was, say, exactly like you said, Raytheon was using it, then absolutely I want it to be proofed. Even if I'm not the one using it, I want them to use something that's proofed, right? So if the agent that's using the proofs is, say, really just simple, consumer day level kind of things, like what's in my fridge, then yeah, inference proofing is more than enough, right? But the higher you go, obviously, the more involved it needs to be. And exactly like you said, even just building the models itself in a provable way, that completely changes the kind of value proposition that it would have for specific market segments.
All right. I'll take it in a slightly different way, guys. I'll talk about the artifacts of AI because I'm not an AI guy, so we'll leave that to the smart guys here. But when you have agents that are operating in environments that we care about, and I'll give you some examples with some of our customers. So say you've got a dark pool, for trading assets, and you've got agents that are automated to operate within that dark pool. That's a great black box, guys. In that type of environment, you absolutely want, or could certainly make use of a variety of proofs interacting in different ways to make sure that that agent is actually doing what it's supposed to be doing, and that you can actually have verifiable outcomes that you can check in some other public environment based on what happened in there. So that's the kind of area that we actually find really interesting right now.
Got it. And yeah, thank you all for all your insights. So for Rob for presenting that use case, and both you, Ismail, and also Daniel for really focusing on like which specific use case can verifiability be applied to. You both mentioned, for example, Raytheon. We would definitely want to have verifiability attached to that, but maybe for some other day-to-day operations it may not be as appropriate. And all of that really comes to fueling the adoption standpoint that David, you mentioned. So thank you all for that. And I wanted to transition this conversation into the types of mechanisms that we can use for verifiability. So Rob and Ismail are both focused on the ZK aspect, so using the verifiable compute use case of ZK. But then I also want to hear from David and also Daniel on some of the other kind of mechanisms that we can consider in addition to ZK for verifiability.
Yeah, I guess I'm first. So for us, because verification was not the core reason why we started our company, we had to look at how does the their verification fit into the whole pipeline of basically data all the way to actual inference. So for us, we kind of had the luxury of taking our pick, and we ended up basically taking all the picks if we could. So we combined basically ZKs, we combine OP and TEE, and we even have an engagement, user involvement aspect to it. So exactly like they said, it doesn't make sense to verify everything from start to finish. So for us, we look at a data source or a model, and we have to look at what makes sense in this specific instance. So if it's a simple inference for a simple, easy output, then you can just get away with, say, having an OP proof just to get the inference out quickly as possible, right? But if it's a bit more involved, especially for things like deep AI, then you might want to get ZK involved. But again, you have to look at, okay, if this is a high frequency trading deep AI, then maybe ZK might take a little too long for it because it needs to execute, I don't know, dozens of times in a second. If that's the case, then you can also look at batching those and then putting it through a ZK. But then you're verifying after the fact, and that might still be okay, right? So we're giving the luxury of freedom to all of the agent developers and the data source, I guess, controllers to be able to see what fits kind of their model, how they plug into Laz AI, and for us to say, this is the bare minimum, and that's basically you have to have some type of proof that you're logging on to Laz AI, because exactly like we said, we don't want non-proofed AI. But again, going back to what I said previously, sometimes it makes sense to be more proofed than others.
Yeah, so the way I see it is like this. When you start a company, you have to ask yourself, I'm going to spend the next 10 years of my life doing something. What am I going to be doing and why am I going to be doing it, right? A lot of young people, and the great thing about crypto is all the young founders, but a lot of them, they'll start their company saying the thing I want is money, right? I want to make a bunch of money. But you quickly realize that that is a very vapid and empty way to live your life and to progress your career. What you need is something beyond that. Something that you can say, okay, for the next 10 years, my contribution to this field is meaningful, whether that be a scientific pursuit, a commercial pursuit, something, right? And so the question of what you're going to be doing to prove AI should be the question of what is the correct solution to this problem? Not what can I build to be able to turn a buck and buy a nice car and a boat, right? And so the only way to ensure that an AI system operates with guaranteed correctness is through cryptographic security. That is through zero-knowledge proofs over the inference to secure the computation, and that is through a combination of zero-knowledge proofs and fully homomorphic encryption to ensure that there is privacy over the inference. That is the solution, full stop. You can go to any professor, any cryptography researcher and say, if compute was unbounded, if time was unbounded, how would you solve this problem? And that is the solution you would hear. So if the answer of what you're going to be doing for the next 10 years of your life is anything different than that answer, I would seriously consider changing the answer. Because you shouldn't be dedicating, or at least I don't think you should be dedicating, that much time to something that is not directionally correct. And so for this problem, and with what Lagrange does, we target that end. Deep proof has been our first step. Proving AI inference using zero-knowledge proofs for a variety of commercially viable and frontier models. Very soon that will include hallucinations, or proofs of non-hallucinations. Very soon that will include proofs over encrypted data. And 50 years from now, that will hopefully include proofs of training.
We do admire the work which is currently done by zero-knowledge proof community. And one of the biggest miners in our network right now is 6 Blocks. They were great contributors to zero-knowledge proof. At the same time, we think that we currently in this crossroad. We need to act right now to make it possible that AI is not controlled by major AI labs like OpenAI and XAI. It cannot be done in 10 years from now, it should be done today. And for that, we need the solution which can be applied today for large models. Most of the developers, only fraction of use cases can be actually implemented today with models of a smaller size. Most of the developers use models of 400 billion parameters, 600 billion parameters at least. And for that use cases, we need to introduce already today, while the science is developing toward that, we need to introduce solution which can work today. And even though Bitcoin, called a cryptography, but cryptography, as we all know, plays quite a tiny role in Bitcoin. Bitcoin solved the only problem, which was double spending. And to solve this problem, consensus solution, voting, was introduced. It just to use a proxy of one human, one vote, Satoshi introduced the idea to use one CPU, one vote. And the same principle can apply today for AI verifiability. Because the same GPUs and then ASICs in the network can represent the consensus, can represent the votes. And from this perspective, this verification can be just fraction of the compute power dedicated for inference. And this type of solutions can enable those use cases already today and can actually be competitive, like we've seen with the rise of different BitTensor, for example, subnetworks in Open Router. They just crushed the competition. Companies like Nubius or CoreWave, they are out of competition. They cannot compete with decentralized technologies already today. It's not like, in crypto seems to be kind of lacking behind in terms of this massive use cases, but it's actually not. It's already today outpace the competition of all the other GPU providers in the network, providing the inference for open-weighted models. So we see enormous opportunity to use consensus, like in case of Gonka. We do believe that the consensus should be proof of work consensus, the same way it was implemented in Bitcoin. And for sure, we need to invest more and more in science of zero knowledge proof to make it possible for the future to be fully verifiable, available for everyone.
Next question? I don't know. Agreed, yeah.
Yes, we did, yes. And yeah, thank you all for your points over there, especially with Ishmael, how you kind of categorized Lagrange's journey into first proving AI inferences, and then potentially later on, you're looking into proving hallucinations and eventually training as well. So there's quite a few different areas of the pipeline that the team is working towards. And to your point also, David, when you mentioned about how we really need to target those use cases that developers are working on right now, and for example, being able to handle these models with billions of parameters. And even Daniel, you mentioned a bit about the use case part, like for example, how LazAI provides the flexibility for these different verifiable mechanisms, especially for a use case you mentioned with a high frequency trading, in which you can't really afford to have extra latency attached there. I'm curious to hear from all of you the current technical barriers that we have with enforcing these verifiable mechanisms. Like for example, can we eventually reach a point where we can prove a model with billions of different parameters and even some other types of verifiable mechanisms? Is there any kinds of ways in which we can optimize the overhead that's attached to using them?
I mean, I'll open it up with, so for us, we're tackling the technical barrier of scale, honestly. So it really depends of how many proofs do you expect to be generated in the market and for what, really. So I'll leave that to these guys to figure out what needs to be proved and at what volume. But we are building for, currently we're handling hundreds of millions of proofs in our network, and we need to be able to handle billions and tens of billions. And ideally, I think we need to even go beyond that. And right now, I would say that that's probably, from our point of view, a major technical barrier. Totally tractable, though.
What he said.
I actually believe that for inference, we're already there. For training, it definitely will be a challenging project because we will need to grow the networks, talking about scale, to hundreds of thousands of top GPUs to make it possible to compete and to introduce to the market those big language models which will be trained in open way so that everyone can actually see what is there. You know, like we can be sure that inference provided is exactly the one which we expected by the model, but we cannot be sure that the model itself is not infiltrated with the thoughts which we don't want to see from the agents which act on our behalf. So, when you ask an AI some healthcare question, you don't want to think about whether it's advertising or not. You want it to be trustworthy. And from this perspective, for sure, training will be a challenge. We'll need to gather actions from probably hundreds of different research labs around the world. But we are quite hopeful. We see most of the, a lot of great scientists around the world. Only through the last 2 years, probably, at least a dozen major articles were released improving the capabilities of decentralized training networks. So we are quite hopeful that those barriers will be solved, but it definitely will require a much higher scale than the networks which we see today.
Right, so let's talk about the math of it for a minute. So Lagrange's deep proof is currently the only production-grade library that can prove zero-knowledge inference over LLMs. We've been able to support models ranging from about low 10 figures, so several billion parameters, including things like GPT-2 and then larger versions of that, Gemma 3, which we announced today, Llama, and a variety of other production-grade architectures. So the answer for inference is yes. The question is overhead, right? Because to prove something with zero-knowledge proofs is a computational overhead. Generally, we've seen this overhead come down by about 1 order of magnitude per year over the last 4 years. That's consistently been true across rollups, ZKVMs, et cetera. This comes from faster arithmetic, better engineering, GPU acceleration, distributed proving, and just improvements in kind of compute per Moore's law overall and access to compute overall. And so we're right now about 2 orders of magnitude off from what I'd consider real-time proving for LLM inference in the low billion parameter range. So yes, we're very, very close there. And from some of the non-hallucination work we're doing, we're looking at about a 10 to 20% overhead on top of proving inference. So the answer to that is yes as well. That's well within strike zone. We're probably 3 to 4 years away from being able to prove really any arbitrary machine learning model at approximately the same compute overhead as running that model natively. And that's going to be just a massive breakthrough, right? You're talking about an acceleration of innovation in cryptography that I'd say is on par with the performance improvements we saw with TLS in the 1970s and encryption in the 1970s. And so yes, we'll have that for inference very, very soon. We'll have that for proofs of non-hallucination, obviously subject to innovations and research in proving non-hallucination, even without ZK. And we'll have that for fairness as well shortly after. Training and fine-tuning will take a little bit longer, but they are coming. And once again, like you're talking about a transformational technology that is already compute constrained on just running it outright. You know, this is an immediate solution in a variety of verticals, things like defense and healthcare, where there's an incredibly high economic value predicated on top of the results of these inference. It really isn't a pressing issue in most consumer LLM usage, given that the open source models aren't even competitive in most cases with the closed source models. So I'd like to see advancements in kind of open source model development actually take off before we start, you know, arguing about the most privacy preserving way to use them. But yeah, and to summarize everything, we're very quickly approaching the convergence of verifiable AI through ZK and just AI broadly.
Yeah, so definitely seeing a lot of optimizations and orders of magnitudes even of improvement over the last few years.
Yeah, and it's only accelerating, right? Like we've seen at least an order of magnitude in the last 8 months since we launched Deep, or 6 months since we launched the first version of Deep Proof. We changed up the PCS that we're using. We're adding GPU support. We added parallelization. I mean, all of this stuff is I think somewhat commodity engineering at a point, and couple that with foundational research innovations, and you're able to really eke out over an order of magnitude per year on this stuff.
Yeah, so the age of verifiability is finally here. And I think a very common theme that was discussed about along all of our panelists was the importance of targeting whichever verifiable mechanism that you're using to your specific use case. So whether that be privacy related, or whether that be if speed matters, or if that latency is a concern, or even just differentiating against those high stakes scenarios like with healthcare and defense versus some other applications like say that are on-chain or blockchain based. All of those use cases need to have some sort of tailored structure for these verifiable mechanisms to be applied upon. So thank you so much, everyone, for all of the insights and for joining the panel today.
Thank you, everyone.
Thank you again for all of our panelists and for wrapping up very strong on the last panel for today. Up next, we have a keynote with John again. John has been a very frequent visitor of the stage. So John will be presenting a keynote on behalf of Veradice. So please welcome John.
Thanks. Yeah. Okay. All right, I think slides are coming up. All right. So I guess let's get started. So hi, I'm John. I'm the CEO of Veradice. And so today I'm going to talk to you about a new security platform that we just released, and it's in beta, that is bringing continuous security to Web3. And so really what I want to start with is talking about the software development lifecycle that we see people often adopt when it comes to developing software in Web3, which looks very, kind of segmented and stilted, where they do a lot of development in individual discrete stages, where they'll do something like they'll plan and then they'll actually perform all of their development. And after that, they'll, write integration tests. And only after that, they perform auditing, which happens right before deployment. And so essentially what you have is you've got security being considered really at the end of this software development lifecycle, and a lot of the security feedback is coming at the end, which really reduces the amount of flexibility that people have to adapt to new security challenges. And then on top of that, once people pass the deployment phase, the proactive security being performed internally pretty much ends, where people basically pass security off onto the community to let them know when there's a security issue. And so what's the problem with this? Well, that's what we're going to look at. So what we've seen is a significant amount of value being lost due to smart contract exploits. And this is even with audits. And so in 2024 alone, we saw about $350 million being hacked and stolen due to smart contract exploits. And about a third of those contracts that were exploited were audited. And when I say audited, I mean that the exploits were actually in scope of the audits and they could have been found. And then we can look at some more information about the current security landscape, which is that critical code is often being excluded from audits, and code that is audited is often modified post-audit. And so what this means is that we see cases like in 2024, an additional $80 million was lost due to out-of-scope modifications or out-of-scope changes and modifications post-audits, which is a huge amount. And it got even worse in 2025, where a single hack resulted in the loss of $223 million. And this was due to a single out-of-scope library. And so even though people are going and getting audits, they aren't including all of the security critical code. And then when we go and look at ZK, you also have similar issues. And so while we can't sit up here and look at the actual losses from ZK, we can start seeing some of the information of what might be in the future for us when it comes to ZK. And so at Veradice, we audit a lot of ZK projects. And so last year, we ended up doing a study where we looked over those ZK audits, and we found that 55% of the audits that we performed had at least one critical issue. And this was twice as likely as it was for a DeFi project to have an issue. And so that means that as ZK continues to grow, there's a lot of scope for there to be similar issues once people start further integrating ZK into their projects. And so if we look at the current security landscape, this is kind of what we see. We see that auditing is expensive, and because it's expensive, there are projects that are forgoing audits and are electing to deploy unaudited because they don't have the funds to actually perform those audits. And then we also see critical code that should be included in an audit being excluded because audits, or the cost of an audit, scales with the lines of code. In addition to that, a lot of people treat audits like the end-all be-all. If I have a clean audit, then that means that there are no bugs, which is not the case. Audits are intended to report bugs, but it's not really intended to report the absence of them, because audits don't provide any sort of security guarantees. And then finally, we see that this security last approach, or security at the end approach, limits the flexibility of teams to address these security issues. And so that means that there are teams that elect to deploy with security issues because they don't think that they are as severe, or they're unlikely to actually be exploited. And there are other times when, rather than deploying code that might have a vulnerability, they just decide to remove entire features so that they can still deploy, but not with the feature set that they expect, because they have a date that they need to deploy, they've announced it, and they don't want to push it back. And so this creates problems. And so how do we fix it? Well, there are a few possible solutions that have been suggested. And so we can evaluate them on a number of metrics. And we'll separate those between usability properties, which are properties that make the solution usable for developers or ideal for developers, and then security properties, where these are the properties that actually we want or are nice to have from a security perspective. And so really what we're looking for is something that is affordable, so anyone can do it. It's low effort, so the developers don't really have to do much. It's on demand, so you don't have to wait for it to happen. You can do it at any point. It's tailored to your project, and so this means that it's customized to the logic of your project. And then finally, it has security guarantees. And what I mean by this is, if it doesn't find something, that means that the thing that it didn't find doesn't exist, or if it does find something, it most certainly exists. And so if we look at auditing in this spectrum, we see that auditing is low effort for the developers because essentially all they have to do is wait for the audit report, and it's tailored, which means that when someone's doing an audit, they are performing the audit with respect to the business logic of that individual project. But really, auditing doesn't score very well on the spectrum because it doesn't provide any of the other properties that we would like. And so what can we do? Well, people have suggested AI auditing. And so AI auditing performs better because now it's more affordable since you can just get an AI agent to do it, which is cheap. And you can also perform that on demand. The problem that you have is AI auditing doesn't provide any security guarantees. And on top of that, if we look at studies that people have performed on AI's ability to identify security vulnerabilities, most of the vulnerabilities that like LLMs and other AI agents are able to detect are more surface level vulnerabilities. They're common vulnerabilities that they've seen, come up in the past, and they're also vulnerabilities that audits are very good at catching. And so for that reason, AI auditing isn't really the best solution because it isn't complementary with auditing itself. So instead we can go and look at some other things that people talk about, which is security tools. So there are different types of security tools, such as static analyzers, fuzzers, and formal verifiers, and each of those come with different security guarantees. But there's a stigma regarding these tools that they aren't low effort. And for static analyzers, that's because a static analyzer can report a lot of false positives, which someone has to go through in order to identify what vulnerabilities are actually in their project. And then for fuzzers and formal verifiers, when we're talking about smart contracts, they both require additional user input. And that's something that a developer has to take time to do. It's not something that you can go and just run one-off. And if we continue looking at formal verification, it gets even worse because it kind of has the stigma of, only being able to be performed by experts. You have to be a formal verification expert in order to perform it. And that means that you also have to hire a formal verification expert to do it. And so it's not something that can be done on demand, and it's not very affordable. And so really what I want to look into is whether the category related to tools is actually correct. And so what we're going to do is I want to talk to you about Audit Hub, which is a security platform that Veradice just released. It's currently in beta, and take a look at the security tools that we've integrated. And so Audit Hub integrates a variety of security tools for DeFi and ZK, where on the DeFi side, we have static analyzers, fuzzers, and then on the ZK side, we have static analyzers and a formal verifier. So let's see what they'll provide us. So one thing that we saw, if we go back to the statistics, is that in 2024, at least $120 million was stolen due to common vulnerabilities. In addition, if we look at ZK, we can see that 95% of the significant bugs that are found, or the critical bugs that are found in ZK circuits, arise from kind of one issue, which is non-deterministic circuits. And so this shows that we can create effective tools that can look for common vulnerabilities and have an impact. And so for that reason, all of the tools that we've integrated into Audit Hub can search for common vulnerabilities. So for example, Vanguard and ZK Vanguard can look for common vulnerabilities in smart contracts and ZK circuits respectively. Orca can fuzz against common invariants or invariants that are commonly required by various, commonly instantiated smart contracts. And finally, Picus is a formal verifier that verifies whether or not a circuit is deterministic, which is a well-defined security property that doesn't require any additional information from the user. So what that means is we can now look and, use tools in order to identify common vulnerabilities. But what about vulnerabilities that are specific to your business logic? Because, again, if we go back to the statistics, in 2024, at least $130 million was lost due to attacks on the specific business logic of a protocol. And so in order to be effective, yes, it's useful to look for common vulnerabilities, but you also should look for vulnerabilities that are specific to a project's business logic. So this is things like whatever the project is intending to do. And so this is something that we also wanted to be able to support in Audit Hub. And so in order to do that, most of our tools also have the ability to be customized. And so what that means is you can provide information about your specific project in order to identify vulnerabilities that matter to you. And so for Vanguard and ZK Vanguard, they allow you to specify common or custom detectors that will look for bugs that is specific to your business logic. So for example, you can say that this API requires another API to be invoked before it. And so if that never happens, then there's a bug. In addition, on the DeFi side, we also have Orca. And Orca allows you to specify specifications that basically specify invariants that should hold within your project, and Orca will go and try to find ways to violate those invariants. And so in addition to that, we've also spent a lot of time making sure that these tools are usable, because that's kind of the other complaint. And so that means that we've also integrated features like guided issue triage. And what this does is when you have a particular tool that can produce false positives, guided issue triage will let you identify the reason why something is not an actual issue, the reason why it's a false positive, and it will eliminate other findings that must be false positives for the exact same reason. So basically you can identify the root cause, this is not a false positive because this doesn't exist, and it will go and eliminate all of the other cases so that you can narrow down very quickly on the true positive set, the actual bugs that matter to you. In addition to that, because this is integrated into a security platform, once you set up the tools once, you can use any tool that you want. So basically, you only have to perform a single setup. And so if you are using multiple tools, you don't have to do a unique setup for that individual tool. Then, in addition to those features, we also have CI/CD integration. So you do not have to go and run Audit Hub yourself or run any of the tools on Audit Hub yourself. Anytime you push your code or create a PR or something like that, you can have your code committed to Audit Hub and have any of the security-related scans that you have set up run automatically and provide you with feedback. And then finally, if there is something that you don't understand, we have a team of experts who all are very motivated to help you, but also have a lot of knowledge in formal methods to, help you understand anything that might, be unclear. And so if we go back and look at the table that we defined before, really when it comes to tools, it looks a bit more like this, where now the different types of tools that we discussed, we can see are low effort because all of the tools can be used without requiring any additional input from the user. All of them can be run on demand. So for example, and most of them don't take a whole lot of time. So for example, Picus was able to verify a Ketchik precompile in about 13 minutes. All of them, or almost all of them, can be tailored to the specific business logic of your project. And finally, all of the tools come with some security guarantees. And this is something that we don't get from auditing and stuff like that. So you can have, higher confidence in the security of your project before you launch. And so how does this help? Well, basically what it does is it allows you to get security feedback earlier in the development process. So rather than waiting until the very end, you can start by configuring any tools that are relevant to your tech stack. And then as you develop, you can then start to perform any sort of tailoring in order to find those custom vulnerabilities early. And so the reason why this is important is because now you aren't waiting until the very end in order to find vulnerabilities, so you can fix bugs before you build on them. Also, because this does not scale, or the cost of this does not scale with lines of code, it means that now you can include the entire project and you don't have to worry about out-of-scope code. And finally, as I already talked about, we provide more security guarantees or better security guarantees, and it can be customized to your logic. And so if this is interesting to you, or if you'd like to learn more, I would encourage you to visit our website and consider booking a demo. And so this is something that we launched very recently and is currently in beta. And so we currently have some nice incentives for anyone who's interested in this. And yeah, would be happy to talk more. But that is the end of this presentation. So thank you all for listening, and I guess that's it.
Thank you so much, John, for the presentation about Veritice's work in Audit Hub. Next up, we have our second keynote for today from Google Cloud. This keynote is by Vanya, who is Startup Success Manager at Google Cloud. So thank you so much, Vanya.
If everything's okay? It's still not showing up. Yeah.
I'm not sure how to do it because like just connected HTML, but it's just in the main screen.
What if I do this? Still not showing up. Do I need to?
Can I try change the
There's a lot of that. Oh, not you. It's okay, just like keep typing. It's okay. Yeah, it's a lot of policy thingy. Give me 1 second, yeah? Okay. Yes, thank you so much. Oh, good. All right. Okay. Good. Okay. Or you can just click on the second slide. Yeah, this should be okay. Yeah, I think this one is also okay. Yeah. Yeah, it's okay.
No, we actually right now we're
All good? Okay. I just need to show the second slide. Okay, sounds good. Thank you so much. Okay, hello everyone. Thank you so much. Sorry about some technical issues. So I think my colleague has shared about what Google Cloud is in the opening keynote early today. But today, I think in this session, I will cover mostly about what Google Cloud can provide and support for you, especially in terms of funding, to help you build your Web3 projects with Google Cloud. So my name is Eva. I'm coming from the startup team in Google Cloud. Basically, there's a bunch of people in Google Cloud that have focused to nurture and support early stage companies, right? So what we provide is basically we provide funding in terms of Google Cloud credits. So if you are a startup that has not yet received any kind of capital or funding, you actually can get some amount of credits that you can use to build your projects in Google Cloud. And then if you are a startup that has already received any kind of funding from venture capital, or you even do your initial coin offering or token offering, NFT token fundraising, or even receiving foundation grant from blockchain, receiving some foundation grant from a blockchain foundation, you are actually eligible to receive up to 200K Google Cloud credits. So these kind of credits that we offer for the startups. Not only that, we also provide like a technical support for you, or even if you want to have some early access to some of our products, we are also able to help you on that. So I'm just gonna put it right here in case you want to screenshot or you wanna know more about the support that we give for the startups. And then maybe next. This is also a free resources that you can access. So we compile a lot of like some kind of like infrastructure and some products that you can use to build your Web3 projects. It's called Google Cloud Web3 Portal. It's easy to access. It's basically free to access, and you can play around with it. So I think that's all from me. Thank you.
Thank you so much, Eva, for presenting. If anyone has their own startup, wants to get more involved with Google Cloud, be sure to follow the links and connect to Eva as she presented. And right now we will take a couple minutes break, but following this, we will have an interview with Ming from ZKM.
give a big shout out to House of ZK for hosting this event and for doing all the different types of podcast and information things. That's really helpful.
Really excited by what House of ZK is putting together. I think ZK is going to eat the world.
Warm thank you to the House of ZK. I feel like there's a lot of synergy in the missions of the two projects.
One thing I wanted to plug real quick is the House of ZK eProof Summit event, which is happening in Berlin very soon, June 10th. I think it's going to be a fantastic event.
Yeah, thank you.
We've seen a lot on Twitter of House of ZK over the last several months, and we're very excited to finally be on.
Yeah, absolutely. And thank you so much, Shorty, for joining us on our House of ZK podcast. Yeah.
I mean, I was excited for like another dedicated ZK podcast is awesome. Like we need more of this stuff. So guys, awesome job. Thank you for doing this.
So very excited to be.
Oh, it's already working. Great.
All right. Thank you guys so much for sticking in towards the end of this event. This will be, I believe, our last interview before the closing keynote. Right now, we have Ming, who is a co-founder of ZKM. Ming is quite a veteran in the space. He also co-founded a few other projects in the Web3 space as well, including Laz AI. So I wanted this conversation to be focused more on the vision, especially behind ZK, behind AI, and where the convergence lays there.
Yeah.
Thank you so much, Ming.
Thank you, Alice.
Yeah, wondering if we can first start off with an origin story about where ZKM was founded. So what was the reason behind building a new ZK VM in this space? And what types of new applications can ZKM enable, especially for AI?
Yeah, so it's quite simple at first. We're just basically answering Vitalik's call, right? Because he said ZK rollup is the future, and so we're already doing optimistic rollup. The Andromeda network is optimistic rollup based. Metis, that's Metis mainnet called the Andromeda. So ZK rollup is always considered to be the ultimate solution for rollup. Optimistic is fast, fast confirmation time, but ZK rollup is supposed to be having instant, fast finality. Anyway, so we answered the call from Vitalik. At the time, ZK EVM is the way to go because basically EVM is the script engine for smart contracts on Ethereum. So naturally, ZK EVM is the goal, right? But we decided to do a little bit different at the beginning. We opted to do ZK VM, which is to prove a executing trace of a general purpose VM CPU. So we chose MIPS. It's actually MIPS 32R2, which is an open source ISA for MIPS CPU, the legacy CPU. It turns out like we made the right bet. So ZKM is proved to be more universal. And lately, Vitalik is pushing for the inclusion and enshrining of a general purpose VM into Ethereum. So yeah, I'm very glad that's going to happen, and that's the origin of ZKM.
You've had both experience in the optimistic rollup space and then now also transitioning to the ZK, enabling for more ZK rollups as well. And you mentioned at that time, ZK EVMs were a bit more popular, but we've seen over the years that we're becoming, following this trend, following a more general purpose approach. So from the specialized ZK EVMs that are only really targeted for EVM to now ZK VMs that can enable for more general purpose computation even outside of the blockchain-based context. So I wanted to also ask you, where you see the connection between Web3 and AI. You've been involved in the Web3 space for quite a lot of years, even starting from Metis. So I'm curious to hear now with all these AI developments coming up, where you see Web3 and AI intersecting.
Yes. So it's kind of popular for a lot of people to build a solution. They say the fusion of Web3 and AI, but mostly it's just it's the purpose is just to use AI sort of like a fundraising tool. That you build a product, AI product, and then you release a token, and the token could be some kind of like fundraising or incentive for community engagement. That is all fine and well, but that's not like I would consider like a deep integration of AI and Web3. Both are very important technology future. So I think there needs to be a tight integration, natural integration, that is. So Laz AI is the project that focused on a very, I think, not very popular space, which is data. Because traditionally, AI data is about labeling, right? So you need like a labeling of the data for training, and in this space, like there are a lot of good established companies that's already in operation and it's profitable. It's but we think well, actually, people realize that there's a limit in doing that, because labeling data is labor consuming, is very labor intense kind of work, and also it will contain a lot of like low quality data. Even if you hire like a PhD to label your data, they get paid very little, and so naturally they're not like naturally incentivized to provide good quality data and sort of like deep data. And those data are very shallow. So in order to get like high quality, sort of like deep data, you need like a natural social engagement of human interaction. And those are very difficult to label. So labeling is naturally not fit for this kind of data, which is sorely needed if AI to be penetrating in every aspect of our lives, and also deeply engaged in human society, which is very much needed for your alignment, for basically for the just basically for a better future, when many see AI as a threat. So if AI can integrate into our society, we'll have a more harmonious future. But in order to do that, we need data that's not superficial, that's engaging, that's deep. So how to get deep data? In order to get deep data, you need to have human cooperation. And also in order to do that, you need very good incentivization, right? Because labeling, you pay third world country, even PhDs, a couple cents, right? Like it's no good incentive for them to do anything good. So a better way is for natural interaction, and crypto is very much good to incentivize in a fine-tuned way. So that's how Laza is about. We're gonna build deep data suitable for AI consuming in a continuous feedback loop, which the pre-trained LLM of today wouldn't be able to do. And we're also going to provide fine-tuned incentivization to the whole process. This is natural. So nobody is kind of actually labeling data. They're just do their own thing, right? So it's a natural interaction. And we're not going to see data from also a very deeply private, individualized way. We call them point of view data. So in point of view data, everyone can build a world around them and being naturally incentivized to integrate their own world and worldview to a larger society. So they feel very natural to contribute, not being forced, and while still getting incentivized through all the Web3 infrastructure that we built. So this is basically the vision of Labs AI, and also I think this is actually the better way to integrate AI into human life and human society. So yeah, that's the vision, motivation that we start Labs AI.
So the common status quo before was that a lot of the data labeling was very limited, and especially because the people doing so weren't really properly incentivized to. And now for Labs AI, they're trying to redefine a new incentive model. And I'm curious to hear about what were the specific mechanisms for incentives that didn't really work before, that caused incentive misalignment, and what kinds of new models or structures is Labs AI proposing to solve this idea of incentive misalignment?
Yeah, so anything that you have to, if people will get paid to do something, the data is gonna be distorted because they can lie, they can, just for the sake of doing it. So those data are not high quality. In order to be able to incentivize the right way, you need an automatic mechanism. Also, you need data to be not distorted. So being the observer, you cannot be, you can observe, kind of put the observer into the executioner's seat, which will distort data you collected. So observer has to be by the side and also neutral. And in order to do that, I think in the Web3 space, if the data is incentivized by the action itself, not by doing it, doing the interaction to get paid is most important. So the mechanisms will be, we will record the interaction and have a genuine copy of the trace, which is ZK based. That's the connection to the Web3 trend for now. And then those true data can be independently verified by the community. So the community will be one to verify the data is authentic, is truthful, and not distorted. And so those are high quality data that people can trust to use for training or evolving, especially for the reinforcement learning. And that's the way to incentivize in the trustful way.
And transitioning the conversation from the intersection between AI and Web3, I'm very curious to hear about where you see the best applications lying between ZK and AI, that intersection, and where specifically ZK VMs like ZKM can really help to fuel those applications. Are there any specific applications within AI, like say, for example, we have like a lot of projects out there who are working on proving the inference of these AI models using ZK. Are there any particular AI-related applications that ZK VMs like ZKM really shine on?
Yes, I think the one thing that ZK can provide for AI to proving inference or proving any computation is essential if you want to achieve a true decentralized application. And in that regard, the most important aspect of it is the UX. So users usually wouldn't care too much about security, but they care the UX, which is the user experience. And in order to do that, it's the zero-knowledge proof has to be generated really fast. So, and that's a big challenge. I think ZKM developed Xiron, which achieved I think it's first of industry, or like they say around the same time, because our VM is actually harder. Xiron is actually proving the most difficult real-world CPU. It's more complicated than RISC-V, and it's been stable around for decades. So naturally, it's harder but then we were the first to be able to provide real-time proving. So this is a milestone that kind of marks the beginning of real-world ZK integration. And I think this is very important. Doesn't matter which app, because any app that use AK, if the ZK process is slow, then you would be you would have to compromise. Maybe you don't use ZK for every aspect of your app, but with real-time proving, you can. For example, inference, you can't really pick which data are not important. You probably need to through and through, like all the way in. And this, in this regard, you need to have real-time proving, which is, I think, it's a must-have, and it's not possible before. But from now on, this is going to be a huge space. We will see real integration with ZK and AI from now on in a real way, instead of just maybe using ZK a little bit here and there. Yeah.
Got it. So we can see ZK be fully integrated into some different applications.
We'll see an explosion of ZK plus AI applications from now on.
Okay, very exciting time that we're in, and it's great to hear that we're finally ready for this new era, especially with a lot of improvements that a lot of ZK projects are making towards real-time proving. A lot of ZK projects now are specifically trying to do the real-time proving for Ethereum mainnet blocks. And hopefully soon we can even have real-time proving for AI inference as well.
Yeah, right. By zero-time proving, we're actually proving like Ethereal level of blockchain. But we also have rollups. So rollups are infinitely expandable, extensible. So the scheme works now, and so I think with all this tech stack, real-time proving for inference is also going to be a reality, which is very exciting.
Yes, very exciting indeed. And just as a last question, Ming, for anyone in the audience who is interested in developing with LazAI, with ZKM, what are the next steps that they should take, or if there's any kinds of announcements that you'd like to speak about?
Right. I would say that it's the right time to build apps on these tech stacks. I think the only thing lacking is imagination. A lot of problems once considered to be hard or difficult to solve, from before, are actually becoming really easy. You can actually have security, decentralization, and AI inferencing at the same time, which is almost seems impossible just a while ago, but it's possible now. So I call for developers, united to build something that's very exciting on this new tech stack. So right now, we're at the crossroads that the crypto is going to be really different because of these new advancements. So it's a new beginning. Forget about DeFi. Forget about the things you're familiar, because this is going to be something, the crypto from now on, Web3, is going to be very, very different and very, very exciting. So yeah, answer our call. Build a future that matters. Build a future for the harmonious unification of both AI and human. And please do.
Thank you so much, Ming. Really appreciate you scoping back and really diving into the why behind, first, the intersection between AI and Web3, and then also within ZK and AI and the new opportunity space that is over there, and the new types of applications that can be enabled. So thank you so much,
Alice.
Ming.
Yeah, thank you, Alice.多谢。他们在 streaming， 不过我很希望就是有人先拍了，因为这个可能要2星期以后才能。是，对他们比较慢。在群里可以找。
All right, thank you so much, everyone, for coming and for sticking in for the whole day. We had a full day's session worth of different panels, different interviews, different speaking engagements all across the AI space, the ZK space, and then also the intersection between AI and ZK. So we really appreciate all of you for coming here and for really diving into what verifying intelligence really means, especially now that our AI systems are becoming developed and being integrated more fully into our everyday lives. The idea of being able to prove that, for example, a model is behaving correctly or as anticipated or aligned with a user's intent is becoming more and more imperative. So it was very, very fun to explore all of the different applications that are being made within this intersection, and also some of the progress that we've seen over the years, as well as the limitations, barriers that we all need to address as of now. So thank you guys so much for attending. Thank you to Boundless for being the co-sponsor of this event. Thank you to Google Cloud for partnering with us. And thank you as well with the support of all of our sponsors, including Veradice, Ontology, Zero Labs, Laz AI, Gonka AI, and Altlayer. So thank you so much, everyone, and we'll see you next time.
The last spirit will not make it. Okay.
The next chapter of AI should be defined not by how large model is, but how human aligned.
Black box in control of just the hands of a few. Laz AI makes it an intelligent asset, owned by all of us, learning from all of us, governed on-chain, transparent, monetizable, and accountable to human according to human values.
Then the data being trained on a small model by the community is the way to go. So this is, I see the Web3 and AI convergence from all Laz point of view.
Breaking news tonight from Pandaro, where GPT rate limits have been mandated. This is a developing story.
Concerned about fake identities, fraud, or privacy leaks in Web3? Discover Ontology, Web3's trust layer. Trust starts with decentralized identity. OntID uses zero-knowledge proofs to verify credentials without compromising privacy. Power your Web3 journey with Onta Wallet, securely manage assets and identity. With Orange Protocol, leverage ZK-TLS tech to build Web3 reputation. Join Ontology's Web3 revolution.
I do think that we're going to see a lot of infra converge to provable VMs, also known as ZK VMs. Depending on the use cases, they might be adapted, but overall, I think we're going to see a shift from low-level circuits to ZK VMs.
So there's so many things you can squeeze out of ZK, you know, and it just gets better when you combine these other tools.
We can use our knowledge in ZK to build these applications on Bitcoin, which may help Bitcoin make Bitcoin maybe 100% use the only blockchain again in the world, because Bitcoin is the best monetary asset that we have. Bitcoin blockchain is the most secure blockchain that we have.
I will say that the boldest prediction though is, and it's not me making this up, a friend of mine, Vinishri Rao, she's I think a famous cryptographer, you guys probably know her. She's launching a Fermat network, and she's been out there publicly saying that her prediction is that ZK is going to replace blockchain.
You have the code, you have the input, which is all the transactions, and you put that in. You create statements and you generate proofs. There is no component whatsoever of blockchain, but ZK is a component, and this is an example to explain also my thesis that I think ZK will become bigger than blockchain.
shout out to House of ZK for hosting this event and for doing all the different types of podcast and information things. That's really helpful.
Really excited by what House of ZK is putting together. I think ZK is going to eat the world.
Warm thank you to the House of ZK. I feel like there's a lot of synergy in the missions of the two projects.
One thing I wanted to plug real quick is the House of ZK eProof Summit event, which is happening in Berlin very soon, June 10th. I think it's going to be a fantastic event.
Yeah, thank you.
We've seen a lot on Twitter of House of ZK over the last several months, and we're very excited to finally be on.
Yeah, absolutely. And thank you so much, Shorty, for joining us on our House of ZK podcast.
I mean, I was excited for like another dedicated ZK podcast is awesome. Like we need more of this stuff. So guys, awesome job. Thank you for doing this.
So very excited to be here. ZK is one of the topics that actually got me into Ethereum, and it's something that's very close to my heart.
Thank you, Ming, for having me here. Thanks to all the audience, and really great to be here.
And also I want to mention a big thank you to Ben from House of ZK and ZKM for organizing this entire conference. We wouldn't have this without him, so really appreciate his work in here.
If you guys have the magazine that was printed by House of ZK, there's actually a very nice image on the Bob side that actually explains how BitVM works.
This is just a great fun series where we are going to explain ZK in an as intuitive manner as possible.
That wraps up our coverage at NORCON. We're in such a great time to be able to see this transition from theory and research to building real applications.
Thank you.